Today, we are going to talk about MIDI, MSC, OSC, show control for a little bit. We're going to talk about video, and that's the main plan. But before I do that, I was thinking about, as I came in this morning, a couple of things that I alluded to and then skipped over talking about object audio. So I want to conclude and wrap up the object audio discussion briefly and talk about Q objects versus map objects, because I started to talk about those things. Good morning, good morning. You missed only some chit chat there. There's been no actual schooling going on yet. I alluded to and then glossed over Q objects and map objects, and I want to fill in that space. So, if you recall, yesterday, we had this piece of music assigned to this audio cue. In the audio cue, in the Objects tab, we created an object. That object moved around. And with the monitor window for the map open, the object is visible in the monitor. If I use a fade cue to move that object around, we see the object move in real time on the monitor window, in the monitor window. But when the music cue, or the cue named music stops, the object vanishes, because the object that belongs to the cue only really exists while the cue is running. That's something universally true in QLab. When the queue is running, the things that the queue does are part of QLab's business. But when the queue is not running, it is as though there is no such queue. Sort of. But we have another layer of objects available in QLab called map objects. And these objects belong to the map, not to an individual queue. So I'm going to go to Workspace Settings. I'm going to go to Audio Maps, and I'm going to edit, once again, this map. Over on the left, the marks and filters list here is two tabs, has a companion tab next to it, Map Objects. And I'm going to add a map object. Map objects are shown as a little diamond with double letters. For those of you of approximately my age or older who lived in New York City, this is how express subway trains used to be indicated. Subways have their letters or numbers in a circle, but express trains had a diamond with a double letter. So that was, that's just a little fun thing for me. A map object belongs to the map, and we're going to put this map object right there. Now, when we look at the map in the monitor window, that map object is present. It's always present because it belongs to the map and therefore is always with the map. When I take an audio cue and have it use that map, when I do nothing else in the Objects tab, the map object is available as an output. Double A is available here. So if I target some audio, let's see. Been doing all music. Let's try to do something else. Say what? What?
I said rainstorm, but that'd probably be bad.
Well, we can do some rain. Let's do some rain. What did you say?
What latitude?
I thought you said, what an attitude. And I was like, spicy, Chris. All right, we've got some rain here. Yes, Sound Ideas 6036. Good library for rain. We're going to take it out of the Levels tab entirely so that no Levels tab action happens. And in the Objects tab, we're not going to make a Q object. We're just going to assign the rain to to the map object. And now it's raining. If I also created a Q object, or two, those Q objects would be available in this matrix mixer with a gap and then the map object to the right. Did you see that?
No, I'm sorry, I wasn't watching.
I'm running the queue. I added a Q object, and then I decided to delete the Q object. And playback stopped for the queue. But playback keeps going.
I think it's probably because it was being routed to a map object. There's probably a little bug in there about rerouting to map object.
Okay.
I'll follow it.
Now, because the map object belongs to the map and not the queue, I can't select it here. I can't do anything other than route audio to it. If I want to move the map object, no, hang on, let me start again. Because the thing about the map object is any queue that uses the map can route to that map object. So the map object is sort of at a higher level of the hierarchy. Any queue using the map could send audio there, and all those queues' audio would get mapped, would get added together and sent to that object in that location on the map. So here's some rain. And now that you've started me down this path, we'll add a little, this rain thunder queue. Is this the one I think it is? Yes, it is. Yeah. We're going to send that also to the same map object. Okay. But now, if we have, say, some scene music, the scene music, this is not a good fit. It's not the right piece of music to go together. Oh, I didn't loop that. The music has its own object right here. That moves around independently. Whatever. Both queues that go to the map object are sitting still. That map object is unaffected by other queues who come and go. It's unsurprising. But I can move the map object using a fade queue. And this is where we reach back to the beginning of talking about the Basics tab. I've created a fade queue here. And in its Basics tab, instead of targeting queues, I'm going to ask the fade queue to target maps. And when I select map, I then am presented with a list of maps. I'm going to choose this map. And now I get an Objects tab in the fade queue only. And all I can do here is the portion of fade queues, the fade queue that targets the map can do everything a fade queue can do to an object, but nothing else, because there is no other parameter to adjust. Here I can grab object AA, and I can send it around the room. Perhaps slowly, continuously, in an oval, by taking that queue, making a start queue to restart it with a tiny delay, putting the two of those in a start first group, and rolling that. Well, that's way too fast. Let's make that up. There we go. Yeah, anyone got any tea? Yeah. Okay. This fade queue, which moves this object, has no level controls. because there is no inherent level going on with the map object. The map object lives on the map and moves around and just does its own thing, and individual cues can send their level to it. Does that make sense? Some folks, I think, are likely to use map. Like, I have a colleague who prefers using map objects because he likes the idea of an object. I don't want to put words in his mouth, but what it seems like he said is that he prefers the idea of the object having permanence. Little object permanence joke there for you. The object having permanence in the space as though it is a real object. He can predict its location, rather than individual cues objects which are ephemeral, which come and go. So this object loop could keep going indefinitely forever, and individual cues could stop or start and join up or drop off with the object as it spun around the room, right? The key detail to point out then is that if you want to both move a map object and make a level adjustment pertinent to that map object, you need more than one fade. One fade moves the object. Other fades tell cues, hey, you, take your level out of that map object, or up in that map object, or whatever, because the level belongs to the cue, not to the object. Does that make sense? While we're here, it's worth pointing out that the fade cue which targets a map has its own icon type, just to give you, again, a little clue. And while we're there, cycling through target types has a keyboard shortcut, which by default is Option T for target. You cycle through cue, patch, and map. When a fade cue targets a patch, you can select an audio patch, and then it has a levels tab. This levels tab lets you automate the patch routing levels here. So you can fade the actual output matrix of a patch. The main reason you might do this, I can imagine, is to put some kind of control, to give you some control over the main output fader so that you can duck down things, right? Our previously discussed fire emergency, you could be prepared for a less serious emergency, right? You could be prepared for, what if you have a QLab workspace that runs lobby music and you want the house manager to be able to duck that music so that they can holler that the house is open? You could make them a fade cue which ducks down the main level of the patch so that they can then duck that down and say, all right, folks, the house is open, go on in, and then run the fade cue to bring the patch back up. That way, all audio which passes through that patch, regardless of when it starts or what level it's set to, has been ducked because the main level of the patch has been ducked. I also want to point out that this is a pretty easy space to get yourself in trouble because you can duck down the main level of the patch, not notice, not remember, whatever, walk away, have a break, come back, and then say all my cues are wrong, and then program all your new cues really, really loud, and then later realize what you've done and have a lot of disentangling to do. It's not only troublemaking, so that's why we have it, but I just wanted to point out that that's a possibility, because this is a window that may not usually be open. So this main level being out of place may not be visible to you. When you do, if you do fade the main level of the patch, or any level of the patch, it's drawn differently. The box that contains the number is outlined in yellow, and there's a yellow bar inside the fader track, if it's one of these controls up here, that shows its home level. Here's a fade cue with its own special icon showing that it's fading settings, fading a patch rather than a cue or a map. Any control that has been faded will display as with a yellow border, and if it has faders, you'll see a line showing the home value. And the reset button will appear in the tab, which lets you reset that whole tab to its home position. You can also use a reset queue targeting either a patch or a map. When you run a reset queue, it restores everything everything that it's targeting to its home saved level, right? Notice this is something that maybe experienced macOS users recognize, but others may not notice. The traffic lights in the upper left corner of all windows, right? The red one means close the window. The yellow one means minimize the window. The green one means change the window size in a series of complicated ways that Apple has slowly changed over the years without any systemic pattern, design, or logic. The red button, here we see the red button is drawn just a flat red space. But if I make a change to my workspace, basically any change that you can undo, Command-Z undo, notice the red button has a dark dot in the middle. The dark dot, this will happen in all well-behaved macOS applications. The dark dot means a change has been made that needs to be saved or not saved, but it's your choice. Have you ever closed a window and the computer says, do you want to save your changes? The red dot, the dot in the red button is the thing that lets you know that you will be asked, do you want to save your changes? If you Command-S save, the dot goes away. It's a single bit in the metadata of the file. If the bit is a value of 1, it means things have been changed, ask the user to save. If the bit is 0, it means nothing has been changed. You do not need to ask the user to save. I kid you not, the name of that bit is the dirty bit. A workspace that has been changed or any document that has been changed is considered dirty. Saving it cleans it. And I think that the whole reason for that metaphor is so that they can call it the dirty bit, because that sounds like fun to someone. And it made you all chuckle, so I guess they're right. So the reason that I'm pointing all this out, besides esoterica can be fun, is when you make a fade on a level in the workspace, notice the workspace is not dirtied. Changing a level by a fade queue isn't a savable change, right? If I quit and restart QLab and reopen my workspace, this level will not be minus 29.5. It'll be back at home where it belongs. Minus 12, which is what's saved. The home value is saved in the workspace. The result of fades is not saved, is not permanent. It's a passing change, right? I'm just trying to, as many times as possible, without being laborious, re-emphasize saved changes, home values, unsaved changes, ephemeral values, what will go back when you press reset, what won't go back when you press reset. Yeah? Okay. So, map objects and fading. What's your problem? No parameters are set to fade. I found another bug, Chris. When you take a fade queue and target a map and do some stuff, and then retarget that fade to something else, and then return, it thinks nothing's set to change.
Good catch. Thank you.
Until you click in the map. Then it wakes up and realizes you made changes. In the Objects tab.
Minute 24. This one is easier to just say, go to minute 24.
Go to minute 24 and listen to what Sam jabbers about. Okay, great. Yeah? Yeah, so I kind of blew past this, but you were correct to draw me back in and not allow me to hand wave. What I've done here, because someone asked yesterday, can fade queues loop? And they can't, but that seems awfully helpful if they could. I made a fade queue. It auto follows to a start queue, which has a tiny delay on it that start cue restarts the fade cue. And then I put them together in a start first group. When I roll this group, this fade cue will run for its whole duration. Then it'll trip the start cue, which will restart the fade. And this is a really useful technique, right? Unless I do something, this will run forever. And the question is, how do you stop that fade? My recommended way to stop this fade would be to use a stop cue targeting the group. Then the group will be told to stop, which means its children will be told to stop. You could make a stop cue targeting the fade cue, but if you were very unlucky and you ran that stop cue during the 1/10 of a second that the start cue was going, it would have no action, then the start cue would go, and then the fade would restart. So I target the group, which says, everyone in me, whoever you are, whatever you're doing, knock it off. Now, that stop cue would not allow the movement to slow to a halt. And to do that, I'd make a fade cue targeting the group. The fade cue would be relative. The fade cue, no, this is not possible. It's not possible because the fade cue would be targeting the group. The group has no objects. The objects belong to the map. The fade cue cannot target both the group and the map. But you could make the fade cue target the map, tell the map relative fade of this object to some location. No, I don't really know how to do this. I don't know that there's a good way to make it just coast to a halt. Do you?
No.
Yeah.
You mean just do a slow down to...
Wherever you are, slow down and stop. I don't think there's a good method for that. Yeah.
Maybe you explained it. What is the reason that you put in a 1/10 pre-wait on start?
Yeah.
Is that a good idea?
So, because, here we go. Okay. Time is weird. And that's like true. Time in computers is its own other layer of weird. Everything in a computer happens on a schedule. So you can tell the computer, please do this thing as soon as possible, or please do this thing a certain amount of time in the future. I'm glossing over a lot of details. It is, for reasons, it is really hard to know the exact instantaneous atom of time at which moment a cue halts. We can tell a cue to stop, and you can hear it stop if it's an audible cue, or see it stop if it's a visible cue, but there is, after that, a tiny fraction of time down at the computer scale in which the cue is still running after it seems to halt. Like the same way a tape deck back in the day, when you hit stop, it would stop, but then the heads would twist just a little bit more because they had mass and momentum, and so they would just twist a tiny bit more. That's not at all what's going on here, but it's a useful metaphor. If you tell a cue to start during that tiny wind down time, it considers itself still running and won't start. Because cues that are running won't restart. When you tell a cue to start, if it's already running, it's like, I'm running, what do you want from me? Right? The ostensible first lesson of today is the triggers tab, where we talk about a way around that. So stand by for more. But the short version is, when this fade gets to its very end conclusion, we give it a little grace period to be absolutely certain that it's truly and fully stopped before restarting it. My colleague, Ethan, has devised a clever scheme whereby, remember yesterday I was making fun of D&B for me having to lie to the software to make the speaker sound correct? Ethan created a clever way where we lie to QLab about whether a queue is running, where QLab lies to itself and says, well, if it's within this very narrow window at the very end of the queue, it's probably supposed to not be running. So let's pretend it's not running. And that is a little bit of a hack, but when you really spend enough time with computers, you learn that all solutions have some little hack in them somewhere, almost all. And so Ethan's devised this scheme, which we may put into play soon, or we have to really bang on it to make sure it doesn't do something unexpected or untoward. But for now, it doesn't have to be a tenth of a second. I bet a hundredth of a second would do. But you do need to just give it that little buffer to make really sure it's really stopped. And I feel Chris itching to chime in, so I will invite him to do so.
I'm sorry.
No.
You're getting my energy.
Yeah.
Right? Yeah. No. This is annoying, and I'm sorry about it. We were. Yeah. No. It's when Ethan proposed a way to essentially fix this, I was like, why did we let this sit like this for so long? So it's gonna get fixed so that you don't have to add this little extra cheat lie time. And truly, the only reason I think that it wouldn't be right away is we don't want to. It's one of those things that's delicate enough that you want to be careful about when you send it out into the world. So it could be as late as V6 that we change this, just to make sure we don't like mess anything up for anybody in running shows. But this little lie, this tiny little lie, will go away. It is genuinely very true about when you start getting down into the world of clocks, and QLab deals with lots of different clocks in one show. It starts being very mind-bendy, and you have to think real hard about how time works for different clocks who are all pretending to tell you the same time and not. And so it's an interesting rabbit hole to go down. Just going back to the previous question, I think this question about fading a path sort of slowly out is within this cluster of features that I think we're excited to tackle for probably version 6 of like speeding up and slowing down a path and the rate changes on a path and looping paths. And there's sort of a whole cluster of things that now feel very obvious that you would want to do with objects moving on paths, that it was just enough of another batch of work to go, okay, this thing is very helpful. Let's get it out into the world, and then we'll do the next batch of work next.
Yeah. A lot of what's really great about QLab relies on the fact that unlike most other media playback software, QLab does not have one clock to rule them all. If you have cues playing to an audio device, the audio device's clock is in charge of the audio playback for those cues. But if you have other cues playing to another audio device, that audio device's clock is in charge of the timing of the audio for those cues. If you have a video playing to a screen that has no audio related to it, the timing clock of the screen drives the playback of that video cue. And all three of those cues could be playing simultaneously, or groups of cues playing to all three of those devices simultaneously, and you'd have those three clocks in charge of those three sets of cues. Well, let's pretend for a moment that those two audio devices and that screen are all cheap as can be, have the crummiest clock chip in the world, and so the three clocks, we play a 6-hour cue in each of them. By the time we get to the end of those 6 hours, they may be wildly off, right? Because the price difference between the chip that keeps clock well and the chip that keeps clock very well is like a 100x difference in price. To get a clock that loses no more than a second or two in a day is like 20 cents, 25 cents, not bought in bulk. To get one that loses no more or less than 1/10 of a second is like $20 or $30. So it's reasonable to understand that, like, for almost all the time, if you like, some cheap, inexpensive, I don't mean cheap like flimsy, I mean inexpensive, I mean affordable computer monitor, like no one cares about this kind of timing thing over great distances, so it makes no sense to inflate the price dramatically to have a super precise clock in it. Other software says, all right, pick the device in your system that is going to be the clock And then all of your stuff will synchronize to that clock, which is great until you need to play some audio out of this device, some audio out that device. That device doesn't have any way to know about this device's clock, and you get skips and pops on the audio coming out of that device. So one of QLab's big advantages is, just play stuff to places, and the different clocks will do what they do, and everything will sound and look nice, which is true until you get to a place of needing some really detailed, exact synchronization between disparate devices, and then we have to do something complicated to figure out how to make them all agree. And I strongly stand by our design choice to make the common thing, which is just play stuff many places, easy, and the uncommon thing, which is just play stuff many places and also have really, really, really tight sync, make that much more difficult. I think the alternative would be to put shackles on folks who need to do an easy thing easily, and I would rather not do that.
When we get pretty soon to the triggers tab and talk about that, and when Sam talks about the wall trigger, I'll jump in with a little story. And remember this little moment about clocks being weird and shifting time, and I'll tell you a story about wall clock triggers when we get there.
On which topic? Triggers.
Oh, look at that.
So that was the object audio coda, end of object audio lesson, which if I had really been thinking about it, I would have finished yesterday with. Now I will talk about the triggers tab, which I've been putting off all day yesterday because it's great, but also it's sort of a little bit farther down the rabbit hole. It's where I hope you feel you are now. The triggers tab, which exists for every type of queue in QLab, is a powerful tool for subverting the expectation that the show just happens with cues in order linearly, one at a time, or maybe a few at a time, the same order every night. The triggers tab provides a way to do other things. And so we're going to talk about the two sides of the triggers tab. It appears like this. It's got a divider more or less in the middle. Not really middle, but it's got a divider towards the middle. We're going to talk about the left side of the triggers tab first, and the right side of the triggers tab second. The left side is can all fall under the heading ways to get the queue started other than the go button. Okay? The first type of trigger we're going to discuss is a hotkey trigger. A hotkey is a key on the keyboard, the computer keyboard. And it's hot because it's ready to do something at any time. So I've assigned in the triggers tab the number 1 to this queue. And nothing has happened because of it. That's odd. I had to unassign and reassign. It's hard to say what's going on. When you press this 1 on this keyboard, no matter what, no matter where you are in QLab, no matter what's going on, no matter where the playhead is, I'm off here in another queue list, talking about all kinds of stuff, hitting go, 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 and then someone's like, show me that Tigger, quick. And I hit 1, it appears. So if you're doing an oddball piece of theater and the director says to you, I want at any time you to be able to ring a little bell. You can make somewhere in some queue list an audio cue with a little bell, give it a hotkey, and whenever you press the key on your keyboard, that bell will ring. It doesn't move the playhead, it doesn't interact with the playhead, it has nothing to do with anything other than itself. Okay, so that's the hotkey trigger. I should point out that you can add modifiers, so it could be Shift 1, it could be Control 1 or Command 1. But let me encourage you to avoid using Command plus anything in your hotkeys, because Command, the hierarchy of modifier keys in Mac OS for keyboard shortcuts is Command something is the most common hotkey. Command plus Option something is the most common the second most common. Command plus Shift is the third most common. Every hotkey that starts with a control key, Control N, Control O, that's really common in Unix. And so when Apple released Mac OS Mac OS 10.1, they decided, or 10.0 really, they decided we're going to let Control plus something just be the Unix hotkeys that Unix people are used to, which means most of the time, Control plus anything when you're using QLab is available to you. So if you want a hotkey that is more complicated than a single key press, right? Because if I just hit 1 by accident in the middle of my show and Tigger appears, that could be awkward.
That happened yesterday.
Yeah, it did.
I did that on purpose. I was hunting for a button, and I did not do that on purpose. I'm trying to be witty. So you want to maybe make it a little harder. OK, well, let's make it a 2-key thing. I have to have Control and 1. So Control 1 is harder to hit by accident. So that's why there's a reason. That's a reason to use a modifier key. Even Shift 1 is harder to hit by accident, right? So these are just things to think about and consider. It's worth pointing out that on an extended keyboard, the number keys are technically different numbers than the numbers over here. So the number pad on the right side is a separate 1 and 1 are not the same one. And if you are using a keyboard that is not the standard US layout, you are entering a world of confusion. We have tried our best. Apple has tried, I assume, their best. But if you have a different keyboard layout, it can be very challenging to know, like, if I say, oh, left and right bracket is pause and unpause, right? I said that yesterday. To start with, Brits don't use the word bracket to mean that symbol. Let's just start with that. The curly ones that we call braces or curly brackets, that's a bracket, I think, to a Brit. Or maybe a parentheses are brackets to a Brit. Anyway, it doesn't matter. Braces are what hold up your trousers in Great Britain. But to us, braces are the curly things that surround numbers. But that's even entirely separate from the fact that these two buttons on a UK keyboard are not these symbols. So what are you supposed to do in Great Britain to pause and unpause? Are you supposed to press the buttons that are to the right of the letter P? Or are you supposed to go find wherever the square brackets are and press those buttons? And I don't actually immediately know how to answer that question, because every time I confidently say you do this, it turns out it's something else. And I once read a long, very dry paper on why this is actually a very difficult problem to solve. I'm not going to subject you to it. But the short answer is, if you're listening to this or watching this video later, and you see me refer to any keyboard shortcut, I'm using a US keyboard layout. And if you're using a different keyboard layout, I encourage you to experiment in a low-risk scenario to find where the key really is on your keyboard. And then tell me about it. And if you're using especially a French keyboard layout, I wish you luck, because I have found that French keyboard layout and QLab are as far apart from comfortable as I have gotten when I was doing a show in France.
A user on the chat says, in Germany, we don't even have the brackets printed on Apple keyboards at all.
Sure. I guess Germans are bracket averse, is the Apple's assumption?
I wouldn't dare to guess.
Yeah. Well, I'm sure Apple's wrong about that. It seems like ordering of things and putting things in sections feels very, seems like it'd be right up their alley. The Grand MA lighting consoles made by a German company, it is a very logical, rational, sophisticated piece of machinery. All right, moving right along before I get myself in terrible hot water. The next kind of trigger to talk about is the MIDI trigger. MIDI, which stands for Musical Instrument Digital Interface, is a very, very old standard. It was devised by Yamaha and Roland and a couple of other manufacturers of electronic music making equipment in the 60s, so that devices that were made by different companies could interoperate without the companies having to every single time saying, hey, I'm selling a new synthesizer starting on Thursday. These are the signals that will make it do stuff if you want to make a controller that talks to it. Or no, we'll just support MIDI, which will be a standard that we all agree on. MIDI was engineered to be inexpensive to implement, reliable and predictable. And it has proven to be exactly that for decades and decades. It's not the most flexible in the world, but it turns out that it is sufficiently flexible for most cases. So QLab has good, strong MIDI support. In the Triggers tab, you can check the little box and accept a MIDI message of any of these types: note on, note off, program change, control change, key pressure, channel pressure. You might ask, how did we select those 6 messages as the 6 messages to allow for MIDI triggers? And the answer is, we guessed, and we figured that if anyone wanted to use a different type of message, they would write to us and ask, and no one ever has. But if you want to use a different type of message, please let us know. It is easy to add. We would do it, probably. Or you can just click Capture and then press a key on your MIDI device, and it will capture the incoming MIDI message. The note number is captured here if you've got a note on message. The note velocity is captured there. If you're using something like a control change message, then that's the control number and that's the value. The velocity message has some tricks. It can use greater than or less than. So if you have a velocity sensitive keyboard and you type greater than 50, if you just tap the key, it won't trigger. But if you hit it harder than 50, it will trigger. It can also do less than. So you could have 2 cues that both accept a trigger. One captures any hits of the key with a velocity of less than 50, the other with a velocity of greater than 50. And then you would discover how often you manage to hit the key at exactly velocity 50 and get no cues at all. Or you can also do velocity any. I want to warn you a little bit about this because the correct behavior of a MIDI device is to send a note on with a velocity when you press the key, and then ideally a note off with the matching velocity when you release the key. But it is an accepted standard behavior, though it is not, I think, technically correct. It is widely accepted that a note on with velocity 0 is also okay to send when you let go of the button. And indeed, that's what this device does. So note on velocity something when you press, note on velocity 0 when you release. So that means that when you use velocity any, you will get 2 triggers. So if the cue is very brief and you hold the key down long enough, you could get bing, bing if you use velocity any. So for that reason, when I use a velocity sensitive keyboard, I usually type greater than 0 as my velocity message so that you can hit the key as hard as you like or as softly as you like. You'll get 1 message, but when you let go of the key, the velocity 0 message will not be received as a trigger. Does that make sense? Yeah.
So just to clarify, that velocity parameter is I will trigger when I receive this exact velocity. So if you had it set to 127, that would only trigger when you slammed on that key.
Yes.
Anything less than absolute max, it wouldn't trigger.
That's correct. This MIDI device is not velocity sensitive. So no matter how hard I press the key, well, there's only 2 possibilities, right? One is I hit the key and it produces a velocity of 127. One is I hit the key much too hard and I break the controller. So yeah, velocity 127 exactly is only useful when you don't have a velocity sensitive device, as I do here. The wall clock trigger should explain the little ping that you heard while I was in the middle of talking about something else yesterday at 6 minutes to 4 p.m. The wall clock trigger triggers a cue at a specific time of day. So it's 9:46 a.m. right now. I'm going to go to 9:47 and 0 a.m. And at some point I was going to say at some point within the next sentence, 9:47 rolls around and we hear that ping, right? This time of day is hours, minutes, seconds, AM or PM, or you can use a 24-hour clock. And then this button, every day, lets you choose days of the week to turn on or off for this trigger. So you can have a cue that triggers at 9:47 AM only on Monday, Wednesday, Friday, or whatever you like. I've used wall clock triggers for pre-show announcements when I'm on, I beg your pardon, when I was an operator on a show where I was required to be in the booth at half hour to trigger the cue that plays an announcement in the lobby, welcoming people into the audience. Simultaneously, I was needed backstage to put wireless microphones on the children in the show who were not being entrusted to mic themselves. And while I sort of stamped my feet about needing an A2 on the show, my producer laughed in my face, and so I programmed the pre-show announcement with wall clock triggers. Right, so at half hour every day, the pre-show announcement ran by itself while I was backstage putting the mics on the children. But of course, on Thursday our show is a half an hour earlier, so I unticked the box for Thursday on the main pre-show announcement, then made a copy of that cue, gave it a half an hour earlier trigger time, and ticked the box only for Thursday. But then, of course, on Sunday we also had a matinee, so I made another copy. Blah 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 blah. There are folks who use QLab to play ambient music in a theme park. I never remember what theme park, but they have just huge numbers of wall clock cues in their show, because this time of day is when the something pavilion opens, and that time of day is when the what do you call it thing happens, and that time of day is when we're going to be closing soon and you should really make your way towards the exit, stuff like that. So they have just piles and piles of wall clock triggers, and it works beautifully for them. One thing that is worth noting is that there is a vagary in the way that the macOS reports time to software. And to my understanding, it is not able to be clear when you will receive, a second has a duration, right? Is the 9:47 and 00 going to trigger right at the beginning of 9:47 and 0 seconds? Or is it going to trigger just before 9:47 and 1 second? And the answer is that the way that macOS reports time to us, it's going to happen sometime within that second. So there's a small amount of slop which you need to accept if you're going to use wall clock triggers. Additionally, pursuant to my earlier conversation about clock chips, the internal clock on a Mac is pretty good, but if you don't let the Mac connect to the internet, the clock will drift by as many as several seconds in a day. So if you're using wall clock triggers and you're using a Mac that is offline, you're going to want to routinely check the time, I'd say once every couple of days, just to make sure that it's still accurate. And that amount of drift is sort of normal. If the clock on your Mac is routinely resetting itself dramatically, more than a few seconds a day, that means that there's a physical problem going on and you should get that Mac looked at. If the Mac is online, it will automatically set its time using a time server and you don't have to worry about it. And you had something to say about time?
Yeah, you actually covered it pretty well. So,
great.
So I'll be faster than I otherwise would have been. But so the wall clock trigger, this is enough of a story that'll come up. The wall clock trigger was introduced in version 1. The reason it was introduced is kind of fun. I got an email from someone in Germany, as it turns out, the theme for the morning, who was building a show, and the show was being hosted inside inside a submarine bunker, which from World War II. And so the rooms that people were going to be in had walls between them, and those walls were 6 feet of concrete. So they had different events happening in different rooms that they needed to roughly coordinate, and there was no way to connect those computers together in any way through 6 feet of concrete. So they said, well, can I trigger it off the clock, and we can get basic coordination? So that's why wall clock triggers were added. But I didn't know at that time everything that Sam just taught you about the fact that clocks drift as much as they do. And back then, I think it probably was even a little bit worse. So I would set a clock when I was testing, and it would go off at the time I expected, and I thought, great, I sent it out into the world, it worked for this submarine bunker, huzzah, the feature's done, we move on with our lives. And I started getting messages back from people who are using it in different circumstances saying, it's not triggering when I set it to trigger. It's 4 minutes late, or it's a different time of day entirely, and I was very worried and confused because it was working just fine for me. So these clocks drift different amounts for different computers. So what is actually happening in there now is that QLab is actually scheduling it once every minute, and it checks every single minute for each wall clock trigger. Is it going to happen within the next minute? If so, the clock is not going to drift that much within a minute. Otherwise, if I'm online, I'm going to ask, what the heck time is it? And recalibrate myself once a minute until this thing happens. Because otherwise, as Sam said, these clocks can drift a remarkably surprising amount, and differently depending on the computer, because the electronics in there just are physically behaving differently. So this gets back to this strange, clocks are weird.
Clocks are weird.
Time is strange. Don't make big assumptions without checking them.
And I want to draw a distinction. Clocks are weird and time is strange. Both of those things are true, and they're not actually related. Time is strange, just time. I don't mean how we keep track of time. It's strange that time goes differently when you're moving fast and when you're moving slow. That's strange. But it's also strange that keeping track of time is a mechanical challenge. Older Macs had a little rechargeable battery in them that would recharge routinely when the Mac was connected to power and switched on, that would keep the clock running when the Mac was switched off. Newer Macs use some other method, I think, that is not literally a battery in a little battery holder on the PCB. I think it's a different sort of charge holding device, maybe a capacitor, or maybe it's a battery but it's soldered on, or I'm not really sure. But also, part of what's different is that it is no longer our recommendation necessarily that your Mac is kept offline when you're using QLab. Keeping your Mac connected to the internet all the time for a show computer used to be considered a definite no-no, and I just don't feel that way anymore. Instead, let your Mac be online, I don't care. Just make sure you don't have any ill-behaved software on your computer, and if you're not really sure what that means, if it's made by Adobe or Google, and then you're okay. And by which I mean, without being snippy, Adobe's background update checking software is, shall we say, assertive. Google's background checking software is both assertive and needy and verbose. So if Google's auto updater can't get to the internet, it tries again in 5 seconds, and then again in 5 seconds. And then every time it doesn't work, it logs a big, long message stamping its feet saying, I tried to update Chrome and I could not. And it was exactly this time and I don't like it at all. And then it would do that every 5 seconds and then every 1 second. And so keep Chrome off your computer for a lot of reasons, in my opinion. Mostly because it sucks your battery dry, but also because its auto updater is a real complainer. Or use Chrome and just ask it not to auto update, which is also fine. Adobe's auto updater, just very, very aggressive, always checking. Would you like to install Bridge? Do you know what Bridge is? What is Bridge? What's a bridge? I'm just making photographs, leave me alone with your Bridge. But Bridge needs to update, on and on and on and on. Nowadays, most internet connections are pretty fast. Most software, even complaining software, just sort of says, do I need an update? No, I don't. Great, moving on. And QLab's ability to sort of do what it does. Again, we've been talking many times about how fast these computers are getting. QLab's ability to get what it needs done with the available resources given to it by a very powerful Mac stays the same as the Mac gets faster. So more of those background, am I ready to update or do I need to do something messages, more of those things can be tolerated because there's more processing power available and because the average speed of internet connections is up. So it's just not such a big deal anymore. Also, Apple's been very aggressive about security practices, and most of the time that's annoying because you get asked if you're sure that you want to allow this microphone to be, are you sure you want to allow your recording audio recording software to use the microphone? Well, that's kind of why I bought it, pal. But that those security practices do have an upside, and the upside is it's much less likely that something is going to just bomb your show simply because your Mac is online. Okay, the next type of trigger is a timecode trigger. Timecode is a technology that was invented for keeping film cameras and audio recorders synchronized on a film set so that the editing process would be easier later. And then, because theme parks tended to be opened by film people, like Universal Studios and Disney World and so forth, it was the film people who had to figure out, how do I get this airplane model to go down this ramp, fly towards the audience, land in this pool of water at the exact same time that the actor is exiting here and a sound effect is happening and the lights are focusing on that. And this is the Waterworld installation at Universal Studios, I believe. And how do I have all these things happen in perfect sync and do it 6 times a day, every day, forever? And they figured, timecode, let's use timecode. We know about timecode. Timecode works perfectly on our film sets. It'll work perfectly here. And the truth is that timecode is a really useful tool for synchronizing events, and it's used commonly in live events. And it is my position that it is most of the time okay and seldom ideal. It's really good for keeping your tape recorder and your film camera in sync. But most live events aren't on a rigid timeline. Most live events have some flex or want to have some flex. I did a show for a cruise ship, and the standard behavior in cruise ships is the whole show is, as they say, on rails. So it's a half-an-hour show. You press go, and then 30 minutes later, curtain call. And that's it. And timecode drives the whole thing. But I was doing a show that, I didn't know this at the time, apparently this is uncommon, that the script for the show was genuinely funny. And as a consequence, we had laughs, which we wanted to hold for. And so, because I'm a QLab person, and I was the new guy in the group, I was like, why don't we just freeze timecode during the book scenes and then pick it back up for the next song? And everyone was like, you are a crazy person. How will that work? And I was like, why don't you all just let me try it? And we did that. We ran timecode for the song, and then we held timecode. There were no light cues, there was no video changes. They did the book scene, people laughed, sometimes it was long, sometimes it was short. And then as soon as the laugh was done and the guy turned to start the next song, we hit go again, timecode picked up again, everything synced up, and we had more cues for the next song. And it worked really well. It worked, so in my opinion, timecode in bursts with gaps is kind of the best of both worlds. I'll leave the further discussion to people's choice whether they want to talk about it or not. But in summary, QLab both can receive and transmit timecode in 2 forms. We accept LTC, linear timecode, often called SMPTE by film people. And we also accept and transmit MIDI timecode, also MTC, which is also like calling time LTC SMPTE is like, it's like calling my MacBook Pro an Apple. Like Apple is the company, the MacBook Pro is the model. SMPTE is the organization, the Society of Motion Picture Technicians and Engineers, that devised and sort of maintains the standard for timecode. So LTC is the timecode. SMPTE is the governing body that is in charge of timecode. So it's not false that it's SMPTE, but it's also not accurate because also like some guy who works at SMPTE is also SMPTE. So is this timecode Steve? I don't know. MIDI timecode and linear timecode are more or less equal. MIDI timecode is inferior for a lot of reasons. The first one is that the electrical distribution of MIDI signals is more challenging than the distribution of audio signals. The second reason is that many MIDI interfaces use a buffer that is too small to fully capture a frame of MIDI timecode. So some perfectly functional MIDI interfaces for all other purposes will freeze up when timecode comes or goes. So then the third reason that MIDI timecode is inferior is that it's a format referred to as a quarter frame format, which means basically you get a frame of timecode that says we're here. and then you get 3 messages that are like 2, 3, 4, and then we're here. You get a full frame that tells you everything about what time you're at, and then you get 3 more messages that are like 2, 3, 4. You know, if someone conducts and they count 1, 2, 3, 4, 2, 2, 3, 4, 3, 2, 3, 4. But if you're not paying attention and you only listen when they're going 2, 3, 4, you might say, what measure are we on? Like 47, 2, 3. Oh, we're on 47. Great, good. MIDI timecode's like that. So if you happen to start listening during the 2, 3, 4, you're lost for almost a second until you get the next big frame. So that's the third reason that MIDI timecode is inferior. That said, people use it, so whatever. To use a timecode trigger for QLab, you first have to go to the queue list that the queue you wish to trigger is within and enable incoming timecode for the whole list. This is like the big Igor switch to turn on for incoming timecode for the queue list. Once you turn on timecode incoming for the queue list, you have to make a bunch of choices. I'm going to hold off on describing these choices until at least one person, either in the chat or in the room, asks me to go into them in detail. Sometimes no one wants it, and it's just a waste of everyone's energy. So for now, I will simply say, does the list listen for MTC? In which case, what MIDI device do I listen to? Or does it listen to LTC? In which case, which audio device do I listen to? And which channel on that audio device is receiving the signal? And once timecode is turned on, forget about all the rest of this stuff for now, blah, blah, blah. You can then go to an individual queue within that queue list, enable a timecode trigger, enter a timecode, or click capture to stamp an incoming frame of timecode and say, at that moment is when I want this queue to trigger. And then when that frame of timecode comes in, the queue will start. Questions? I will give one cautionary tale about timecode, which is these numbers, right? Hours, minutes, seconds, frames, or reals, minutes, seconds, frames, doesn't matter. If you don't start at hour 1 and instead start at hour 0, sometimes weird stuff happens with older equipment. It's the shortest version of that warning I can give. So that's the end. Again, we'll talk more if anyone wants to talk more. Okay, that is the conclusion of the left side of the timecode tab. That's 4 ways to get a queue to start that isn't putting the playhead on that queue and hitting go. All of them happen at any time when the workspace is open. None of them move the playhead or have any effect on the playhead. None of them care which queue list you're looking at or are active. So all of them can be considered just sort of hot at any time, ready to rock. Does that make sense? Great. The right side of the timecode tab is 3 categories of things, that pertain to behavior of the queue while it's running, or when it starts. The first is fade and stop. You can set a queue to fade and stop other queues when it starts. So this queue can be told, when I go, you all stop. It can fade and stop queues at one of 3 levels of QLab's hierarchy. It can fade and stop its peers, which are all the queues that are at the same hierarchical sorting level as that queue in the same group. Or it can fade and stop list all the queues in the same queue list. Or it can fade and stop all the queues in the same workspace. We're going to do peers, which means that these queues inside this group are all going to be each other's peers. But this is not a peer because it's outside the group. If I took these 2 queues and put them in a group, that queue, and that queue, and that queue are peers, but these 2 are not peers of these 2, right? Because they're in another layer. These 2 are peers of each other. These 2 are peers of each other. Yeah? Okay, great. When you have a cue set to fade and stop peers, you can also give it a time for the fading to take place. So it's kind of like a special kind of panic. And when you fade and stop peers, one cue goes, the next cue that goes fades and stops the first. Then the next fades and stops the next, and the next fades and stops the other. Fade and stop peers is your friend when you're making slideshows. It is your friend. Yeah? The next option is duck or boost others. So here's a piece of music. This music is playing at whatever level I programmed. This next piece of audio has duck audio checked. It's set to duck by -12 over time 1. When I hit go on this cue, all the other cues in the same list will have their level ducked by 12 dB over a 1-second fade. And then when this cue ends, the level will be restored. So I hit go.
Well, good day, ladies and gentlemen.
The pilot comes on.
We're level at our
The music's ducked down.
so I'm going to turn off the seatbelt sign at this time.
And when the cue ends, the level restores. It needn't be an audio cue that causes the ducking, right? So we could have our pre-show music playing, and then I could have a slide that plays, and when the slide comes up, the music ducks. If you put a positive level in there instead of a negative level, it will boost level instead of duck. I'm not really sure why you'd want that, but we can do it. If you come up with a good use of boosting audio while a cue is playing, I would love to hear about it. The last option on the right is called if running a second trigger ... So the default behavior of a cue when it is running, if it is told to run again, is to ignore that instruction, right? I'm already running, leave me alone. But you can ask a cue to behave differently than that, and I'm using hotkeys 2 through 7 on my keyboard to demonstrate this. Hotkey 2 is for this cue, which is set to if running second trigger panics. So this cue is running. If it gets another signal to go, it panics itself. Now that's true no matter how it's told to go. So I use the go button. Now I'm going to use the go button again. Now I'm going to use the go button, but now use hotkey. Right? This cue, if it receives the signal to start, no matter how, while it is already running, it panics. This cue is set if running a second trigger stops. And the reason there's reverb on this is because I want to explain the difference between a stop. I caused it to stop and the reverb continued to go. Ooh. And you see in the status column, there's a little slopey line. That's fading out. The reverb is doing its thing. This cue is set to hard stop, not just stop. Same reverb, but when I give it its second trigger, it stops dead and the reverb stops dead. So hard stop means stop and also stop your effects or whatever else is going on. Really, really stop, stop, stop. Whereas just stop allows the reverb to ring out. And panic fades out and stops. Hotkey 5, to me, is the most fun. Hard stop and restart. This is where we get into sampler territory, right? When you trigger a cue with hard stop and restart while it is running, it just stops and restarts. So, loop of object map fading, if I set this cue to second trigger hard stops and restarts, then I don't need that pre-wait, right? because even if the queue is still running when the start queue tells it to go, it will hard stop and restart itself. But my habit of the small pre-wait is ingrained from before we had the hard stop and restart trigger option. This next one, I'm going to use a MIDI message to demonstrate, because this next one is called, this next one has to do with this checkbox below, which is a second trigger on release. Hotkey MIDI note. So when I press this hotkey, this MIDI message, I'm sending MIDI note 9, velocity 127 to start this queue. And I have if running second trigger set to panic, and I have this checkbox checked, which will listen for the release of the MIDI message, which is a velocity 0. QLab knows about the velocity 127, velocity 0 pair, or the velocity something and velocity 0 pair. And so a MIDI trigger will start the queue, and then listening for the 0 velocity release will panic the queue or do the second trigger action. It also works on the keyboard. I'm now holding down the number 6 on the keyboard, and when I let go of 6, that's because that checkbox is checked. That will also work. It also works in carts, which we haven't talked about yet, so there's this inevitable thing where you have to teach something before you teach something else, and we'll get to carts. Yeah?
So to reiterate, go back a little bit, so that any cues with a trigger will still go when if the playhead lands on it, though, you hit go, right? Is that correct?
Unless it's already running.
Unless it's already running. So then, would you say a practice, if you have a bunch of cues that you really only want to activate with triggers, you would put them in like a separate list or something? So
You're saying you want cues that will never be triggered by the go button?
Right.
Yeah. I always put those in a second list so that there's no possibility of the operator accidentally running them. Sometimes I have all my show cues here, and then I have like several memo cues, and then below that I have a bunch of stuff. So that only if they got to the end of the show and then hit go 8 more times could they get to those cues. That's just, to prevent me from flipping back and forth between different pages. But usually I put them in a separate list. I worked on a show, I was the associate on a show called Kung Fu, which is was about Bruce Lee. And the finale of Act 1 was filming an episode of The Green Hornet, which is a super fun scene. And while we were rehearsing, we didn't have the fight choreos set. So we set up our operator with a MIDI keyboard, triggering a playlist full, not a playlist, a cue list full of punches and kicks and things. And so he could just watch Bruce, and every time he did something, he played the piano. And it absolutely worked beautifully. And that was all in a separate cue list from his cue list of regular show cues, so that he didn't have to worry about where the playhead was or what was what. The next option for the second trigger is a second trigger devamps. So here I have a cue with a looping first slice, infinitely looping first slice. When this cue is triggered again, it devamps and exits its loop. Just another useful tool, another way to get out of a vamp, right? I went to the Triggers tab, and I chose, if running, a second trigger devamps. Next, here's there are 2 playlist-only options for second triggers. And what they do is make use of a quality of playlist groups, which is that when playlist groups contain a cue that has an unknown or infinite duration, the playlist can't advance, right? Because this cue has no time. This cue is just going to be up until we stop it. So I've set hotkey 8 to trigger the playlist. And I've set the playlist to, if running, a second trigger plays next. So now every time I hit hotkey 8, I get the next trigger. Yep. I can also set it to play previous. So hotkey 9 does playing the previous. I'm not really sure what that's good for, but it was difficult for us to imagine all the scenarios, so we figured let's just let it be and we'll have that option in there and people might use it. I'm sorry?
That'd be good for like a slideshow maybe?
If you want.
Like playing the previous one?
Yeah, I guess if the slideshow does automatically advance, but I want to be able to jump back one, I could use that. I don't really know. I can't think of a design scenario where that would actually be a choice I want to make, but I'm thinking. Anyway, that's the Triggers tab. Things to make the queue go, things to tell you what happens when the queue is going. It's a little bit of a mishmash, but a lot of powerful stuff in here. And I want to call your attention once more to the Workspace status window, which we looked at briefly when we were talking about warnings. The Triggers tab of the Workspace status window lists all triggers, hotkeys, timecode, MIDI, or workspace-wide messages, workspace-wide keyboard shortcuts, excuse me, that are set for the whole workspace. So if you set up a hotkey trigger, for example, and when you hit it, 2 different sounds play, and that was not your plan, you can go to the Triggers tab of the Workspace status window and find your trigger here, your hotkey, and say, oh, look, I have 2 different cues set to hotkey 8. Now I know that. Let me go fix that. You can get to the Workspace status window by clicking this emergency icon if it exists, but you can also go to the Window menu and choose Workspace status. And the Triggers tab can be sorted by different columns. So you can sort alphabetically by target, alphabetically by trigger, or alphabetically by type. And that's the Triggers tab. Yeah.
Can it be for video as well?
Absolutely. Any queue, all of what we just talked about works for any queue in QLab. Alrighty. It's just slightly earlier than I would naturally take a restroom break, but the next topic is not easily interrupted. So I think let's take 8 minutes and come back and resume with MIDI, MSC, timecode, and show control. Thank you. Aaron, I'm going to turn my microphone off. All right, folks, how you all doing? It's time to talk about alphabet soup. At the beginning of yesterday, I described QLab as being media playback and show control for live events. My friend John Huntington, who wrote the book on show control, which I believe is entitled Show Control Networks for Theaters, which is a fantastic book, and I highly recommend it. He defined show control as any time devices belonging to one department communicate with devices belonging to another department. And I'm sure I'm misquoting him, but I'm paraphrasing. And that works well enough for me, more than well enough, in fact. Show control has become so prevalent that I find it in some form on almost every show I do. And it's as little a thing as, listen, for this one cue, we really just want lights and sound to synchronize just right. So can lights please send a MIDI message to sound to trip that doorbell when lights up the little doorbell light, on the set, or whatever it is. I often, as a matter of course, specify, when I'm putting together sound systems, specify interlink equipment to attach to the lighting department, even if the designer I'm working for hasn't even said it once, or the lighting designer hasn't talked about it either. It's just something to be ready for. So QLab is as good a show control citizen as we can make it. We both send and receive messages according to all those letters. And I'm going to go through them briefly so that we can understand how. The MIDI messages are sent by a MIDI cue, which is right here, using the old school 5-pin DIN port as an icon. A MIDI cue has 3 tabs: Basics, which you know about, Triggers, which you're now expert in, and the Settings tab. And the first setting to choose for a MIDI cue is a MIDI patch, which is like any other, just like an audio cue, a patch is the way that a cue connects to a device. So I'm going to go into Workspace Settings to MIDI and look at MIDI outputs, because we have 2 MIDI patches in this workspace. One is named IAC, and that's connected to bus 1 or whatever, a disconnected MIDI device, doesn't matter. The other is named a MIDI device, and it is connected to this Go box, which can receive MIDI. And by virtue of being able to receive MIDI, the Go box tells the Mac, here I am and I can receive MIDI. And the Mac tells QLab, here's a list of all the MIDI receiving devices attached. And so it appears on that list. Those are all the settings for MIDI patches. But because this list looks somewhat like this list, it's worth pointing out a couple of other things that patches can do. Notably, all of the things I'm about to describe work in MIDI patches, network patches, video outputs, stages, we call them, audio patches, and that's it. You can hold down the Option key to drag and duplicate. You can reorder. If you make a new workspace, you can open the workspace settings for that workspace and drag patches between to copy them. You can also select patches, one or all, or several, and drag them out of QLab into the Finder, and QLab will create a settings file with the name of your workspace, MIDI outputs, and 3 items saying, hey, you just put 3 MIDI patches into the settings file. That settings file can then be dragged into a new blank workspace or any other existing workspace, and those patches come with. And that works for MIDI patches, network patches, audio patches, video patches, yeah? But I wanted to demonstrate them with MIDI because it's the least settings available, so it's the cleanest interface, so it's easiest to look at. So we have a MIDI patch selected here, and that's the MIDI device that will receive the message from the queue. Then we choose message type. MIDI queues can send one of three types of messages. There's MIDI voice messages, there's MIDI show control messages, MSC, and there's MIDI system exclusive messages, abbreviated to SysX. We'll start with MIDI voice messages and get through the others shortly, so don't worry. QLab can send any of these types of messages: note on, note off, program change, control change, key pressure, which is also called aftertouch, channel pressure, and pitch bend change. And again, that is a list drawn from the official list of MIDI message types, which we thought were the most common MIDI messages. I think one of these got added after the initial invention of the MIDI queue, maybe two tops. But again, we await your instruction. If there is a MIDI message type, if you're like, man, I really need to use the breath control, great, let us know. We'll put it in there. It's not a big deal to add it, but we didn't want this list to be long and unwieldy for no reason. Depending on what type of command you've chosen, the attributes that are pertinent to that command will appear below. So here's a note on message. It sends on MIDI channel 1. We're sending note number 1 with a velocity of 0. If I send a pitch bend, it needs a channel and a value. And because pitch bend can send, is the kind of message that might want to vary over time, some MIDI messages are fadeable. So you can check the box and fade over duration from this value to this value over this time using this curve. The MIDI system exclusive message, to explain what that is, I need to just do a little history. The folks in the 60s invented MIDI, and they said, all right, we're going to have a set of messages that everyone understands: note on, note off, control change, program change, aftertouch, etc. There were a bunch of them. There's more. But then they thought, well, we don't know what the future will hold. So we think that it would be cool for every manufacturer of MIDI gear or MIDI compliant gear to have a set of messages that is exclusive just to them. We will call them system exclusive messages. And anyone who joins the MIDI consortium can apply for a MIDI system exclusive code, and then they get to have all the messages that start with that code belong to them. It's not very expensive to join the MIDI consortium. It's some amount of money. And when you join the consortium, you can get a system exclusive message. And for a little while, that seemed like a very useful thing to do. So for example, this message is, as far as I can recall, this message is the message that you send to a Yamaha DM1000 mixing console to bring the fader on input channel 4 to like 75% of fader travel. I think that's what it is. 43 says the following is belongs to Yamaha. 10.3e, I think, says this is a message meant for the DM1000. 04 means input channel 4. 30.000C means 75% of the fader travel. I can never remember what the 09 means as much as I can remember any of this stuff. And then all system exclusive messages need to start with an F0 and end with an F7. But QLab fills those in for you. You may wonder, why is it written in this arcane way? And that is because in their infinite wisdom, the MIDI people decided we will use hexadecimal base to communicate MIDI messages. Hexadecimal is base 16. So the valid digits in hexadecimal are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. 10 comes next, right? In base 10, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the single-digit numbers. And 10 is the first two-digit number. In hexadecimal, it's 0 through F is all the one-digit numbers. It's not super important, but this is the way that you write it out. System exclusive is one of those things that you do not need until you need, and when you need, often there's no other way. Before OSC was invented, this was the way you controlled complicated stuff via MIDI. After OSC was invented, this is still the way you control complicated stuff via MIDI, but reasonable manufacturers have moved on to use something that's a little more human readable. Yeah.
I have a question from the chat.
Oh,
which
yes.
Is what would be a possible, preferably simple solution to create a set of predefined MIDI messages that can easily be recalled during the show? For example, for sending fader control to a mixer.
Yeah. I mean, my short answer is it would be better if you can use a mixer that accepts OSC. But here's what I do. I have a program that I'm a fan of called MIDI Monitor, which might be on this Mac or might not, is not. Okay, no problem. I'm going to install it real quick. MIDI Monitor is a free piece of software. Yes, allow, download, get the thing, do the thing. Is a free program which lets you monitor incoming MIDI messages. And when MIDI Monitor, yes, I'm really sure I want to open it. Yeah. Sorry, fumbling my mouse. Bye. MIDI Monitor is a free piece of software which lets you monitor incoming MIDI messages. When you open MIDI Monitor, it will show you all the MIDI sources that are available, and one of them, hopefully, is your mixer. With it open, this works with the DM1000. I don't know if it works with every mixer. You want to configure the mixer to both send and receive MIDI messages when your faders move. Grab the console, grab the fader you want, and move it to the level that you want, and you will see a stream of MIDI messages come blasting in. The very last message is the message you're interested in capturing, because the very last message is the message that says, get to this spot on the fader, right? Because that blast of messages that comes in as you move the fader is, go to here, now go to here, now go to here, now go to here, now go to here. That last message, you can copy it and paste it into a MIDI sysx queue, being sure to delete the leading F0 and the tailing F7 because QLab fills those in automatically for you. If your mixer doesn't send MIDI system exclusive messages when you move faders, this is going to be a lot harder. But that is my recommended method. My real recommended method is to use a console that can communicate using OSC or that allows you to store a series of presets on the console and just use simple MIDI messages like a MIDI note or a program change message to recall the preset of your choice.
Thank you.
Thank you.
And while I've interrupted you already, could you double check that your screen capture outputs are running? We just were, I don't know if we lost the feed on the stream, and I don't know if it's on your end or on the other end, but I'll just, since I've interrupted you already.
Is it
I'll double
resumed?
check. It might be on the other end, so. Thanks for checking.
Yeah, no problem. Great, we're back. Okay, great. I think what happened is that MIDI Monitor, I inadvertently asked MIDI Monitor to restart the computer and it quit Sienna, and that's what happened. But it's back now. Yeah, so MIDI Monitor is your friend. There's also, if you need a much more sophisticated tool, it's a little heavier weight, Hexler makes a program called Protocol. They spell it with a K because it's cooler. Cool starting with a K. Protocol is a fancy message receiving, sending, examining tool. Highly recommended. But MIDI Monitor by Snoise is the standard for me and has worked very well for me for like 20 years. So I don't argue. Okay, that's MIDI system exclusive. The next type of MIDI message you can send is MIDI show control message, MSC. And what happened was Charlie Richmond of Richmond Sound Design, who did a lot of very creative things with MIDI in the 80s and 90s, and really impressive audio playback tools as well. He was working on things like roller coasters and attractions in theme parks and sending show control messages back and forth between devices. And they were like, okay, well, you're going to use MIDI because it's robust and it's easy to understand and it's cheap to implement. So, okay, note 1 will mean go, and note 2 will mean stop. And they had to come up with all these sort of like in-house sort of temporary agreements about what MIDI message meant what. And then he was like, no, let's take the MIDI system exclusive system, apply for a system exclusive number, and then create a standard protocol for using system exclusive messages as show control messages. So we will create a go message. And anyone that knows that they're using MIDI show control will send the same message for go and receive the same message for go, and everyone will know what go means. And that will allow folks, like in the distant future, QLab, to create a nice, simple, human-readable interface for MIDI show control messages that will make it really easy to send things like go and stop and whatever. So the way that MIDI show control works is there is, the first thing you choose is a format for your message. And a format is a preordained list of types of things that get messages, like lighting general, moving lights, color changers, strobes, lasers, chasers. Sound general, music, CD players, EEPROM playback, or EPROM playback, audio tape machines, intercoms, amplifiers, audio effects devices, equalizers. On and on to some of my favorites: machinery general, lifts, trusses, robots, barges. Process control general, hydraulic oil, H2O, CO2, compressed air, natural gas. Pyrotechnics, fireworks, explosions, flame, smoke pots. I especially like that category. I like that there's explosions in this list. The reason I like that is because it puts forth a kind of optimism that I'm not really ready to embrace. That both fireworks and flame will never be an explosion. Not to mention the natural gas. I'm here to tell you, friends, we have no way to be really completely sure that QLab is bug-free. Like, actually no way. It's like, can't be done at this point. And the reason for that is not only does QLab have QLab, which is under our direct control, but QLab runs on the Mac OS, which is decidedly outside of our direct control. The Mac OS runs on Mac hardware, and Mac hardware is built to a standard of reliability that is impressive, but not absolute. We cannot 100% guarantee that QLab will behave exactly a specific way always and forever, because we do not control the entire apparatus that runs QLab. In theory, we could write QLab in such a way that it only uses software that we ourselves wrote. It was all checked methodically and mathematically in a way that could be guaranteed, and it ran on custom hardware that ran a custom OS just for us, just by us. This is how the Space Shuttle software team was able to guarantee that there were never going to be any software problems on the shuttle. And in fact, there never were. Their process was anytime any inconsistency or bug is found in the Space Shuttle software, it is considered to be a total system failure. Any bug of any kind was regarded as, in our simulation, the shuttle has now exploded. And so there were never any showstoppers in the software in the life of the shuttle program because they were obsessive about it. They were also working with an extremely constrained set of parameters. The software that ran on the shuttle is a game to this, right? It ran on these incredibly esoteric processors that were hardened against cosmic radiation. It used hand-woven memory, conductive wire woven through ferrite beads to produce a literal yarn of code, because that was impervious to cosmic radiation changing a bit and therefore rewriting software on the fly. We can't do that. We're not building the whole widget. As a result, I want to tell you that at no time do I feel really good about anyone using QLab to drive fireworks. So what I do feel good about is if you've got a machine that is hardened for safety, that is approved and examined and engineered for life-critical safety, that is in charge of fireworks, that's great. And if you want that machine to allow an incoming message to tell it when to start the fireworks, I also think that's okay, as long as there is a human person opening and closing that gate, right? So I have my fireworks machine here that's all safe and impressive. I'm the fireworks operator. I turn the key to say ready. I hold down the button to say listen for a message. And then QLab says, hey, fireworks, go. That's okay with me. Because then the person can let go of that button, turn off that key, and now if QLab wigs out because the Mac was dropped off the desk or whatever, and it sends another fireworks go message, the fireworks machine is no longer listening. Fine with me. Not fine with me is QLab, MIDI cable, straight to fireworks launcher. Don't like it, and neither should you. All, and I mean all of the times that something horrendous has happened with pyrotechnics in a live event situation, it was something that someone else could have done to prevent it, and not only could have prevented it, but any reasonable person who was looking carefully could have spotted the problem. Almost all the time it's been obvious. Not all the time, but almost all the time. And so I'm just giving you one for free, right? Make sure that the thing that actually does the fireworks is really made for that, and then have it open a door to say, I'll let you tell me when to go, and then we can have synchronized with the music, where if the music is early or late, no one gets injured, right? But if the fireworks are early or late, perhaps someone does. With me? Now I will describe the rest of this. So once you've chosen the format of the device that's listening, you have to choose a command. What command are you going to send it? There is a fixed set of commands in MIDI show control. Go, stop, resume, and so forth. They're in all capitals, which is how you know this is from the 80s. Because back then, lowercase letters cost extra. The message, the command is chosen, then the device ID is chosen. Device ID is an address, 0 through 127. And there's some rules around this. Basically, every device that wants to receive MIDI show control gets its ID. Okay, I'm 7. And it gets its format. Okay, I'm a barge, and I'm 7. Whenever a MIDI show control message comes in, it has its format, barges, and it has its ID on the message, 7. Oh, barges, 7, that's me. I will listen to that message. It's okay to have several barges all say that they're 7, then they'll all receive the message. But if I'm over here and I'm barge number 8, I see the message come in, that's not for me. I'm not moving. Or I'm over here and I'm like, oh, I am my EPROM playback, because I'm one of the 4 people who ever used one of those, or whatever it is. I'm teasing. I take it back. I'm a CD player, and I'm a CD player number 7, and in comes the message, oh, but that's for barge number 7, and I am not a barge, so nope, nothing happening here. So you have to have both the format and the device ID match. By convention, we also have all types, and we also have a rule where 127 is considered the all call message. So if you send to format all types and device ID 127, everybody responds to that message. I'm a barge, I'm a CD player, I'm fireworks, I go.
I really love the mental image of a CD player philosophically asking itself whether it is a barge or not.
Am I a barge?
Am I a barge? No, I'm just a CD player.
Yeah.
And that's all I want to be.
Short and stout. Here's my whatever.
I'm happy being a CD player.
Frankly, if I had to choose, I think I'd prefer to be the CD player because I don't care for swimming. Okay, but then you send a queue number and then a queue list and a queue path. Queue number we've heard of, yeah? In MIDI show control, queue numbers must be numbers. They can be decimal numbers, but they must be numbers. Queue list in QLab is not a meaningful number because if I have 2 lists in QLab, all the queues in those 2 lists have to have unique numbers, right? So if I have a list called list 1 and a list called list 2, there's no such thing as Q1 in list 1 and Q1 in list 2, because in QLab, all queues have unique numbers. But on an EOS, as an example, every queue list has its own set of numbers. So Q2 in list 1 is different from Q2 in list 2 on EOS. QPath is a parameter that I have never seen implemented by anyone other than Charlie Richmond. So I'm not really sure what it is, and I know that you need it if you're working with Soundman Server or with the audio box, but I don't think you need it if you're working with quite literally any other products. But it's there because it's part of the spec. So your format has to match, your command has to be a command the device can receive, your device ID has to match, your queue number has to be a queue on that device, and your queue list has to be either a list that's on that device, or if you're sending to QLab, it gets basically ignored. And then when this message comes in, the device does the command, if all those things match. Yes? The transmitting device doesn't need to have any special setup. It just needs to have output to MIDI that is physically connected to the receiving device. And that's MIDI show control. I'm a big fan of MIDI show control. I may not sound like it the way I talked about it, but I actually am, because I think it achieves its goal, which is easier than system exclusive, clearer than regular MIDI, all the advantages of MIDI, which is that it's dead stupid simple to build and physically maintain. It does have the disadvantage of MIDI, which is that it's hard to get MIDI distributed around a venue. Electrically, it's hard. So I don't love it for that reason, but if I've just got this thing plugged into that thing, simple as can be. Really love it. Okay, and that's all the things the MIDI queue can do. The MIDI file queue is next. The MIDI file queue is here. It's got the barred eighth notes. We know the basics tab, we know the triggers tab, and in the settings tab, we choose a MIDI patch. And then the MIDI file queue needs a target, and that target is a MIDI file, a .mid file. I have chosen here a performance of Take the A Train, as recorded by Oscar Peterson in June of 1991, sequenced and programmed by Diane Lewandowski. Well done, Diane. These little dots are the visualization of the data in the MIDI file. The MIDI file is a standard format. It was described many years ago. It's a standard file format for making MIDI messages. This same file format will work on basically any type of computer. And we only have one parameter that you can adjust, which is the playback rate. It needs a MIDI patch, which is a device that it can go to. And that device needs to be plugged into a device that can receive MIDI messages out of a MIDI file. So it would make this thing do something strange. But if I had a Clavinova, which is a Yamaha piano that's got a MIDI engine in it and has a little tiny motor underneath every key on the piano, and I sent it this message, it would play "You Can Take the A Train" as though someone were sitting at the piano playing it. I've used MIDI files in exactly one show in my life. We had a Clavinova on stage. We had a person who was playing the piano who was not much of a pianist. She had to play a very difficult piece. And it's no knock against this individual. It's a hard piece of music, and to find a great actor who's just right for the part, who's in the right town, will take that fee, and is a killer pianist, who can not only play this piece of music, but can accurately play it as though she is exactly as out of practice as the character is, that's a tall order. So we just angled the piano so that her fingers were not visible to the house. She mimed playing it, and we sent the MIDI file to the Clavinova from the booth. And the Clavinova, because it's not a synthesizer, it's an acoustic piano with motors that drive the keys, played the tune. Worked perfectly. 100% successful illusion. Again, don't need it often, but when you need it, it's what you've got. If you are one of those people who uses the MIDI file queue, tell us about it. I'd love to know about it. I would love to know more about those folks out there. The next type of message that QLab can send or receive is MIDI timecode. We've talked about receiving timecode briefly and snarkily, but we also have a timecode queue which can transmit timecode. The Settings tab of a timecode queue lets you tell the queue to either transmit MIDI timecode or linear timecode. If you are in a situation in which someone who is higher up the pay scale than you has demanded that we're going to use MIDI timecode, you can sigh resignedly and know in your heart that you are right and they are wrong, and then click over here to use MIDI timecode. Then you can assign a MIDI patch, which is the MIDI device that will receive the timecode from QLab and send it out to the world. And then you choose a frame rate. There are 8 frame rates available. And then a start time, and that is the first frame of timecode that will get transmitted when you start rolling the queue. And then optionally an end time. So this queue is starting at hour 1, minute 0, second 1, frame 0. If the end time is deleted, or it will show up exactly matching, and that means start and keep going till I'm stopped. But if you type in an end time that is different than the start time, this MIDI timecode queue, or this timecode queue, will start running by sending that frame and keep sending a frame until it gets to that time, at which moment the timecode queue will stop itself. So you can send an explicit chunk of timecode from the queue. Frame rate, in case you are not familiar, these are film and video frame rates, and that's because timecode is originally a film and video topic. It does not matter what frame rate you use. It only matters that all the devices that are sending and receiving timecode are using the same frame rate. My frame rate policy when I'm working on a show is I wait for someone else to say what frame rate we're working at, and then I agree. You can also take the timecode queue and switch to the vastly superior linear timecode, at which point you must choose an audio device to send the timecode to. Hear my words. Timecode does not sound nice. Timecode is made of square waves. Square waves are the right waves to use if you want to rip a speaker cone out of its surround, or permanently damage someone's hearing, or absolutely melt headphones, right? No, Dave, that would not sound cool. So, before you run a timecode queue, think very, very enthusiastically about which queue output on which device you are sending the timecode, and really, really ask yourself whether or not that is where it belongs. Once you have done that, you can choose a frame rate, start time, and end time, just like the other. Go away, go away, go away. And you're off to the races. Okay? Many people have asked over the years, how do I get QLab to send timecode to itself? And the most correct answer is, why would you want such a thing? The answer to that is usually, oh, well, I want to have a bunch of queues that trigger along time and timecode. No, no. Do you not remember the group queues? Do you not remember the timeline group queue? The timeline group queue is your friend. Make a timeline group queue, put your timecode queue in it, have that send timecode out to the world, and then put your own queues in there and set their pre-weights. But for the most particular scenarios, that is the superior approach. If you are in one of those most particular scenarios, we'll talk later. But in short, timecode going out and coming back into QLab gives you nothing that you can't already get inside QLab. Yeah.
Is there a reason why it doesn't go up to 60?
Why what doesn't go up to 60?
The frame rate. Like, so I know 24 is the standard for film, but is there a reason why you wouldn't do 60?
So, oh boy, here we go. So video speed and film speed are things. Yeah. And 60 frames a second is sometimes 59.97 frames per second. Timecode started in cinema, and these are the film and video speeds that are common. That is the best answer I can give you right now. To the best of my understanding, I don't know of anyone who's, I've never seen a context in which timecode was being run at 60 frames or 59.97 frames per second. I'm not saying it's not possible, but I've never seen it. So I don't know enough about it to give you a more thorough answer than that. I also don't, like, if I'm completely honest with myself and with you all, don't deeply understand the difference between drop frame and non-drop frame. I vaguely understand it, but like, why? Like, I don't really understand why. Whereas like 24 frames per second is the standard for film because that is the basically minimum frame rate that looks good. And so that's the way to maximize financially how much movie you can shoot on a specific amount of film. 25 frames per second exists because electricity in Europe runs at 50 hertz, honestly. 30 frames per second exists because electricity in North America runs at 60 hertz. And then all these ones with decimals have to do with how irritating it is to get film and video to agree with each other. But that kind of is the limit of my knowledge, and sort of on purpose, because if I knew more, I'd be asked to do more with timecode, and I don't want to be.
Our colleague Siobhan is deeply an expert about timecode, and we have in the past occasionally, when we've met up as a company, we've done a game where Siobhan tells us the history of timecode, and every time an unfortunate technical decision was made, everyone takes a drink. And it's a long night, let me tell you. It is a deep and just really head-scratching history of how timecode got to be the way it is. But it is pervasive, it's used everywhere, and you want to know only just the right amount to be able to use it when you need it and try to avoid it otherwise.
Yeah, that is also how I feel. Okay, and now, good stuff. OSC, which is, to me, the show control language of choice. OSC was invented by some lunatics at UC Berkeley a while back. I say lunatics very lovingly. Many beautiful, wild, unbelievable things have come from UC Berkeley over the years. Among them, my brother, who went to UC Berkeley for journalism school. The CNMAT, the Center for New Music and Technology, I can't remember what it stands for. They're the new music folks at Berkeley, invented OSC because they were sick of doing nonsense with MIDI that was above its pay grade. So they thought, wouldn't it be cool if we could invent a language for show control where instead of a fixed set of commands, go, stop, reset, and note on, note off, program change, we could say the protocol is every device, every controllable object has its own library of commands. And if you want to control that object, you send it one of the commands in its library, and it knows what to do with it. And they created a format of message that is human-readable form, looks like this. It's divided with slashes, like a URL is. And this message, /q/99/pre-wait with a big W, then a space, and then 4.2. This is an OSC message out of QLab's dictionary. That part is called the address of the message. That part is called the argument of the message. The rule in OSC is there are some messages that are only addresses. Those may not contain spaces. There are some messages that are addresses plus one or more arguments. In QLab, we separate the address from the argument with a space, and we separate arguments from each other with space. But this is the human-readable form of a message that computers send to each other. The actual message is not plain text. It's encoded. So the space is just a human decision about how to display the difference between the address and the parameter. You could have a different interface. You could say, the address goes in this box, and then we'll have some number of boxes below, and those will be the parameters. Other software uses a comma to separate the address and the arguments. There's no better or worse. I mean, reasonable people may differ. But the point is, this is not the actual message. This is the human readable form of the message. Just like note on is not the actual MIDI message, right? It is some series of binary numbers. Does that make sense? Okay, great. One thing that is true as we pass through, though, is it will matter in subtle ways, like the space will start to matter. If you want to send a message with an argument and the argument contains a space, how can you make it clear that that space is part of the argument rather than a separation for a new argument? So we'll show you in a bit. This message tells QLab to set Q99's pre-wait to 4.2 seconds. If we look over in QLab, we've got a network queue, which is how you send OSC messages in QLab. And this network queue has, in its settings tab, a text field to type in an OSC message. The settings let you choose a patch, and there are many on this computer. Lets you choose whether the message fades or not. We'll get to this in a minute. And its duration. A message that is not set to fade doesn't need a duration. When you run this queue, it will send this message once instantaneously. If I give it a duration, it will resend this message at this frequency for that duration. So it's not really that clear why you would want to set your pre-wait to 4.2 30 times a second for 6 seconds, but it could be done. We'll talk more about duration and time in a minute. When you send this message to a copy of QLab, if there is a queue that is queue number 99 in that copy of QLab, its pre-wait will be set to 4.2 seconds. And indeed, I have configured this patch to send OSC messages into QLab itself. And when I run it, you'll see that Q99's pre-wait, bam, is now set to 4.2. That's nice. On the one hand, you can just reach over and type in 4.2. But on the other hand, you have to be at the computer to do that. Maybe I would like someone over here on a Digico console mixing a show, watching an actor walk upstage and wanting to delay a message for a cue based on the distance upstage of the actor, send an OSC message from the console and say, hey console, tell me the actor's position, send that as pre-wait time to QLab, some kind of nonsense like that. Or maybe I have, Alec, what's it called, the tracker that you like? You put a thing on and you put cameras up and... ZACTRAC, thank you. Maybe a ZACTRAC system can be configured to send /Q/99/pre-wait and then fill in a value based on the location of the tag. Blacktrack's I've heard of also, but ZACTRAC is what I was thinking of and not thinking of the name.
Fine.
Yeah. I just said just like. Yeah. So that is the basics of sending an OSC message. There are out there many good citizens of the OSC world which are not sound. And so in a sense, the S in OSC, which stands for Open Sound Control, is a bit of a misnomer. Sound is where it came from, and we get not that much glory among our lighting and video brethren, so we feel like we're going to claim this one. And OSC is sound, and sound meaning sound, not just sound. ETC lighting consoles have a phenomenal OSC library. D&B, Behringer, I have nothing nice to say about Behringer except their embracing of OSC, which is pretty impressive. Yamaha these days has really gotten on board with OSC. Meyer Sound is very on board with OSC. There's a lot of groovy stuff out there that can be controlled by OSC and can control using OSC. And because of that, QLab can sort of sit in the middle of a show control context and tell different devices to do what they're doing based on information from other devices. And it becomes really interesting what can be achieved. Now, because there are so many devices out there, that can speak OSC. And because the paradigm of OSC is each device has its own library of commands, it gets tiring to write out all these messages if you're doing a lot of it. If I'm sitting in a theater and I'm sending messages from QLab, A to itself, B to a DS100, C to a Meyer Galileo, D to an EOS console, E to a, I don't know, some other thing, a Pixera server, I've got to have like all these manuals open, flipping through, trying to find the right message to send to each device. So we have something called network device descriptions. In QLab 5, you can create a network queue patch which is attached to a device description. And instead of presenting you with one big text box to write in an OSC message, it will present you with a series of hierarchically organized controls that let you navigate your way to a specific message, because QLab contains the library of messages for the devices. I'm going to show you how to do that. We're going to go to Workspace Settings, Network, and for a moment, just don't get overwhelmed with all the stuff you're looking at on your screen, and zero in with me on just this row. The name for the patch, QLab parentheses OSC, it's just a name. It's a human readable name like every other patch. The type is OSC message. Network queues in QLab can send whichever type of message their patch dictates. You can send an OSC message. You can send plain text using UDP. You can send hexadecimal codes using UDP. Or you can send a message that is defined by the network device description that the patch is using. So this message, QLab template, uses the QLab 5 library. This message uses the ETC EOS family library. I'm sorry, this patch. Does that make sense? So when I create a queue and I send it to ETC Nomad, network queue, patch, ETC Nomad, where are you? Oh, yeah, there. I get a list of OSC messages that EOS knows what to do with. I want to send a channel message. Do I want to specify the user? Yes. I want to say user 2 is sending, or user 2 is sending this message. And I'm going to choose, I want to set a channel at level. I want to set channel 89 to 45. And then down here in the bottom, QLab shows you the actual OSC message that's getting built. /EOS, /user, /2, /chan, /89, and then one argument, 45. When I send this message to an EOS console, if that console is set to allow messages, to allow control from user 2, and that console is set to allow incoming OSC messages, and that channel, that console has a channel 89 in its patch, then sending this message will bring that channel 89 to 45%, which is great, right? Because then you could have a QLab computer that's like your space maintenance for a rehearsal hall, your space maintenance tool. The computer could be sitting there running. You've got an EOS rack-mounted thing, and channel 89 could be the work lights in that room. So the crew can come in and run the queue on QLab that's just like, work lights up, please, without having to go and do slightly more complicated interaction with the EOS rack. And this whole hierarchy means you don't have to remember this syntax for EOS, which is hard to remember. I mean, it's not that hard, but it's hard to remember, especially when you start to think about all the huge piles of messages that each device can use. If I'm remote controlling a DS100 and I'm going to end scene positioning or function group spread factor, like, okay, /db audio 1 /function group /spread factor /4 space 1.19. Like, you're going to remember all of these? No, thank you. Spend your time designing your show. Let the robot do the robot stuff. We have, in QLab 5.5, organized our network devices by category. So under audio, we can control all of these devices. Under automation, we can control these devices. Hey, ZachTrack, there it was. Under communications, we can control these devices. Under lighting, these devices. And under video, these devices. You'll see that, I just learned that ATEM OSC has reached end of life and has been replaced by a different product, so we have to change that. If you're listening to this and you have a device that you want controlled by OSC and QLab and you think it should be among this list, let us know about it. All we need is a comprehensive manual describing what OSC messages your device can receive and that it is in some way readable, and then we will make it. Notably, there are a few out here that I want to sort of call out, well, because they're my favorite to call out. I will call out Behringer, which is a bad citizen of the world for many, many reasons. But one of the reasons they're a bad citizen of the world is that there is no published spec for the X32 OSC library. The authoritative document that shows the list of OSC commands for the Behringer X32 was created by some guy who hooked up his Behringer to Wireshark and just sniffed all the messages coming out of it. I think that's reprehensible. If you're going to put something in the world and you're going to bother to write a manual for it in the first place, go all the way and have the manual actually describe what the thing does. What? Yeah, really, really frustrating. So it took us a while to get the X32 in here because it took me a while to read through that document that that guy wrote. Likewise, in lighting, this is sort of a different story. The Grand MA3, which is not a simple piece of hardware at all, the Grand MA3, their OSC library is so flexible that, like, you can basically sit at the Grand MA3 and tell it, here's how I want you to listen to OSC. So there is actually a fairly small library of fixed commands and a fairly large library of it could be anything. So it took us a while until a Grand MA3 expert communicated with us about the set of commands that are fixed and the set that aren't flexible. So it's a little bit difficult to decode some of these. And all of that stems from a good thing, which is that OSC messages are flexible. Okay. While we're here, I want to talk about some other things in the patch that are a little headbendy but worth knowing. To begin with, patches can send messages either using UDP or TCP. UDP, which stands for Universal Datagram Protocol, and TCP, which stands for Transmission Control Protocol, are two very low-level, very don't need to worry about it almost all of the time components of computer networking. And the short of it is some messages need to be one kind, some messages need to be the other kind, and some messages can be either kind. And until you really need to know more, it's just going to be cluttering your mind. So on a small network, not connected to the internet, if your device can use either, you can use either. The more complicated your network, the more important it is to use TCP, which has better traffic cop facilities. UDP is a little more fast and loose. That's as far as I'm going to go on that right now. We can talk more if you like. The next menu, interface, allows you to select one of the specific network interfaces that your Mac has as the interface that these messages will go along, or you can leave it as automatic. If you're connecting your Mac to multiple networks, and those multiple networks all use the same IP address scheme, which is 192.168.5.something, if I'm on two networks that are both 192.168.5.something, then it's possible that QLab will choose the wrong network to send my message over. So that's when I would choose an interface here. Nearly all of the time that I leave this on automatic, it works perfectly. Almost every time. Only when I have set up a bizarre network situation have I needed to choose the interface. Next, you choose the destination, which is the IP address of the device that is receiving the messages. If IP address is not something that you feel comfortable with, I encourage you to go to the doc, to tutorials, to basic networking. I wrote this article after getting frustrated with explaining IP addresses at the right level of detail for stagehands and designers. This is written out to explain basically all the things you need to know for IP addresses to use them effectively in the theater, and a minimum of stuff you don't need to know about IP addresses to use them effectively in the theater. In short, IP addresses are 4 numbers separated with periods until we go to IPv6, which is coming real soon now and has been for a decade. A decade? Longer? 2. Yeah, 20 years. Yeah, incredible. But it's a number, dot, another number, dot, another number, dot, another number. And those numbers are all between 0 and 255, but they're usually neither 0 nor 255. But sometimes they are, but sometimes they're not. Blah. Then there's port number. So in theory, the IP address described is the address of a computer, just like 10 Liberty Street is the address of my house, right? In theory, this computer's address, while it's connected to this Wi-Fi network, is a specific number that's only for this. So if I know the number, your 1.2.3.4, then I know that messages that sent to 1.2.3.4 end up here. Port number is like apartments in the building. So I send a message to, 123 Anywhere Street. Okay, great, I'm at the building. There's 100 apartments here. Which apartment gets it? That's the port number. So port 53,000 is QLab's apartment. You can change the port. We'll talk about that some other time. But in short, you need to know both the address of the receiving device and the port number of the software or program or subsystem or whatever that is listening for OSC messages. If you use a network device description, QLab will fill in the port number for you to the default that the manufacturer of that device specifies, but you always might have it customized, and you need to know, hey, lighting folks, are you using port 8000 like usual, or are you using a different port on this particular show? And they will tell you. Or they will often say, I don't know what you're talking about, please leave me alone, I'm busy doing lighting, in which case the answer is they're using port 8000. Passcode is a QLab specific additional security measure in which messages are checked against the passcode and only allowed in if they have a matching passcode. You can set your workspace to also allow messages with no passcode, but by default, in the OSC Access tab, which we will talk about in greater detail in just a bit, you have to have a passcode that allows messages coming in, and then incoming messages have to have that passcode in order to get in and do stuff to your Mac. Fear not, we will return, but we've already said too many numbers in a row, so I need to break it up, intersperse it with something a little more action-y before we're all ready for more numbers. These are network patches. Here's another network queue that's sending an OSC message to a Meyer Galaxy, just showing you how another way that it might look when you're using a network device description. Here, we're controlling the device output 4 and setting its voltage range to plus 16 dBu, which is the kind of granular control that we all expect from Meyer. Now, when you give a network queue a duration, last week, spending time with my little nephew, and he likes if you give a mouse a cookie. And I realized if you give a network queue a duration, it will probably ask you for a glass of milk. When you give a network queue a duration, we saw earlier that you could resend the message over the course of that duration. One of the reasons you might want to do that is if you have a congested network and you want to make sure the message gets through, even if there's extra traffic on the network, right? Set the Q light to red, please. Set it red, set it red, set it red. I'm going to send this message a bunch of times over 5 seconds. But another reason you might want to have a duration for a network queue is to send a range of values to like drive a fader or move an object. So I am sending this message with a duration of 10 seconds, and it's going to send what's called a 1D fade, a single axis fade. One parameter is going to change value over the course of these 10 seconds. We're going to send messages every 20 times a second, 20 frames per second, and we're going to send floating point numbers, which means the range for this message is going to start at 1 and go to 0, and it's going to send every decimal number it can in between 1 and 0, so 1, 0.99999, 0.99998, 0.99997, 20 times a second for 10 seconds. When I send this message, which sends opacity messages to those queues, it drops their opacity down over 10 seconds, lifts their opacity back up using this message, which fades from 0 to 1, and stops them. But now that was one message controlling several queues. How did I do that? The answer is the next superpower of OSC is that it supports wildcards. A wildcard is a special symbol which means more than one thing. So you remember that this queue was Q99 pre-await. That 99 gets matched over here by this queue number, 99. 99, 99. But this message is /Q/OSC star. And here I have 3 queues numbered OSC1, OSC2, and OSC3. The star says anything will do here. So when I send a message to /Q/OSC star, what I'm saying is send this message to any queue whose queue number starts with OSC and then after OSC has any text. So I can send one OSC message, and those 3 queues will all receive it because their names match the pattern defined by this asterisk. Are you with me? (2D) OSC fading is also possible. So if I set the fade menu to 2D fade, oh, I'm sorry, I'm going back. I skipped something. The fade is facilitated also by this little construction, #v#. In a 1D fade, the V surrounded by hash marks is a code saying fill in the fading value here, V for value. This hash sign, or if you're my age, £, or if you're 50 years older than me, octothorpe, which is the typographical name for that symbol, is used like quotation marks to surround what we call here a token. A token is something that gets filled in with something else later. So we have one token in a 1D fade that is V for value, and the value that gets faded along this curve here gets filled in place of that V every time the message resends. When we set this fade to 2D fade, we get a, what should now be familiar to you, canvas view with the same tools that we use to draw paths for object audio. We can make it, this canvas, any width or height we like. This is not a map. We're not going and assigning a map. It's just a just for this queue space. And here I'm sending /Q/soup/translation, and then I have 2 arguments, both of which are tokens, #x and #y. X means the x-axis position of the pip that's going to fade around this space, and y means the y-axis position. QSoup is up in here. Hello, soup. So when I run this queue, nope, I had the wrong queue standing by. when I run this queue, oh, it had a pre-wait. The X and Y position of that queue on this stage gets modified by this path. For a while, this was the only way to do something like this in QLab before we added 2D fades to video, which we haven't talked about yet because it's not after lunch yet. But this is a 2D fade of an OSC message. Now we say 2D and you think of like this, right? But it's really just any two parameters. So the 2D fade, if I sent it to an input channel message on a console that was appropriately configured, could be level and pan, or could be any two values that are two arguments in an OSC message. It could be hue and saturation. You have to have an OSC message that has two arguments like this. If there's an OSC message you know of that's like /my/groovy/message, and then argument, 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 it's 3 arguments, you could say, well, argument 1 will be X, argument 2 will be just the number 7, and argument 3 will be Y. Maybe that's red, green, blue. We're going to change the red and change the blue, but leave green alone. So as long as there's 2 arguments available to replace with hashes, you can use that message in a 2D fade. You with me? A little. It's hard because it's hard to pin down when there's no specific example. And it's hard to come up with specific examples that aren't excruciatingly specific. Are there any questions here? Okay. Time to sit down. Now, if you recall, yesterday I discussed the frustration that can exist when show control messages are sent from one department to another during a break or during a hold, when folks are expected to be doing independent parallel play. One of the tools that we have in QLab which helps you manage this is the overrides window, which I want to discuss now because it's most relevant to everything we just did, even though it's a slight change of topic. But it's a good sized topic for between now and lunch. I'm going to go to the window menu and choose override controls and bring this panel up here. The override controls window lets you temporarily enable or disable different kinds of messages that can come and go from QLab. To emphasize, the overrides control window is absolutely in charge. When I turn musical MIDI output off, no MIDI voice messages get out of QLab, period. When I turn it back on, maybe some other reason could stop them. But when it's off here, it is definitely off. So if I'm sending OSC messages to all kinds of devices, I can set external output off, and now all OSC messages that leave the computer and go somewhere else are disabled. So I can turn all of this off while I'm on hold and not bother the lighting people, not bother the other devices, not do anything over there. But local output is on. That means that OSC messages which come out of QLab and come back to me here in QLab are still permitted. I went past this a little too quickly. When we talk about IP address, there's one special IP address, localhost, which means me. So when you set a QLab network patch to localhost, that message never leaves QLab. Now, folks with some programming experience are probably expecting localhost to be the same as that. But in QLab, it is not the same. 127.0.0.1 means this same computer. Localhost means stay inside QLab. So, oops, did not mean to do that. So local output is separated from external output for network messages. We also have the ability to turn timecode input and output off and to turn DMX output off. It used to be true that this only disabled ArtNet lighting output and not, well, I've disabled my lighting output. And there's a 2-second delay in the firmware of the lighting controller. When I re-enable it, it wakes right back up because it starts hearing from QLab again. We'll talk about lighting tomorrow. Input works the same way, and I want to call your attention to the footer of the workspace. When different inputs are disabled, QLab tells you about it. And the message gets long and longer the more things are disabled. When outputs are switched on, you will start to see 0 with a slash in the status column. That icon means overridden. The mnemonic here is the O makes you think of override, I hope. And the slash means no, not this. So that means that the queue, there's nothing wrong with the queue, but its output is being suppressed because there's an override that's preventing it from outputting. Yeah?
Are these toggles something that, like, either within settings or with, I think maybe you said, like, Apple script yesterday, that can, like, we can set to a quick toggle. Like, so I'm working to a rate, boom, disable MSC, I'm working.
Yeah.
Boom, re-enable, I don't have to go through the menu.
Yeah. You can set, you can use AppleScript and OSC to control these buttons. So when I'm doing a show with a lot of timecode, or I'm sorry, with a lot of show control, I will make a queue in QLab that uses scripting to toggle the buttons I want toggled off, and then another script that toggles them on. And I will set a button on my MIDI controller. Just when I hit that button, that toggle is flipped.
So do you need AppleScript, or can you just do it purely with, like, cues and hotkeys?
You need either AppleScript or OSC. Yeah. And if you're ever going to disable OSC output, then you can't use OSC to turn it back on. But since scripting cannot be disabled by the override control panel, I use scripting just to make completely sure. Okay. Any other questions here? Override controls is a window to make friends with, right? I know plenty of lighting folks who just, whenever the stage manager calls hold, they reach around behind the lighting console and unplug the network cable that plugs the computer into the show control network. And I'm like, I got a button that's nice. Do you want to trust me? And they're like, no, I don't. But it's fine. Network queues themselves, I always do this in this class. I always forget that I have a whole little separate, shorter list of things to talk about network queues with. All right, well, that's how that goes. So instead, I will just move on to the bottom portion of this list. So OSC Access, I started talking about this, but now it's time. I said too many numbers, we got to go do something exciting. We'll come back and do more numbers. It's time, more numbers. In Workspace Settings, Network, OSC Access, there is a checkbox to allow or not OSC to come into this workspace. If I turn that checkbox off, no OSC messages make it into the workspace. OSC messages still make it to QLab. You can send some messages to QLab itself. Messages like, hey QLab, tell me a list of all the open workspaces. But the workspace itself is prevented from receiving OSC if that box is unchecked. Over here, the IP address or addresses that the computer is currently holding are listed so that you can see what address should I be sending messages to in order to get OSC into this QLab. into this copy of QLab. Now you have to figure out on your own if there's multiple IP addresses, whether one of them or the other is on the correct physical network to send OSC from another device, but at least gives you a starting point. Passcodes, as I said before, are a security mechanism which prevent unauthorized OSC messages. I have here a little table of passcodes, and you can add as many passcodes as you like. Each passcode and no passcode can each be assigned to 3 layers of permission: view, edit, and control. If view is unchecked, then no message that has the corresponding passcode will successfully arrive in your workspace. With view checked, messages which only ask questions but don't change anything will be permitted. With edit checked, messages can edit parameters in QLab, but can't start queues, stop queues, or move the playhead. With control checked, OSC messages can start queues, stop queues, and move the playhead, but with edit unchecked, they won't be able to edit anything. And with all 3 checked, you have full access. So I could create a set of passcodes where my operator can send OSC messages that do control messages, but not edit messages. My associate designer can send edits, but not control, because I don't want the associate designer to accidentally run a queue. And then full access is possible with this 3rd passcode for rehearsal and programming time. By default, QLab listens on port 53000, but you can customize that port on a workspace by workspace basis. QLab also listens for plain text over UDP, and if you type out the human readable form of an OSC message and send it to QLab, QLab will try to interpret it as an OSC message and execute it. You can send that to port 53535 or to a custom port of your choosing set here. Make sense? Okay. I find this passcode stuff really useful some of the time, and it gets in my way some of the time. If I'm on a network that is physically controlled well, then I don't have to worry about passcode access because no one's getting on the network without coming to me. So I am pretty liberal with my checking of these boxes for no passcode. A lot of software doesn't know how to send a passcode to QLab because it's a QLab specific thing. Some software can't really be well configured to send passcodes. So if you're using that stuff, maintain physical control of your network, enable access by no passcode, and you'll be fine. Yeah? And when I say physical control, I mean I have no Wi-Fi network. I have a network switch that's in a place where no one can just reach in and plug in. Then how could someone get on the network? They can't. Or if the network switch is by the knees of my operator standing at the mix position, and some hoodlum comes in with a laptop and an Ethernet cable ready to just change the color of all my queues, or pre-wait times be damned, right? The operator's gonna notice. They're gonna be like, hey kid, what are you doing there trying to plug into my network switch? Get away, and so forth. Questions? Questions like, why did you use the word hoodlum? Yeah.
We might be getting this later, but what's the difference between connecting to a workspace via OSC from another QLab versus the connect workspace?
Yeah, so we will talk about collaboration tomorrow. But in short, collaboration uses its own communication protocol and not OSC. And collaboration only works with another copy of QLab. OSC can come in from anything. So if you have an EOS lighting console over there and a Digico sound console over there and a D3 server over there, those devices can all send OSC messages to QLab. None of them can use QLab collaboration because QLab collaboration is a QLab only feature. So if I want messages coming in from those devices, I must allow OSC connections. If I want collaboration from another copy of QLab, I must go to collaboration and allow collaboration connections. But being able to turn those on and off separately has value. Likewise, I'm sorry?
Is OSC what's used for QLab Remote?
QLab Remote uses OSC for now. Likewise, in that context where I have an EOS, a Digico, and a D3 server, it might be convenient to have 3 passcodes, one for each of them, if their software can send a passcode. And then I can individually disable or enable those passcodes to say, like, right now I'm not taking any calls from the Digico, and just disable the Digico's passcode. But I'll still get messages from the EOS and from D3. I'm not sure that that's useful, but it could be. Yeah. All right. Because video is a big topic, I first of all don't want to start it until after we've all eaten, so that the blood sugar is up, so that the attention is up. Second of all, I don't want to interrupt it. So because we have an asymmetrical amount of day, yesterday we had a longer morning and a shorter afternoon. I'm going to propose to you that because we've come to a good breaking point in the order of operations, we could break for lunch very shortly, and then return and spend the rest of the day on video. Does that feel reasonable? Is anyone just itching for more of the topics that we've been doing so far today? Feeling underserved in this area? You are. Can you describe the nature of your interest?
I just want to learn more about OSC and network in general.
Okay, great. That's great. I think then we'll go like another 10 minutes or so, because there's a little bit more networking to talk about. We'll spend like 10 more minutes on networking or so. Then we'll go to lunch, and we'll come back and do video. And if there's still more to go beyond those 10 minutes, don't be shy. That will be part of our tomorrow plan. Does that sound good? Okay, great. There's a few other tricks QLab does with networking that I want to point out. The first one I want to talk about is OSC Queries. This is something unique to QLab. This is not OSC in general. I want to call your attention to the queues here, T1 and T2. These queues send messages to queue T2 setting its color name. So this sets T2 to red. This sets T2 to no color. This message is a little differently structured. Queue T2 color name, which is the address that we've been using for these last few messages. But then the argument is another address surrounded by hash marks. That in QLab is an OSC query. And what that means is, at the time of sending this message, go look at this address, find out the value that is there, and replace this token with that value. So what this message says is, set Q T2 color name to the answer to the question, which is, what is Q T1 color name? Then we're going to set this queue to resend 10 frames per second for a really, really long time. So when this queue is running, it will continue running for another hour. And while it's running, it will constantly watch queue T1 and see what its color is. Will it? What's happening? That's correct. No overrides. Why are you not working?
Did you disable access with that password?
Did I? You're up. You're up. You're where you belong. You're where you belong. Well, we know that worked.
After lunch? Wait, no, I don't know.
All right, well, this is curious. This is irregular. Ah, there we go. Something was reset. So when I change, no, you've got it. That's actually the answer. It doesn't want a 2-word. So watch this.
Free t-shirt.
If I enclose the query in hash marks, it will turn the argument into a string. Nope, that won't work. If I include, oh, I did not type that in the correct, I'm not running the correct message. QT2 color name, now in hash marks. Yeah. So the space in hot pink, well done. The space in hot pink breaks the message because the space separates arguments in QLab. So now sky blue works also. Hey, 2 of my favorites actually, sky blue and hot pink in here. Because this message is constantly running at 10 frames a second, 10 times a second, QLab asks T1, hey, what's your color? And then sets T2 to that color. That's interesting. So too is this version of the message, where we use a special operator, selected. This says, hey, when this queue is running, whichever queue is selected, QT2 becomes that color. That can be kind of useful. It also works with name, right? If this queue is running, QT2's name is the name of whatever queue is selected. Notice that when I select all these queues that have their default name, QT2 gets nothing, because the default name is not the name. It's called the default name. It's got a different message. Reset everything in this list, including evidently the lights. Oh, because there's a lighting queue in here. I can't do that demo because it includes copyrighted material and we are streaming. So I'll do a demo like that later if someone wants. The OSC query gives you a way to make messages in QLab that contain information gleaned from QLab. I don't know that I think that the recoloring a queue to match whatever queue is selected is necessarily the most useful thing, but it's a simple example. And I encourage you to sort of think expansively about it. I use that for things like displaying information back to the human about what's going on right now. If the stage manager has a copy of the screen showing QLab, I can call their attention to certain cues by changing their color dynamically while the show runs. I find things like that exceedingly useful.
I've seen people make like custom props that every couple of seconds will change the color of a cue so that you know that the prop is on the network and working and online.
Nice. Yeah, cute. Really cute. Basically, QLab doesn't have a lot of facility for just displaying information to the operator. But what it does have is cues with names, numbers, and colors. So you can use OSC messages to set the name, number, or color, well, not number really, name or color of a queue that is in the operator's field of view to give them information.
I have one fun example of using long-running OSC messages that Alec came up with for this building. Because this theater is run almost entirely by QLab in almost every conceivable way, we have one particular computer up there that is the brain of the building, and it really matters if it stops working for some reason, and we need to know. And so Alec came up with a scheme where he has one computer at the back of the building, which is once a second with a long-running infinite network queue, sending a message to the front of the building. And if it gets a message back, it says, okay, it's still alive. And it resets a counter somewhere. And if it doesn't get a message back within a certain amount of time, it doesn't trip the switch that says the front of the building is still alive. And if it's something like 5 or 6 seconds pass and it doesn't hear back, it texts us. It sends us a text message to both me and Alec to say, I'm very sorry to report that the QLab machine of the Voxel has crashed. Please do something about it. So we periodically, every once in a while, get a text message that tells us that the building has crashed and we need to go do something about it. And that is one of my favorite uses of long-running network queues, and it just requires one message a second, all day long, every day.
The next thing for you to do, Alec, is to take an Arduino and a solenoid and bolt it on top of this case so that you can send a message to the Arduino from home that presses and holds down on the power button for 10 seconds and then lets go. Then you can reboot the Mac from a distance. But of course,
That is a problem. That said, the QLab that runs the building basically doesn't crash. It usually means Alec unplugged something or some other physical reality. The internet's down, the network is down.
Or we installed a beta, because this is our testing theater, so every once in a while I'll install a beta of QLab on this machine that's doing as many things as we can possibly get it to do 24 hours a day, 7 days a week. And if the beta had a bug, sometimes we'll find it that way because it's working hard. And
I mean, at that point, we almost hope it crashes.
yeah, exactly.
Yeah.
So that's sometimes a nice thing to see that we got a crash on an unreleased version and can go fix it. But yeah, it's true. It doesn't. Most of the time, if we're not doing heavy changes, and putting lots of sort of bleeding edge betas on there, it just sort of sits there all week, all month, just controlling the building.
Yeah.
It's best practice to restart your computer with some frequency that I defer to the experts on. I don't do it.
Yeah, it's the support team will tell you do it once a day, and I'm just totally lazy and do it maybe once a month, and they're gonna hate that I say that.
Oh, daily reboot.
Yeah, I know.
You can automate it.
I don't.
Listen to me. What if someone's what?
If someone's working in the building at 4 a.m., I'm not turning the lights off on.
I mean, we're also trying to do the worst practices. We're sort of intentionally doing the bad thing because if we can run it for a month and it doesn't fall over and it doesn't have a memory leak, that's great. But also, it's sort of low stakes here because we know what's going on, we know it controls. So it's better for us to push the envelope and behave more badly here than we would suggest that you do. So that's the other reason.
Yeah, that's true. My recommendation to you is that if you are running a show for a long time that wants the Mac to be up 24/7, you work out somehow in your process a once daily reboot. If for no other reason than a once daily reboot guaranteed will show you whether something else in your setup has gotten fakakta, and the only reason it's working is because it hasn't been rebooted, which is not healthy, right? So if your system can't come back from a reboot cleanly, that's knowledge worth having in a context that is not what Chris just described about this building. I hope that was a little bit more of networking that was interesting to you, and we can still do more tomorrow. Yeah, great. It's 12:05. Let's come back at 1:10, so 65 minutes, and we'll talk about video. Thank you all. And thank you, Aaron. Hi. Okay, here we are. Welcome back, folks. I hope that you had a pleasant, restful, and nourishing lunch break. We are going to talk this afternoon about video. But as I did before, I want to start by checking if there were any lunchtime musings that had settled in anyone's mind, something you thought about asking or wished you asked or would like to now ask that came up over your break. Yeah.
With the OSC triggers, can you target a queue type?
Can you target a queue type?
Does that make sense?
Yeah.
So like, I want all my network triggers to be purple.
Oof, I don't think so.
Okay.
I don't think so. I don't think we categorize queues by type as far as OSC is concerned. But here's what you can do. In a given list, I'm going to go to network queues. Yeah. In a given list, you can type shift period, which gets you the right angle bracket, which unfolds all groups. Then you can type Command A to select all queues in the list. Then go to the Basics tab, and where you were expecting to see the queue number, you now have a menu telling you how many queues are selected. And when you click that menu, you can refine your selection to only queues of a certain type. And then a message that is /q/selected will act upon those queues.
Could you repeat that one more time?
Oh, cheerfully. But I'll do it in a more complicated list because it'll be even more fun.
Cheerfully, though.
In this list, I'm going to start by typing shift period or right angle bracket in the US keyboard. Brits, French, I'm so sorry. And it will unfold all the groups in that list. Next, I will type Command A, which selects all queues in that list. Next, in the Basics tab of the inspector, I'll see a menu that says 166 selected queues, and I can choose from that list a specific type of queue. In this case, I will choose fade queues. And now, only the fade queues remain selected and all my other queues become deselected. At which point I can run a OSC message, send an OSC message that starts /q/selected, and it will act upon the selected queues, which we've already produced a set of selected queues that we want, and profit. Yeah? Splendid. All right. We're going to talk about video queues, and video in general, and we're going to use this piece of media, which I shot using the world's most expensive dolly, the New York City subway system. I clamped my GoPro to the handrail on a northbound F train, and I went across the little stretch of Brooklyn where the F is above ground before going underground for a few stops and then going to Manhattan. And the reason I used my GoPro is because at the time that I shot this video, there was no other easy way to shoot high frame rate video without spending a lot of money. I don't live in Brooklyn anymore, so I have to find a new clever thing to film if I want to replace this footage. That I can't use the subway, or I have to make a trip just to recreate this shot. I'm not sure what I'm going to do yet. Point is, we're using this shot. It looks a little fisheye because the GoPro lens is a little fisheye because GoPros are a little fishy. And we're going to use this footage to demonstrate some of the powers of QLab's video features. I'm going to preface this by saying, for humans, so too for computers, video is harder than audio. On the one hand, the lowest sample rate of audio that most people work at is 44,100 samples per second. The lowest sample rate of video that people work with is only 24 frames per second. So you feel like I got to do way less stuff in a second. But each second, every pixel matters. And so the computation is harder, and the systems of control are harder because the possibilities are greater. in terms of the possibilities of things you need to tell it what to do about. So if you don't start off being a video person and you find any of this vexing, please trust that that is because it is a little vexing, not because you are missing something. And we're going to try to, take our time and go real slow and learn everything there is bit by bit. But as always, stop me, ask questions, ask me to repeat myself, ask me to slow down, whatever. Okay. To play video in QLab, you use a video cue, which is hopefully not that surprising. Video cues are like audio cues in that their target is a file on your disk. The file must be a video file or an image file. We'll talk about formats in a moment, but to paint to the broadest strokes, any sort of normal common video file that you easily find or normal common image file format is probably going to work. The video you're going to see today is mostly ProRes 422 LT or ProRes 422 Proxy, and the still images are mostly PNGs and JPEGs. Others will work too. We'll talk about it shortly. In the inspector of a video queue, you've got the Basics tab, which we all know about, the Triggers tab, which we all know about, the I/O tab, which works a little differently than the I/O tab in audio queues. So I want to take a moment to stop and take a moment and look at it. The I/O tab for video queues will also look different based upon the type of media that's being targeted. For example, this video file has no soundtrack. As a result, there is no audio I/O going on here. But if I if I target a piece of media that has a soundtrack, we will get some more options pertinent to sound. We'll talk about those shortly. To start with, though, is the file target well, which we already know and love, hopefully, from audio cues. That's the same. Next is a listing of the video format of the targeted video file. This is a ProRes 422 LT file. It's 848 pixels wide by 480 pixels high, and it's at 240 frames per second. Over here is a disabled menu, which will become enabled if we use media with sound embedded. We'll talk about that shortly. Audio format says no audio, which is how I can say so confidently that there's no audio in this file. Then the video output is the place you choose where it's analogous to audio output patch. It is the place where you choose where the video is going to go. We have a stage, as we call it, defined as a place video goes to, and that stage separates cues from actual output devices the same way that an audio patch separates cues from actual output devices. The stage is named QClass. The monitor button lets me bring up a monitor window, which allows me to view the stage on my screen as well as the output. This can be really useful if, for example, the output is behind you and you want to describe it. But in a lot of contexts, the operator wants to be able to check that they're outputting but can't see what the audience sees. The simplest explanation is what happens if you're using a dowser that physically blocks the path of light from the projector, but you want to make sure the signal's good. The monitor window shows you, even though the dowser is blocking the actual light for the audience. It's also a great tool to use to prove to the house video engineer that your output really is playing. No, I am rolling a cue. I really am. Look, here's the monitor output. So the problem is downstream. That's the monitor window. To the right of the monitor window are the dimensions of the stage, just to give you a clue, and an edit button to jump you to the video stage editor, which we'll talk about in time. Yeah?
I was just realizing during one of the breaks we could take a tour of the live streaming station because it has a bunch of monitors up and all kinds of fun stuff that shows this stuff. So if you want to look at what is live streaming this class, you can go look at how we've set that up.
Maybe what we should do is put NDI scan converter on that Mac, capture that whole screen.
How many loops could we do? It'd be amazing.
You're very clever, but you can't fool me. It's turtles all the way down. That sounds like fun, though, right? Yeah.
Yeah.
Okay, that's the I/O tab. If this video file had audio, we would also have an audio output choice down here, which lets me choose an audio output patch for the sound in the video file to be sent to. Again, we'll get there. The geometry tab comes next, and the geometry tab is sort of like the levels tab for audio is. The geometry tab lets me choose the basic behavior of the playback of this video. So to start with, the overarching choice is mode, either fill stage mode or custom mode. This video cue is in fill stage mode, as is this one. This logo, as you can see here in the sort of sample view, this logo is a video that is a square. It is playing to a stage that is a rectangle. The mode is fill stage, which means in some way be as big as you can. There are 3 styles of fill stage, though. Fit will fit the content of the video to the stage, the content of the file to the stage, making it as large as possible while not exceeding the bounds of the stage in any dimension and not clipping off any amount of the video. What that means is, since the video is a square and the stage is a rectangle, there's blank space on either side of the video. Here you see nothing because QLab is putting nothing in that blank space. If I switch it to fill, the directive is use as much of the stage as possible, clip off some of the cue if you need to, but don't warp the shape of the cue. So this video is still being shown as a square at its original aspect ratio. It's just scaled up to occupy the full space of the stage. And in this case, the top and bottom get cut off. If I switch it to stretch, stretch tells the cue, display every pixel of the cue, use every pixel of the stage. And if they're not agreeing with each other in terms of shape, stretch the cue as needed to fit. Yeah? One may be more correct or less correct for you in any given circumstance. The other controls in the geometry tab, layer, geometry, and smooth, we're gonna, well, no, we'll talk about layer in a minute, but we'll talk about opacity right now. Opacity is a percentage scale from 0 to 100. Opacity of 0 is completely transparent, and as we fade up the opacity to full 100%, the video becomes visible. That's how you fade in and out of video, by fading opacity. The little reset button here resets the opacity to its default posture. The smooth checkbox, which is checked, I think, by default, smooths jaggedy edges in the video if the video is being dramatically scaled. So when I uncheck this smooth checkbox, it's not hugely dramatic in this case, but you see the jaggedy edges around the white. That's because this image is being scaled up a great deal, and the default behavior of anti-aliasing is enabled by the smooth checkbox. When I uncheck the checkbox, it gets jaggedy, and when I check the checkbox, it gets smoothed out. Sometimes you want the jaggedy look aesthetically on purpose. We came up with this checkbox when I was working on a show where I was carefully drawing very low-res sprites, which I wanted to be displayed in a very sort of like 8-bit video game vibe. And QLab was helpfully blurring out all my jaggedy edges. And I was like, I drew a zombie and I see just a green wisp. Why? And it's anti-aliasing. So we added the smooth checkbox so that you can get the jaggies if you want. Yeah?
What kind of anti-aliasing do you use in QLab?
Chad, would you like to answer this one?
I don't know off the top of my head. Give me 2 minutes.
We'll check the code.
Chad, one of our developers, who works on video among other things, is fortuitously present for questions of this sort. It's some kind of nice, smoothie, pretty kind. is the limits of my knowledge on that.
Do you have a? Are you working in a situation in which you have a preference?
I guess there's. I'm just curious, I guess, because I know there are visual differences between different forms of anti-aliasing, and
Yeah.
I'm just wondering what form you specifically use. So.
You arrived at a class with curiosity. How dare you?
While Chad is investigating, I will proceed. Because I want to talk about the layer control. So here are 3 video cues, Wasp, Panda, Wally, all set to layer top. The order in which I play them dictates the order in which they are displayed to you. When I play the Wasp, then I play the Panda is a larger image. It completely obscures the Wasp. But then this drawing of my favorite little robot is much smaller. It plays in front of the Panda, and therefore you can still see the Panda because the robot is smaller, right? If I play these cues in a different order, though, they display in a different order. Their layer is set to top. Each cue is set to layer top. But now, the Wasp is played here with a new cue set to layer 10. The Panda is layer 20, and I've also scaled it down. Hi, Eleanor. And Wally is on layer 30. You can think about layers as being like a stacking order, where the lower layers are farther away from the audience and higher layers are closer. It is as though the cues have distance between them. Layer 10 is below layer 20 is below layer 30, and there's imaginary distance between them. There's no real distance between them. This is a clever animation. It is a metaphor. But it's like you have a bunch of index cards, and each one is a cue, and they're infinitely thin. Also, any 2 cues that have the same layer, the most recent one is put on top of the previous. They don't replace each other. If I have 2 cues on layer 10, the first cue to play on layer 10 appears. The second cue to play on layer 10 appears. If I stop the second cue, the first cue is still there and was all along. It's like on the fly, QLab says, okay, layer 10 and 1/2, or whatever. The layers are a stacking order, and the 2 special layers, layer top and layer bottom, allow you to say all new cues that are on layer top will appear in front of all others, or layer bottom will say all new cues appear behind all the others. When a cue is in custom mode and not fill stage mode, as this one is, you have your layer control, which we just discussed. You have your opacity and smooth, which you just discussed. But instead of fit, fill, and stretch, you have translation, scale, rotation, anchor, and crop controls. Translation is left to right movement and up to down movement. The x-axis is this one. The y-axis is this one. If you were like me and you find that difficult to remember, a wonderful set designer who I know once was teaching me something in Vectorworks, and I admitted that I had a hard time with which axis is which. And she said, X is a cross, right? And I say, sure. She said, X is a cross. And I have never forgotten it since, so hopefully, if you are like me and have trouble with that, this will aid you. If you are not like me and you've never had trouble with it, now you have something to say when someone else has trouble with it. You can move in X and Y axis. You can also rotate in 3 dimensions. Rotating around the X axis means tipping forward or back. Rotating around the Y axis means tipping left and right. The axis is like an axle. that the thing spins around. Rotating around the z-axis, which is this one, means spinning. T-axis. What's that one? Oh, no. This is the t-axis.
There you go.
And it doesn't, there's no spinning happening here. No. Now, QLab uses a kind of 3D rotation math that produces very smooth movement between arbitrary rotations, no matter how dramatic they are. All three of these marks that I've selected, these just arbitrary 3D positionings, no matter which I fade between, it always moves smoothly. If you've ever seen sort of cheaply done keyframe animation of like figures, you find sometimes like they're trying to like move their arms and it looks weird and choppy. This is the other kind, right? The rotation of a cue is represented by a kind of number or a set of numbers called a quaternion, which is above my pay grade. See aforementioned notes about Montessori school and selecting my path through life to avoid doing math. The metaphor is this. The cue exists inside a ball. The surface of the ball has a handle on it that lets you move the cue around. You can twist the knob, and you can move it anywhere you like on the ball, and the cue always stays facing the knob. Good news is I can get from any orientation to any other orientation by simply dragging the knob in a straight line across the ball, straight from the perspective of the ball. It is, of course, from an outside observer, an arc. But from the perspective of on the ball, it is a straight line, with or without some amount of twisting the knob. That's the good news. The bad news is, if you want to move a cue more than 180 degrees in any one direction, the shortest path will be going the other way, right? If I want to spin a cue 360 degrees around, the shortest path from here to here is to not move. My favorite kind. But we have an option for you. A fade cue can rotate or scale or translate, right? But a fade cue can also be used, salud, to rotate a cue not in 3D orientation, but around a specific axis. And when you use a single axis, QLab sets aside the quaternions and just spins the cue some number of degrees according to your wishes. So this cue will rotate the Z around the Z-axis 3,600 degrees, or 10 full spins. That lets you do the extra read all about it news animation, right? I'd like to point out that when you do that, you can imagine that the original position of the cue is like an indexed position at 0 degrees. When you rotate it 3,600 degrees, you've moved the position of the cue from 0 to 3,600. If you want to do that again, another cue to 3,600 will do nothing. It's already at position 3,600. If I wanted to do it again, I would have to make another cue that sends it to 7,200. Spotlight is my friend. If I want to send it back to where it was, I have to rotate it to position 0. I don't subtract 3,600. I don't send it to negative 3,600, right? I just send it to 0. One of the things that can vex people when using quaternion rotation is that when you set a position of a queue in 3D space, to do that, you click on one of the axis buttons and then drag, or you click and start typing numbers. But when you click again, the numbers you typed are gone, because these controls are not showing you what is the current location of the queue according to some axis. These controls are, how much would you like me to turn the queue in a direction? The actual position of the queue in 3D space is represented by a quaternion, which is 4 numbers that I don't understand, and I challenge anyone to look at 4 numbers and tell me and predict the 3D orientation of the queue. It is not directly obvious. So what happens here is, each time you open up these controls, you get a box that says how much you want to go. But when the control is done moving, that's just the place the queue is in 3D rotation. And people say, but Sam, I would like to know where the queue is. And I say, you know where the queue is. It's right there. Look at it. It's turned kind of like that. And then they say, okay, yeah, but what if I want to make another queue turn just like this? How can I know? And I say, you can copy this queue's rotation and paste it onto that queue. But I won't know the numbers. And I said, does the audience know the numbers? No, they do not. Does the queue look nice to them? Yes, it does. So get on with it. The trouble is, expressing the numbers usefully is challenging. Expressing the numbers productively, like usefully, no, what am I trying to say? Expressing the numbers in a way that you can read and make sense of them is not easy to do. So instead, we have made a tool here that hopefully makes it easy to use to actually move the queue around in space. That's really my whole point. Relative queues, of course, exist. And I want to show a scale change that is relative. I've made this queue relative, and the scale is 1.1. Every time I hit this queue, I get a 10% increase in size, right? Because it's multiplicative. 1.1 times the scale is 10% larger than it was before. Every time I hit this 0.9 queue, it reduces by 10%. Relative rotation also works, but I'm here to tell you it's not what you expect. Every time you hit a 3D rotation that is relative, the math is right, but the behavior feels weird. And getting it done backwards, like you'd think, all right, if I just go 1, 2, 3, 4 times in one direction, I should be able to just get it back to where it was by going 1, 2, 3, 4 times back the other direction. But the answer is no, you cannot, because quaternion math is hard. All I want to say is that quaternion math is hard, and relative rotations is hard, and doing them both is hard, and if it looks good, it is good. And if it doesn't look good, keep changing it till you do like how it looks, and then you've done it right. And we try to give you as many tools as possible. Single axis rotation is very predictable. 1, 2, 3, 4, 5, 6 spins in one direction. Then I take the exact same axis and spin the opposite way, 1, 2, 3, 4, 5, and it's right back where it was. So single axis fades with relative math, quite logical. But the reason that the other one is not quite logical is because math is hard. Now, all the queues we've been looking at so far that have been rotating and moving have been using the center of the queue as the origin of the queue. And that's an unusual thing for QLab to do. Many other video tools choose the lower left corner as the origin. I would say that's probably the most common. Some use the upper left. Apple, in their infinite wisdom, uses the lower left sometimes, the upper left sometimes, depending. And do they tell you when they use which? No, they do not. QLab uses the center of a queue as its origin because that is the way that we feel you can get the most predictable behavior when you have an arbitrary sized stage on which you can play arbitrary sized cues. If you want to just throw up a bunch of images, they all align center to center. That's nice and easy. If you had them all align lower left corner to lower left corner, your eye would be jumping around more as each cue played. Of course, you can move anything the way you want it, but we feel that the center aligned default provides the most sort of straightforward and predictable behavior. But if you have a door and you want to open it by using a y-axis rotation, it looks weird because it pivots around its center point. But the anchor parameter lets you move this little blue plus from the center of the queue to some other place. And then that becomes the center of the queue as far as fades are concerned. So by putting the anchor aligned with the left edge of the door where the hinges go, not so bad. Video effects, we have them. End of lesson. No, not true. The next, I'm glossing over the time and loops tab, and the reason I'm glossing over it is you've already learned everything there is to know about it when we talked about audio. Everything you can do in an audio queue, you can also do in a video queue, slicing, looping, vamping, devamping. But let me tell you, it's a little tricky to do that in a video queue that has no audio track because there's nothing you can see here to work on. Which is why, for many reasons, this is the least of them, I encourage you to put, by default, an audio track in all of your video queues. If it's silence, that's fine. If it's a metronome, that's even better. Just something so that you can count your regular units of time and just make it easier to work with this tool visually. So that's the time and loops tab. The video effects tab is a lot like the audio effects tab for audio cues. We're going to talk about blend mode separately. But it lets you add a video effect the same way audio cues let you add an audio effect. The difference is there is no audio unit equivalent for video effects. There are a lot of video effect formats that aspire to be like the audio unit, but nothing has really clicked. There is no universally functional video effect plugin format. So all these effects that we have here were made for QLab specifically and are built into QLab. This selection of video effects expands upon the QLab 4 list of video effects greatly, but omits one essential video effect that we used to have in 4, which I want to talk about briefly, which is use your own. QLab 4 used a kind of an underlying video technology called Quartz, and Apple had a program that they made and let people download called Quartz Composer, which allowed you to produce your own video effects in the Quartz video rendering system. And Quartz Composer is super cool, and Apple killed it. And Apple stopped using Quartz, and we stopped using Quartz. QLab 5 uses Metal, which is Apple's newer video toolbox, which is much better performing and much more capable, but it has some limits, and one of them is no Quartz Composer, or no Quartz Composer equivalent. But we did some triage of all the times that people talk to us in QLab 4 about video effects, and we've determined that this list of effects that we have now, plus the addition of blend modes, plus the addition of a feature which I'm just about to describe, covers, we think, the vast majority of situations in which a person chose to use their own effect that they made in Quartz Composer. So while this is technically the removal of a feature, it feels probable that the total result is you're basically still going to be able to do what you were able to do before. If that's not true, let us know, because we're eager to make sure that we can cover all those use cases. We just can't cover it with Quartz Composer because Quartz Composer doesn't work anymore. And that's on Apple, not on us. And I mean, for good reason. It was old. It was time to move on to a new and more powerful thing. This video cue is playing with a hexagonal pixelate effect. Fade cues can target video effects and change their parameters. Which can be a little trippy on the eyes with this particular effect. The thing I said I was about to talk about in a moment, which is a new feature that QLab 5 has that enables you to do things that QLab 4 didn't, is you can also put multiple video effects on a cue. So this has a crystallize effect, but now I'm going to fade in a zoom blur on top of that. Here we have two video effects, crystallize and pointillize, and zoom blur. And the order matters. So this effect is getting crystallized, then it's getting zoom blurred. If I drag them into a different order, now it's getting zoom blurred and then crystallized.
This is what happens when you spin around the time axis.
Yeah, I do not like it. I'm going back to the other. That feels safer. You can add as many video effects to a cue as you like. You are limited only by your computer's processing power. I just heard the fan turn on. That's exciting. Well, I was covering the vent hole and rendering video effects at the same time. If I stop the cue, will you settle down? No, doesn't matter. It's running just fine.
I think it's notable that that was surprising to Sam. Right? I mean, we're not used, in the olden days, I mean, Sam will talk about this more, but in the olden days, having fans running loudly and often was common. And with Apple Silicon and the newer machines and with Metal and with the new rendering engine in QLab 5, it is much less common.
Yeah. The show that I learned that the French keyboard is a hassle in QLab was a video mapping installation that I helped develop in a castle in Provence. And this installation was leveraging a law that is true in France, which is they've got so many castles lying around that if you buy one and renovate it into something that is available to the public in any form and which celebrates or showcases or demonstrates the history or culture that that castle is a part of, the government of France will foot your bill 50%. They'll go halvesies with you. So a gentleman who it turns out is the 6th richest man in France bought this castle, immediately spent the exact same amount of money he spent buying it, repairing it to meet modern seismic code, and then began developing it into a themed attraction which told the history of this particular castle and the eccentric individual who owned it, who was a minor naval hero for France. Most notable, and this is why he was so popular in France, his most notable thing was that he was captured by the British Navy, imprisoned, and he escaped prison, stole a boat and sailed back to France, and then turned around and sunk some British ships. And like, as far as I can understand it, that is kind of the pinnacle of French victory, is like, something bad happened to me, I not only solved it, but stuck it to the Brits in the solution, which it really seems to me is the thing that makes them the most excited. And I can get behind that. The British Navy is a bully, and this castle was owned by this guy. And so you go through the castle and you see the story of the guy going to sea and getting shipwrecked, and there's like one room you go in, it's like the edge of a ship is there, and it's like pouring water, and there's all this thunder and lightning all around, and you hear, I'm told, because I can't speak French, you hear voices saying like, oh no, we're being shipwrecked, look out, there's the British Navy, oh no, we're screwed. And then in the next room is like, and then he was in prison. And it's like a little prison, and you can see the shadow of the guy pacing back and forth behind a prison wall. It's very, very cool installation. The part I was supposed to do was called the voûte, which means vault, which is a long hallway, very damp. The ceiling was very damp. The floor was very dry and very dusty. And the hallway was lined with 16 HD projectors. 16 HD projectors and going the length of it, then a pair of HD projectors mapping the end of the wall, and then inset in a window was a 4K 60-inch television built in architecturally to a fake window, as though it's the air outside the window. And driving all of these projectors, they wanted one animation to play throughout the whole thing. And you walk into the voûte, and then as you walk through, it's the story of the bâtisseurs, which are the monks who built the castle out of raw monk stuff, or I don't know what. Rocks? Presumably, yeah, I assume. But special French rocks from Provence. So you walk in, and the animation is, it's like 30 feet long and 16 feet high, and the ceiling is arched. So all of these video projectors are overlapping enough that you can create a blended single image. And driving this thing were two Mac Pros, 2019 Mac Pros, fully loaded double video cards in each. Each cost 35,000 euro, plus the projectors. So just the Macs, 35,000 euro a piece. So I'm sitting in front of 70,000 euro worth of video projection power. This thing, well, no, that's not true. The last time I did this class, I had a Mac Studio here, the M1 Ultra Mac Studio. That M1 Ultra Mac Studio cost $8,500, and it would absolutely outperform the $70,000 worth of Intel Mac Pro. The degree to which the Apple Silicon processor is more capable for a variety of tasks, including those which QLab are most regularly engaged in, cannot be overstated. It is stupidly better. It is wildly better. And so had they chosen to do a refresh at any time now, if they choose to do that, I would go in there and replace two huge rack-mounted fans screaming. They had an air conditioner ducted straight into the vent hole on the rack where the two Mac Pros were, through like 3 layers of filtration because everything is covered in what I called voûte dust. I don't know what it actually was, but it was awful. No, just get rid of that. Give me one of these. It's this big. End of story. Okay. Point is, when I would run this effect on the Mac Pro, the fan would go from loud to excruciating. When I'm running it on the M4, is this an M4 and M4 Pro?
M4, but there's 3 Blackmagic cards in there which get toasty.
Yeah. So M4 vanilla here. Up until this, Mini, yeah. So this is Apple's entry-level Mac. It costs $600. Yep. The fan was not running at all. And it's already quieted down now that I've shut off that queue. So it goes from no fan, or inaudible, to running this queue, and I'm like, oh, I can kind of hear a fan. You put it under your desk or in a rack, backstage, end of story, no problem. But the zoom blur is the secret weapon. If you want to find out whether you have a computer that can hold its own or not, throw a couple of zoom blurs at it. For whatever reason, that really grinds their gears. I'm sorry? Thank you. I thought you said a word in French that maybe I was hoping was zoom blur in French. Yeah. I also don't got no French. Okay. So that's multiple effects. Yes, Alec.
Now that we're in video world, would it be worth touching on Always Audition so people can play around?
That's a good idea. Okay. I'm thinking of an Eddie Izzard bit about when she did a stand-up act in Great Britain that she had done in America, and she did something very, very English, and everyone laughed, and then she said, Did you change that bit when you did America? Nope, left it the same, couldn't care. And then she did another bit where it was like, and does that come after that? Was there a connecty bit? Did you write a connecty bit? Nope, no connecty bit. And so right now, no connecty bit. We're just going to jump to a completely different topic briefly. No connecty bit, but once we finish this topic, you with Max there will be able to play video on your screen without taking over your screen. No, you know what? I'm not even going to do it fully. I'm just going to do this. For those of you who want to play video on your Mac right now, please to go to Tools menu and choose Turn on Always Audition. When you do that, your Go button will become an Audition button. When you play video with the Audition button instead of with the Go button, it appears in its own separate window. There's good, interesting stuff to teach you about that, which I will, I promise, later. But for now, you just have this window that you can look at video in your own screen without obliterating everything else you're looking at. Does everyone who want to understand that understand it sufficiently? Okay, great. And then more teaching about this topic later. Thank you, Alec. Yeah.
I'll answer the earlier question.
Oh, great.
I was looking for a good spot where you would be paused. But the answer to, if you check the smooth box there, what kind of smoothing is that doing? It's doing bilinear interpolation, which if you're selecting between different options for making things smooth, is on the very fast to do, which is why it's what our default thing to do, but not the prettiest of everything. We've never gotten a complaint. We could easily add other stuff like bicubic and Lanczos, if that's how that's pronounced. I don't know how that's pronounced. We could add other options, but bilinear seems to have been enough for most people. People don't seem to complain, so we haven't bothered to add it. So if you have a problem, and if you want something different, write us and tell us, and we'll add a issue.
Neat. Bilinear, bicubic, and what's the other one?
Lanczos, Lanczos.
Oh, Lanczos, yeah.
I'm not sure how to pronounce it.
I've seen that word and also wondered how to pronounce it.
Yeah, we could add those. We just haven't done it.
Cool. Does bilinear interpolation suit your needs?
I work for a university theater department, so yes.
So yeah, okay, great. Excellent. Thank you for that, Chad. I appreciate it. I also wondered, but never thought to ask. All right, the next thing I want to talk about is the blend mode menu here in the effects tab of video cues. Here's a video cue, that same video cue that I was playing before. And now I'm going to, it's playing on layer 1. Here is a video cue, an overhead shot of the ocean. It is playing on layer 2. But this video cue is playing with a blend mode of difference. The blend mode of a video signal, what that means is, how does that signal composite or add up or combine with the video signal that is below it in terms of layers, right? The default behavior of QLab, a normal blend mode, is a fully opaque video cue on a higher layer will completely obscure a video cue on a lower layer, which is like how real objects work in actual space, and so that's fairly easy to understand. If I have an image and then an image, and this image is completely opaque, this image becomes completely invisible. But because I have a lot of light here, and this paper is kind of thin, if I hold them properly, now this is harder, this is easier for me to see than for you. You can kind of make out, you know what, here we go, here we go. I'm going to put them in front of a, go over there, in front of a bright thing. What's behind shines through, right? It means the thing on top is not fully opaque. That is blend mode. A cue's opacity is on a scale of 0 to 100%, and that means actual opacity assuming a normal blend mode. But because we have multiple blend modes available, different effects can be achieved. This is a part of QLab that is a little bit difficult for me because I have found the names of blend modes, and we use fairly standard names for blend modes. I find the name of blend modes almost impossible to latch onto for reasons that maybe a psychologist can interpret. I just can't latch on to what these words mean. So here in the dock, under Video Blend Modes, I have a series of textual explanations. The Darken Blend mode creates pixels made of the darkest value from each channel. That means the lower layer and the higher layer. Each channel of each source pixel. So red channel, green channel, blue channel. The Multiply creates pixels by multiplying channel values together, blah, 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 blah. What I've done here is basically made that demo and then made little animations of each version of their compositing using each blend mode. I've scoured the internet and found every definition of the overlay blend mode that I could find. And I kept reading them until one of them made more sense than the others. And then I rewrote that one in hopefully even the clearer language. So I did all this homework, so then made all these little thumbnails. And the truth is, even after doing that, I still can't keep track of them. So for me, for this guy, the way I do is I always just either refer to this page or click through blend modes until I like what I'm looking at. But between blend modes, multiple video effects, and the increased power of modern Macs running the more efficient video engine based on Metal in QLab 5, the number of different looks that you can achieve in QLab is dramatically increased. So this is an area which I think really profits from enthusiastic experimentation. So I encourage you to grab video material. I use, if you don't have access to a lot of video material, well, first of all, anything you shoot with your phone will work nicely. But second of all, Pond 5 is a relatively affordable stock video site. And they offer low-res downloads of all of their material. It's just got a watermark and has a guy saying Pond 5 every 15 seconds, which is kind of irritating. But if you just need to get some video to work with, that's a great way to go. I don't have any recommendation like freesound.org for video. Freesound.org is my go-to recommendation for free sounds. Pexels, P-E-X-E-L-S, is another resource. Do they have a good free library?
They have a great video library.
Both these are from Pexels, but I bought them because they seemed well-priced and they looked really nice, and I was looking for something specific. I didn't know they have free stuff. Pexels, P-E-X-E-L-S. Pixabay. Okay. Something that you should not do is just rip stuff off of YouTube, because that's someone's property. YouTube's default posture is that the copyright for the video belongs to the person who posted the video, and just pulling something off of YouTube and playing it is not legal. Yeah?
YouTube does, however, have a pretty fat library of free-to-use music and sound effects.
I'm glad to hear that.
If you go into just like YouTube Studio, which if you have an account, anytime you upload a video, there's like the YouTube Studio section of the site.
Yeah.
Down near the bottom, there's like a big sound library. I pull stuff from there all the time. I've never had a problem.
Cool. Very cool. And if you're looking for paid to use, the thing you're looking for, the rights that you're looking for are complicated for video, right? Because most video clip sale websites assume you're going to use the clip either for broadcast or for distribution, like on a DVD, or for download, or for use embedded on a website. It's very difficult to find a set of rights that explicitly include live playback in a theater. So you have to sort of read between the lines and try to figure out what is the most appropriate source, or as much as possible, shoot your own footage or use stock footage that is royalty-free and usable sort of in an unencumbered way. But that's a topic for another class. Another, the last setting on the geometry tab, which we haven't yet talked about, is the crop setting. I'm going to just play our F train here. The crop, oh, baby girl. The crop control here, which is not addressable with a fade cue, is sort of like the trim tab for audio. Crop lets you crop in the video material. So if you're trying to use only a subset of the pixels in a cue, it's also kind of analogous to the start time and end time. It's just spatial instead of temporal, right? These controls, which again can't be faded, also exist in the video effects tab as shuttering or windowing, which are two different ways to solve the same problem. These are fadeable. So if you want to adjust the crop of a cue dynamically using a fade cue, don't use the built-in crop control. Use the video effect, either shutter or window. I want to talk about why they're different. Hang on. I want to talk about why and how they're different. That cue is cropped using the unfadeable crop controls, right? The one farthest to my right. This cue is shuttered. Both of them have a zoom blur, but the cropped cue, the boundaries of the cue are brought in by the crop, and the zoom blur can't extend past. The zoom blur causes the number of pixels that a cue wants to use to be greater than the original number of pixels because it's blurring outward. But the crop is an absolute, non-negotiable final limit to the number of pixels being used by the source cue. So when you crop, it is always a final step. But a cue that is using the shutter effect can have that shutter effect render before the zoom blur, and so the zoom blur can exceed the bounds of the shutter, right? I could also reorder it and put the shutter afterwards, and then pull the shutters in to simulate exactly the crop effect. Well, not exactly, but you get the idea, right? So that's the essential difference between crop and shutter. The difference between shutter and window is simply one of nomenclature. Window lets you set a width and a height for the cue and an origin X and Y point for the window to be anchored in. So right now it's anchored in the lower left corner, and we're shuttering in from one side and in from the top. That's window. Shutter is a left, right, top, bottom control. And, interesting to me, a feather effect. When feather goes all the way, it gets rounder. When feather goes to 0, it stays rectangular. I'm sorry, that's not true. I made a mistake. I misspoke. Feather softens the edges of the shuttering. Separate question is rectangle or ellipse. I can make it elliptical, or I can make it rectangular, and I can make it hard-edged or soft-edged using these controls. Okay. That is a quick summary of the total list of the powers of the video cue. Understanding that a video cue which has audio track in it has some additional powers because it has audio. You've already learned almost all of the things that there are to say about audio, but I just realized that I'm not sure I have a video on here that has a soundtrack. Yes, here we go. There is. I thought ahead. We're going to go all the way back to the I/O tab now that we have this audio cue, this video cue here that's targeting a piece of media that has an audio track. In fact, it has more than one audio track. This menu, the audio format menu, appears when your target video file has at least one audio track. And now we have to have an excruciatingly pedantic discussion about the difference between tracks and channels. These are things that are used pretty interchangeably by a lot of people, but folks who make vinyl records do not use them interchangeably, right? The record has two channels, but each song is its own track. CD has two channels, but each song is its own track. In the world of digital video, a video file can have any number of tracks. Each track can have up to 16 channels. So, when you pop a DVD in a DVD player or a Blu-ray in a Blu-ray player for a commercially made film, you can choose your audio track. Is it the full surround stereo, the full surround mix as originally made by, released by the filmmaker? Is it the full surround version dubbed into another language? Is it a stereo mix down because you don't have surround speakers at home, you have just two little stereo speakers or those speakers built in your TV? Is it a closed caption track? Blah, 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 blah. So each track can have some number of channels. The channels refer to the number of speakers. So the surround channels, the surround track might have left, center, right, sub, left surround, right surround. Or the stereo version might just have two channels, left and right, yeah? QLab 5 supports you using any one track of a video file at a time. And then, once you choose which track you're using, QLab can use all the channels in that track. Since the limit of channels in a track is 16, and QLab's limit of channels in a queue is 24, which is greater, we're always ready to rock with all of the channels that happen to be there. So here in audio format, I see we have two tracks available. One is an MPEG-4 AAC track that is labeled as being in English with two channels in a stereo configuration at 48 kilohertz. The other is an AC3 encoded audio track. That's a Dolby audio format. Also in English, two channels, stereo left, right, 48 kilohertz. So I pick the one I want, and then that's the audio that gets played when the video cue plays. Since there is an audio track, at least one audio track in the queue, in the target file, I'm also given the opportunity to choose an audio output patch to use. Salud. I'm also given this option here, follow video clock or follow audio clock. And here we're going to draw upon our earlier clock discussion. When a video cue plays, how often should it update itself? Well, if it's a 24 frames per second video cue, we'd like to update it 24 frames per second. But if it's a 24-second video cue playing on a 60 frames per second screen, I guess we should update it 60 times a second, right? Because the screen is updating 60 times a second. Well, what if it's a video cue that's playing on two screens at once, and one is 60 frames per second, and one is 30? Okay, now it's got an audio track. The audio track is playing to an audio device that's updating at 48,000 times per second. which of these clocks is going to be the clock that drives the playback of the video cue. And it used to be that QLab's policy was a video cue that has no audio track updates according to the clock of the video device it plays to. If it's playing to multiple video devices, it chooses one of those two. If the video cue has an audio track, then it follows the clock of the audio device. Okay, but then we run into problems where if the audio clock and the video clock, which cannot talk to each other, have a disagreement about when the edge of one frame should stop and the beginning of and the next frame should begin, if we are following no, let me say it this way. This is hard. Let's imagine that we travel through time slower so that 24 frames per second looks like this, and we can see each frame coming on, lasting for some time, and then coming out. So each frame is like a chunk of time, right? If QLab is supplying frames according to the tempo of the screen that's displaying it, the screen can be like, I'm updating at this tempo, give me a new frame, and now a new frame, and now a new frame. And so the synchronization of each frame coming out of the video file and each refresh of the screen will be perfect because the screen is in charge of asking for the new frame. Beaut. But if the video cue is following the audio device's clock, which goes way faster, right? 44,100 times per second instead of 24, or even faster. Usually it's great. New frame, new frame, new frame, new frame, new frame. No problem. Here you go, here you go, here you go. But what if it doesn't line up mathematically so that the screen is asking for a new frame at this exact moment and the audio device is ready to give you a frame at that exact moment? What if the audio device wants to give you a frame very slightly later? You will get a momentary visual glitch in your video playback. Even if you have a very fast Mac, even if you have a very high quality screen, even if you have a very well put together video file, you will have these momentary glitches if the playback of the video file follows the audio device's clock and the audio device's clock and the video device's clock are not in direct communication, which they usually aren't. So, we allow you to choose. Is this cue going to follow the video clock and allow for the fact that it's plausible that every now and then there'll be an audio glitch, which sound like a little pop, which is the exact same problem happening on the audio side that I was describing on the video side? Or are we going to have it follow the audio clock and allow for the possibility of a small video glitch every now and then? Unless your clocks are synced together in hardware, unless you have your video device and your audio device having an external clock sync, you gotta have to choose one or the other. So rather than make that choice for you, we let you choose. And you can decide, well, I'm doing a show in a context where a very small visual glitch will be eye-catching, but a one sample glitch out of 48,000 samples per second is unlikely to be caught because I'm playing some mushy, floppy Brian Eno ambient, who knows what, and a little glitch is going to be very difficult to catch. Or you could say, I'm actually playing a meticulously recorded classical orchestral piece, and a minute glitch is going to be very, very noticeable, and my video is some very mushy, smudgy stuff, and a small glitch will not be noticed. So I can make that choice on my own and allow for the possibility of a slight glitch on one side or the other according to my design choices.
To add a little deeper dive into that answer, it's almost always safe to have the video clock, to follow the video clock, because most of the time the quote-unquote problem you're going to hit is less likely to be a glitch or a dropped frame of audio, because the nice thing about audio is you can stretch it. You can sort of speed it up and slow it down in small amounts and not notice that. And so we are able to do that. So if we're following the video clock, which we do by default, and it is technically true that the audio is not playing back exactly the same way it would if it's following the audio clock, but usually the way it changes is that we have to just do a tiny amount of speed up or slow down here and there that you actually can't hear.
Right. If we play back a 48,000 sample per second track, for 3/4 of a second, we play it back at 48,001 samples per second, you won't hear that difference.
Right. So in most cases, if you follow the video clock, that's what you want because the video will be perfect, the audio will be, as far as you can tell, perfect, and you move on with your life. So that's 99% of the time, that's what you want. The other 1% of the time is you really care about how fast the audio clock is going over a long period of time. You're trying to synchronize a video to an audio track that runs for a very long time, and those two clocks would be drifting otherwise, like a movie that runs for 2 hours, and you don't care about maybe 1 or 2 dropped video frames, but you definitely don't want the audio of the actor speaking in it to drift away from the video that they're seeing, those kinds of things.
Yeah. Yeah, Alec.
I had a project recently where I needed to play 4 4K videos that are 10 minutes long at exactly the same rate. Like play 4 videos to 4 projectors. I could have solved it otherwise, but it had to be done this way. And I needed to set the to-follow audio clock for those videos to be in perfect frame sync with each other over that long duration.
Right, because your 4 projectors had no Genlock port, so you couldn't Genlock the projectors together, right?
There was SDI there was an FX4 SDI in the middle. So theoretically I was using its video clock.
Huh. But yet they would drift?
Yeah.
Mm-hmm. So one thing that's nice is when multiple video cues, when multiple cues of any kind are playing to the same audio device, that audio device's clock is what's driving them. So any cues which are playing to the same audio device will stay clocked alike. If that clock goes off the rails, all the cues go off the rails together with it, but they are together. So Alec had 4 cues playing. All 4 cues are visually playing on different devices, but since they all had an audio track and the audio track was all assigned to the same device, that device's clock was in charge and they stayed in sync, which includes being wrong together if the clock is wrong, but at least it's together. Yeah. Okay, great. What did I want to say about audio? No, all I wanted to point out is that here we are with the Levels tab, the Objects tab, and the Trim tab and the Audio Effects tab, all available to this video queue, because this video queue has an audio track, and we're using that audio track, and a video queue that has a video with audio in it is kind of like a video queue with a built-in audio queue. So everything that happens in audio land can happen to a video queue that has an audio track. All the things you learned yesterday are pertinent. Yeah? Great. So we've been assigning these videos to this stage and displaying it here, and I want to talk about the video stage editor now, which is unquestionably the most complicated part of QLab. So we're just going to take a moment to appreciate that, and now we're going to dive into it. I mean it so much that I'm hiding other windows. Okay, here we are in Workspace Settings. There are 4 tabs: Video Outputs, Output Routing, Output Devices, and Video Inputs. Friends, I'm going to go backwards across this list from right to left. Not because it's in Hebrew, not because it's in Arabic, because I have tried teaching this both ways. And either way, you have to assume that you know something I haven't taught yet before it will all make sense. But by going backwards, there are the fewest number of those things. So we go backwards. The Video Inputs tab is the simplest. It has nothing to do with output. It's input only. The Video Inputs tab lets you create a patch that you will use to bring live video into QLab, just like an audio input patch lets you bring live audio into QLab. You can name your patches, and you can choose any video device that is available. QLab accepts USB-connected webcams, Blackmagic designs video devices. Blackmagic Designs is an Australian company. They make groovy video hardware that is relatively affordable. We get asked all the time, will you support Aja hardware? And the answer is we'd like to, but Aja makes it difficult. So it's on the list, but it's not high on the list until Aja makes our lives a little easier. The last conversation we had with them about it made it seem like they're going to make our lives a little easier. So the next time we dig into video input is the most likely time to see a change there. Hopefully we will. We also accept video into QLab using NDI, which is a network video protocol, kind of like Dante for video, which is not Dante for video, which also exists, which is a hassle. And then we also accept video over Siphon, which is a software technique for sharing video between two programs on the same computer. Not going to talk too much about it right now, but all of that is true, and when we talk about camera cues, we'll get back here. But that's the short version for video inputs. Output devices is the end of the signal path for video as far as QLab is concerned. The signal path is this. Cues play on stages. Stages are cut up into regions. Each region must go to a route. A route connects to a device. Cues to stages, stages made of regions, regions to routes, routes to devices. That is the whole signal path for video. If you do not need something complicated, most of the middle part of that is going to be something you don't interact with. But we're going to talk about all of it for those times when you do need it. We are starting at the end, devices. This computer monitor is a device. Those projectors are devices. An NDI send from this computer out to the network is a virtual device. Yeah? So in the Output Devices tab, we see a list of video output devices. The first three, whose names I cannot change, are actual physical devices. Device 1, Decimator, in all capitals, not because it's the 80s, but because they are very serious. Decimator is the name of this video scaler, right? This is a converter that accepts HDMI coming in and then does stuff with it. The main kind of stuff you might want to do with it is take a signal that is of one resolution and feed it into a device that only accepts video of a different resolution. But in this particular case, the purpose of the Decimator is to take a video signal out of the Mac, come to the Decimator, go out of the Decimator into this screen, and also come out of the Decimator and go somewhere else. No, not this screen.
That screen and that projector.
Yeah, this screen and that projector, yeah. So the Decimator is a hardware split that lets me and you see the same image, right? We could do some other clever trickery, but the Decimator makes it easiest. So that's Decimator. As far as the Mac is concerned, Decimator is the name of the display that's attached to the Mac. So when I go to System Settings, Displays, Decimator is the name of the display attached to this Mac. If I'm not running QLab, Decimator and this screen still work this way. Everything's just like this. Has nothing to do with QLab specifically. Okay. That's the first device. I'm showed its resolution here, which is what the device is reporting, and I'm showed its frame rate, which is what the device is reporting. The second device is called Output 1. That is not editable. The fact that it is not editable tells me that it is a real, actual device. Output 1, which also has a resolution of 1920 by 1080, I happen to know, because I talked with Alec, who configured this system. Output 1 is a Blackmagic Ultra Studio monitor, which is a little Thunderbolt connected device that produces video. QLab has software built into it which can communicate with the Blackmagic device. it circumvents the Mac itself. As far as the Mac is concerned, there is no screen called output 1. But QLab knows better. The reason that that's workable is because Thunderbolt is fast. And so we're sending data over this fast Thunderbolt bus to the Blackmagic device. And the Blackmagic device knows how to take that data and turn it into an image and send it out over HDMI or SDI. Yeah? If I had Final Cut connected, Final Cut would also be able to talk directly to it because Final Cut has a driver built in to talk to it. The fact that it doesn't communicate directly with the Mac OS, that it doesn't appear in system preferences, is an advantage to us because I cannot accidentally shove my mouse off the edge of this screen and onto that screen. I cannot accidentally have the menu bar appear on that screen. If I get a notification that I got a text message, which should not be enabled on the Show Mac, but if I did, it would not appear on the Blackmagic device. So we have many advantages. What are the disadvantages? One, more money. If I've got a Mac like this one, which supports multiple screens, I can just plug the screens right in and they work. Don't have to buy an extra thing. So that's one advantage. One disadvantage, it costs extra money. Second disadvantage, it takes a little more processing power because I'm bypassing the Mac OS's own considerable display management power, right? But in the modern day, a new Mac you buy today will have either Thunderbolt 4 or Thunderbolt 5, both of which have an enormous amount of bandwidth. And the modern Apple Silicon processors dedicate this is dull, so I'm just going to say computer stuff. It's very fast, does good work. Thunderbolt's no problem. So the thing that makes it technically not as power efficient as the built-in video is sort of an academic limitation because in truth, it gets it done. So who cares? And there's very, very little overhead. The final version is sort of, the final disadvantage is really just a version of the first disadvantage. These have a limit, resolution limit of 1920 by 1080. And the 4K models are noticeably more expensive and physically larger. So do you have a, yeah, this is what we're using, or this is the monitor, yeah. This is the Ultra Studio Mini monitor, right? Thunderbolt comes in here, video comes out there on either SDI or HDMI. It can only use broadcast compatible resolutions. If you've got a 1920 by 1200 projector, no you don't. It's a 1920 by 1080 projector because 1920 by 1200 is not a broadcast resolution. So it only supports broadcast resolutions. It takes up a Thunderbolt port, but it's nice and tiny. You want a 4K one? No problem, it's about that big. You want an 8K one? Sorry, that one's this big. Now, it's not because there's more pixels, right? More pixels, bigger box. It's not. It's because only their higher end boxes do higher resolution, and the higher end boxes also do more stuff and have knobs and buttons and things. They're all, compared to what they offer you, I think they're all extremely, extremely aggressively priced in a good way. This thing is $130? $130, right? That is phenomenal. 4K is not quite as amazingly priced. 8K is not quite as amazingly priced. Whereas the built-in HDMI port on this Mac Mini supports an 8K monitor. Like, so you've already got it. You already paid for it. It's free. So those are the disadvantages. I consider them to be relatively minor. But I wanted to disclose them, right? So that's my output 1 device. It's 1920 by 1080. It runs at 60 frames per second, and it is in 1080 by 60p mode, which means 1080p 60 mode, which means it is running at 60 frames per second progressive scanning, not interlaced scanning. If you don't know what that means, it looks nicer. That's all you really need to know right now. My third device is called Output 3, and I happen to know that it is another one of these guys, also built into this case. So those are the 3 physical outputs connected to my Mac. There's nothing I can do about them in here because they're real. But devices 4 through 12 are virtual devices. QLab can generate an NDI device or a siphon device and send video out of QLab as an NDI signal or a siphon signal. Siphon is simpler, so we'll talk about it first. QLab makes some video, puts it in memory. I made that video. Siphon says, draw a box around that memory and make it available to other software, also on the Mac. So that other software can be like, hey, look at that video you rendered. I'm going to do stuff with it too. It's a way of sharing video between programs that's very, very efficient. The good news is it's efficient. It's cheap for the computer to do. The bad news is it only works on the same Mac. So unless I'm running another video processing app right on this same computer, it's kind of no point to it. But something that I like using Siphon for sometimes is creating video in QLab, sending it out via Siphon, and then using that same Siphon source as an input to QLab, making a camera cue, and capturing that video back into QLab. Why would I do that? We'll see when we talk about camera cues. That's Siphon. If you have a Siphon device here, you can edit its properties here by giving it a name, pixel dimensions, and a frame rate. NDI is another type of output. NDI uses the network to transmit video. It was created by a company called NewTek. We have a license with NewTek to include their NDI smarts directly in QLab, and that allows QLab to produce an NDI send. NDI signals are much more complicated. They have pixel dimensions and they have a frame rate. They also have a pixel format. BGRA, which stands for blue, green, red, alpha. Alpha is transparency, is one format where the video has 4 channels of data, which for each pixel we have a number that represents how much blue is in that pixel, how much green is in that pixel, how much red is in that pixel, and how transparent is that pixel. That's one pixel format. Computers like BGRA. The other pixel format is Y''CBCR4:2:2, which let me tell you rolls right off the tongue. Y''CBCR422 is, none of these letters mean exactly what they sound like they mean. Y''CBCR is a video transmission standard which separates luminance, i.e. the brightness of any one pixel, with chrominance, i.e. the hue of that one pixel. The reason Y''CBCR exists is because when we invented color TV, and everyone had already bought a black and white TV, the folks who made TVs wanted people to buy color TVs. But the folks who made television said, if we stop transmitting in black and white and start transmitting in color, everyone with a black and white TV will not tune in. Not everyone's going to run out and buy a color TV today. And we're not going to spend double the money to transmit simultaneously in black and white and color. So what is it exactly that you want us to do, RCA Victrola? And what they came up with was exceedingly clever, which is the black and white TV signal was considered to be non-negotiable. The radio wave that goes through the air and sends a black and white image from the TV studio to your television is just a wave that describes, an encoded radio wave that describes the brightness of every pixel on your TV, according to a pattern so that it updates every pixel at the right time all across your television screen. You with me? So when they invented color TV, they were like, check it out. That signal is going to stay exactly as it is. It's going to keep telling you about the brightness of every pixel on your TV. And if you have a black and white television, you stay good. But your color TV is going to be clever enough to pick up a second signal that's going along with the first signal. And that second signal is going to say, what color is every pixel? Along with its brightness, which you already know about from the other signal. And that's chrominance. Y''CBCR, the Y is luminance. The CB is chrominance blue, and the CR is chrominance red. And the remainder of the signal, after you figure out how much red and how much blue to put, must be green, because all the pictures on your TV are made up of a mixture of red, green, and blue. The reason it's red, green, and blue is because the cones in our eyes are most closely aligned to pick up red, blue, and green light, although not truly really. It's much more complicated than that, and the trap that a person can fall into, certainly the trap that I fell into, is thinking that there's some fundamental truth of the universe that means that light is made up of red, green, and blue components, which is absolutely not so. But human perception is closely aligned to what we think of as red, closely aligned to what we think of as blue, and closely aligned to what we think of as green in our 3 photoreceptors for nearly all people that pick up color. So we have these channels red, green, and blue. Yeah? YCBCR format is available as a format to send video over NDI. All of that teaching I just did boils down to the following. Use one of them. If the picture doesn't show up on the other end, use the other one. The truth is that some devices can use either format and some devices can only use one or the other. If you are sending a video signal over NDI which requires transparency, you must use BGRA. If you are using a video signal over NDI that will be received by a broadcast-savvy piece of hardware that really is not meant to interact with computers at all, you almost certainly want YCBCR. Is good? The 4:2:2, I never remember exactly how it breaks down. It has to do with how nice does the picture look at the end. And the more 2s you see and the fewer 4s you see, the less nice it looks. If you see 3 4s, it looks really nice. If you see 1 2, it looks very nice. And if you see 2 2s, it looks okay. And if you see only 2s, I think you're not doing video anymore. NDI can also transmit audio embedded in the video signal because that's something that broadcast usually does. HDMI can do it, SDI can do it, so NDI can do it. You pick a number of audio channels, 0 to 16, a sample rate, and a buffer size. These are the defaults. If you want more channels, make more channels. If you want a different sample rate, go ahead. I don't know why 22050 is allowed. I assume it's because it's just a scratch track that no one cares about and you're trying to save bandwidth. I don't really know why 96K is allowed. I assume you're plugging into a Digico which requires 96K. Buffer size has to do with your tolerance for delay versus the possibility of dropouts. The bigger the buffer is, the higher inherent delay you have in your audio signal, but the more protected you are against momentary dropouts. The lower your buffer size, the less delay, but the more likely you are to have momentary dropouts if your network slows temporarily. I recommend leaving it at 48 kilohertz and 512 and just sort of not touching it unless you discover you need to. Yeah? Okay, great. That's NDI. These are all now the devices for getting video out of QLab. A screen that the Mac knows about, a Blackmagic device that the Mac doesn't know about, NDI, and Siphon. Yes? Okay. Now we step up the signal path one step to the output route. This is the head-bendiest part. This is the part that won't matter to some of you. It is okay if it doesn't matter to you. There are people who never need this part, but there are some people who always need this part. The route is what connects the stage to the device. The name of this route is stream. I created this route, I gave it a resolution of 1920 by 1080, and I told it that the device it's playing to is the device named NDI HD. That NDI stream is here in output devices. Oh, sorry, little miss SIRI. Something I say with the letter S and the vowel E somewhere in my voice makes her listen. I don't know what to say. And I know I'm not supposed to call it her. I know I'm supposed to call it it, but I can't help myself. It has anthropomorphized itself successfully. Okay, so the route named stream has a resolution of 1920 by 1080. It's going to the NDI HD device, and it's using the full raster of the device. Does everyone know what I mean when I say raster? Okay, great. Raster is an old-fashioned video term which is, doesn't really matter as much to use anymore, but is still useful to use. The raster is the addressable space of video of a thing. We're going to go back to the original. The first use of the word raster is a tube television. The way TVs worked was there's a little magnet that you could cleverly control to bend a beam of electrons getting shot at it by a ray. And you'd bend the beam of electrons to cross the back side of the glass of the TV screen and then go down a little bit and then cross again and go down a little bit and cross again and keep going. On the back side of the glass, they painted a bunch of tiny little dots with a phosphorescent paint. When an electron hits one of those dots, the dot lights up for a brief time. When you scan across the dots with the electron gun very quickly, in a very specific pattern of on and off, you get a picture. Each little dot is one element of that picture. That is where the word pixel comes from. Pixel is short for picture element. Each dot is a pixel on the back side of the glass of your TV tube. The entire space where dots got painted is the raster. It's the canvas. Modern screens don't use an electron gun and phosphorescent dots. They use little rectangles made of silicon that glow when electricity is applied to them. And the amount of electricity that's applied to them makes them glow a lot or not as much. And if you put 3 of them very close together, one of which glows red, one of which glows green, and one of which glows blue, those 3 together are considered 1 pixel. Sometimes it's 2 green ones together to make a nice tidy square. That's a pixel, and each color is a subpixel. But together, it's 1 pixel. The number of pixels in this piece of plastic here, all together, might be, it doesn't matter what number it is, but the whole space where those pixels are, that's the raster. So we can then say, okay, well, in NDI, which is imaginary and ephemeral and virtual, the raster is an imaginary rectangle, some number of pixels wide by some number of pixels high. That's the raster of the NDI feed. And when that NDI feed ends up in a device that decodes it and turns it into video, which is to say a signal that can make pixels do something, the raster of the video signal gets applied to the raster of the video display device. Yeah? So we've now latched onto this noun. Routes can do a clever little trick where you can say, route, pixels will come into you, and pixels will go out of you. When they come in, they are some size. They are a raster of some size. Please apply that raster to either the full raster of your device or a small portion of the raster of your device. For example, you can say, I have a device that accepts 1 video signal coming in and supplies 4 video signals coming out. Stream, I am so sorry. I just bumped my lavalier with this object, and I bet that sounded awful, especially if you're wearing headphones, and I really am sorry. I'm going to do it out here now. 1 video signal comes in, 4 video signals come out, and inside this screen, this box, is some cleverness, which takes the raster of the input and cuts it in quarters. And then each of the outputs is one of those quarters. Call it a display divider or a display slicer. When you take an input that is, for example, a 4K television signal, which is 3840 pixels by 24. No, this one's interesting. Okay. One sec. If you send a 4K signal into a display divider like that, and then you cut it in quarters, each quarter is a full HD raster, 1920 by 1080. Because the size of a 4K raster was defined as 4 HD rasters together. So if you have a display divider like this plugged into your Mac, which you might because it's a common thing for folks to want to do, you can tell the route only send to 1/4 of the output device's raster. This is how you can use 4 routes in QLab to turn one big 4K signal into 4 HD signals. Or to take 4 HD signals, put them together on a stage that is one big 4K stage, play that to a route which can then cut them in quarters, and then send that to 4 output devices, or one output device that cuts it in quarters. Do you basically understand the idea? Even if you don't understand the practicalities of each. The practicalities are particular to the device itself. So we can talk through those practicalities if you like, if this feels like something you might want to do. But I want to sort of get the premise in your heads. This all roots back with the M1 family of Macs supported only a single external display. But they had enough processing power for that single external display to be very high resolution. And people reasonably thought, I don't want a 4K screen on my stage. I want 4 HD screens. So why don't I take that 4K output from the Mac, cut it in quarters, and then use those 4 quarters anywhere I like in my theater. And for that, QLab needs to know that you're going to cut it up into quarters so that it gives you 4 separate signals, but it puts them in the right corner, the correct corner, for the divider to divide it up and then give you 4 signals. Yeah?
Is this a software version of what's happening at Buffalo Wild Wings when you see 4 TVs just stuck together with one football game on them? Is that what I'm understanding? Is like it's like splitting and then you can send it to 4 different places?
I'm glad you brought that up because I can actually use that to explain this one way better.
Great.
When you go to Buffalo Wild Wings,
I'm with you. I'm with you.
can you imagine this whole crew just showed up and they're like, hang on a second, are you here would you like the menu? No, we want to look at your TV for a minute. When you go to Buffalo Wild Wings and you look up over the bar, there's what looks like one enormous TV showing the football game. But when you look closer, what you actually see is it's actually 4 reasonably sized TVs clumped together really tightly, each showing 1/4 of a football game. Interestingly, they have chosen to divide the football game spatially rather than showing the 4 quarters of a football game in time. That'd be interesting too. Yeah. My upper left TV shows the first quarter of the game. Yeah, which is why you'll never see such a thing in Europe because you have 2 halves, right? Or in Canada, you do hockey in thirds, right? But they're metric thirds, which is, anyway. Okay. It's not one big TV showing the game. It's 4 smaller TVs, each showing 1/4 of the raster of the game, right? Why? Because an enormous 4K TV is extremely expensive, but 4 smaller HD TVs, very reasonable. In fact, 4 smaller HD TVs are considerably cheaper than one big 4K TV. So we have our satellite TV box or our cable box or whatever, our internet streaming thing or whatever, and it's giving me a 4K video signal. I want to show it up over the bar. If I had to put a big-ass 4K TV over the bar, it'd be a fortune. So I take that one 4K signal and I pipe it into this box. And it takes the upper left corner of that 4K signal and sends it to that TV. Takes the upper right corner and sends it to that TV. Takes the lower left and sends it to that TV, and takes the lower right and sends it to that TV. If my Mac is plugged into the divider and it just sends one 4K signal and then those 4 outputs make the 4 TVs, that's easy. But what if an enterprising person at Buffalo Wild Wings says, oh, no. I'm going to take those 4 TVs and I'm going to separate them. We're going to see the football game on that one, We're going to see a baseball game on that one. We're going to see a soccer game on that one. We're going to see a hockey game on that one. We're going to spread them out across. So I'm going to take one 4K raster coming out of my cable box. But that one 4K raster is going to have 4 TV shows on it in the 4 corners. The divider knows that we're cutting it in quarters. The TVs don't. How then do I tell the cable box, give me 4 shows in the 4 corners? That you can't do. But for QLab, all I need to do is make 4 video cues that are not full screen. 4 video cues that are, I'm going to have to, oh, is this bear? What size is this bear? Not the right size. Wrong size bear. Are you 1920 by 1080? You are. Okay, great. So all I have to do is take 4 video cues, each of which are placed in 1/4 of the raster. 1, 2, 3, 4. And then tell QLab that upper left corner is going to go to the first output on this slicer. The upper right is going to go to the second. And then my 4 individual cues can play to 4 individual outputs. All the while, the Mac thinks it's doing 1 4K screen. Has the penny dropped? This thing, Aja makes one called the HA4. And there's a new model that's got a slightly different name. But I like HA4 because I'm like, ha, 4. Just makes me laugh. The HA4 just takes 1 4K in, 4 HD out. This one is made by Alec. It's called the Slice 4. And this is interesting because it takes either HDMI or DisplayPort in and gives you 4 HD base T outputs. If you have a device that can accept HD base T video, you already know that it's groovy. If you have a device that cannot take HD base T, then understand that it's just basically like a video signal over what looks like Ethernet cable, but it's not Ethernet. It's just video signal. It's very useful. Matrox makes one called a quad head to go, and that one's pretty good. And then DataPath makes what's widely considered to be like the gold standard, the FX4 or HX4. DataPath is great. They're very well built. The fans are loud and they are very expensive. And the configuration software for them only runs on Windows, which for me makes it sort of inherently like impossible to think of it as having taste. But, what?
You're backwards. Quad head to go doesn't work.
Quad head only runs on Windows. That's right. I'm sorry. That's right. Quad head inherently difficult to think of as having taste because it only runs on Windows. But actually what's really going on is that Matrox is like heavily invested in selling these things to air traffic control centers. And air traffic control centers are built on Windows, and that's fine. That's whatever keeps the planes in the air. I do not care. So they have a sort of specific customer pipeline. It means that when we theater nerds buy a quad head, they're like, who are you and why do you only want one and not 40 of them? And we're like, please don't ask me questions, sell me the box, and let me go make a play. So Matrox is basically aimed not really at theater. DataPath's major customer is Buffalo Wild Wings, or the folks who do video displays in the walkway in the airport between security and your gate. And you're walking past all these big screens that are like a little fancier than you would expect. That's DataPath's main customer. And that's why I think it's especially groovy that Alec has brought these things out, because finally a manufacturer of the display slicers whose customer base is specifically theater. Okay, I told you this was the most complicated part. That's output routing. I'm going to go up a step. Video stages are the thing that cues know about. A cue plays to a stage, and what happens past a stage is not the cue's business. Everything we've been talking about for the last hour, not the cue's business. I'm going to hit the edit button next to this one stage, and we're going to look at the video stage editor. This is the window that lets me configure a video stage. The stage gets a name. I named it QClass. It gets its own layer, which is separate from QLayers. We're going to talk about those in a little bit. It has a checkbox, keep rendering between queues. We're going to talk about that in a little bit. It has a size. The raster of the video stage is 1920 by 1080. When you are making a stage, you can think of the pixel dimensions of the stage as sort of the home resolution of your project. People often used to ask, can QLab do 4K video? And my cheeky answer is QLab doesn't know what 4K means. 4K is not a meaningful term to me, to QLab. QLab just plays videos, and they are some number of pixels wide by some number of pixels high. The only important number when it comes to pixels in QLab is the limit on pixel dimensions in Metal, which is the programming toolbox that we use to build the QLab video system. And that is 16,300 and something? 384, thank you. 16,384 by 16,384. The largest any image can be in Metal is 16,384 by 16,384, and therefore that is the upper limit of a stage in QLab. Any individual video can play whatever size it is on a stage. You saw me play videos bigger or smaller than the stage. QLab does not care. Just as it doesn't care what sample rate your audio is, it does not care what pixel dimensions your video is. You do not need to convert all your videos to the appropriate pixel dimensions or frame rate. You just take some video, put it in your workspace, and play it. This stage is 1920 by 1080 because when I teach this class, most of the time I plug the system into a projector that is 1920 by 1080. So that was easiest for me. If we fast forward some years and the next version of this class gets built and I find, you know what, the majority of video projectors that I meet are 4K, then I will make the stage 4K. But here's the thing. It doesn't matter either way because the route which receives video from the stage has another set of powers which I was waiting until this moment to describe. You can edit a route, and the route has scaling mode. Just like cues, which play to full stage, can either be fit, fill, or stretch, routes can either be center, fit, fill, or stretch on their device. So if I have a stage which is 1920 by 1080, but a projector which is 4K, I can tell the route, listen, you're set to fill. So if I'm going to send you a 1920 by 1080 raster from the stage, but if your device is expecting a 4K raster, just go ahead and scale up and fill that whole raster. And QLab will do it automatically for you. Previously, to routes being invented, this was a big hassle. Or you needed one of these guys. You needed a decimator plugged in where the decimator told the Mac, I am HD, not 4K, don't worry, everything's fine, give me your pixels. And then my output will be 4K, and I'll handle this. But now, clickety, clickety, and it's done. Even more of a hassle was, I've done my show at 1920 by 1080, and I get to a little rinky-dink venue with a very old projector that they bought at Staples in 1997, and it is 1024 by 768. Optoma, right? Okay, Optoma, listen up. We're just going to fill that raster. Fill will scale my HD signal down to 1024 by 768 because 1024 by 768 is in exactly the same aspect ratio. They'll be black either on the top and bottom or on the sides, but no one cares. The picture will not be distorted. It will be fuzzy because it will be squinched, but it will be accurate. This alone, in my opinion, makes it worth spending 30 minutes on talking about all this. Because when I take my show on my computer and I go to your venue with your projector that is some number of pixels by some number of pixels, I don't know and I don't care, or God forbid it's through some Crestron nonsense that does who knows what to it, it just doesn't matter to me because the route takes care of it. La, 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 la. And my cues don't even know. As far as I'm concerned, I'm still doing 1920 by 1080. Disco. If the projector is mounted upside down, I can rotate the image 180 degrees. If the projector is mounted on its side, I can rotate the image by 90 or 270 degrees. If the projector is rear projecting and either doesn't have the ability to mirror its output or the infrared signal from the remote to tell it to do that is being blocked by the cyclorama, which is what usually happens to me, I can just set QLab to rear project here. Bada bing. This is the best part. But it takes so long to explain all the things you need to know before you get to this part to see why that's good. And I know that because I've tried just explaining this part and people are like, oh yeah, that seems nice. But they weren't like, what is it, right? So now you know what is it. So here's my stage. It's 1920 by 1080. Masks? What are masks? If I have, oh, come on now. If I have video playing onto this nice cyc like I do here, it's nice to see every corner of every edge, right? But what if my set designer had built some unusually shaped piece of scenery and I was trying to fit my projection into it? For that, we use a mask. A mask is just a black and white image, technically a grayscale image, but critically, not an image with any transparency. Fully opaque pixels only. When the mask is applied to a stage, it masks out all the pixels of the stage that correspond to the black pixels in the mask image. Now, it doesn't really mask them insofar as masking tape masks something. What it really does is cut them out. And that pertains to this layer business I was about to talk about earlier, and I said we'll get to it in a second, because not only do cues have layers, stages have layers. Oy. If I have two stages, both using the same projector as their device, and cues are playing to both of those stages, how should they composite? The answer is the layer of the stage dictates which cue is in front of which. All of the cues on the higher layered stage appear on top of all of the cues on the lower layered stage. So if I have a stage that is on layer 1, and I have a cue on that stage that is on layer top, then I have a cue that is on the other stage, which is on layer 2, and it's got a cue on layer bottom, I still see that bottom layered cue first, because its whole stage is on a higher layer. Yeah? So you can think of all the cues layers as being nested inside the stage layers. When you mask a cue, when you mask a stage, it cuts away the stage in the black pixels. So if there is a lower layered stage also running on this projector, you will see that lower layered stage playing through this dark area. Yeah? A lot of folks do not need this at all. A lot of folks do not need this at all. You could be one of them, in which case it is fine to blow past this. If I've got an unusual piece of scenery, though, the mask is a great way to keep my video off of it. The lower layer stage would not be off of the mask, and maybe that's part of the plan. Maybe I've got a frame, and I want one stage which plays video to the inside of the frame, and a second stage which plays video to the frame. Ooh, fun. That's the mask. The rest of the stage editor is made up of two tabs, the Layout tab and the Warping tab. In the Layout tab, we're going to define how the stage how the regions of the stage are laid out. A region is just a subset of the stage. Plain and simple. The most common way to do a region on a stage is to make one region that covers the whole stage, and that's what we've been doing today. I'm showing the grid for this region. The region covers the whole stage, and every pixel of the stage is visible on the region. I've also got a second region which covers the entire stage, and it's being sent to a second route. The route that it's going to is NDI HD. NDI HD is the NDI feed which is going out of my computer and into the computer in the booth to be sent to YouTube. So every pixel of this stage appears 2 times in the universe. One time it appears here, made of light from that projector on this screen. And the other time it appears is there in YouTube land, right? Because the 2 routes both cover the entire stage, every pixel of the stage appears in each route. When I play a cue onto that stage, this blue rectangle is the raster of the stage. If I play the cue like this, every pixel of the stage is filled with pixels from my cue. All those pixels appear here, all those pixels appear on the stream. If my cue is smaller than my full raster, the rest of these pixels contains no information, so QLab sends black. Jess? Is good.
In the case of the stream, it sends clear.
In the case of the stream, it sends, hang on, I'm not sure that's so. In the case of the stream, it does send clear because the pixel format of this NDI feed is BGRA. If the pixel format of this feed were YCBCR, it would send black because there is no transparency in YCBCR. Every pixel is fully opaque in YCBCR. But right, when I don't transmit pixels or when I don't transmit information to any portion of the NDI send that goes to YouTube, it sends clear pixels, which allows groovy compositing over there in the streaming software. So I've got these 2 regions. Each region covers the entire stage. Now, if I wanted, I could have regions that cover less than the entire stage. I could have each of these regions cover only half of the stage. And now, half of my stage would appear covering this whole projector. And the other half of my stage would appear on the stream.
If you click the grid, will I see it on the stream?
I suppose you will.
I hope so. I have to wait for 30 seconds to
Yeah,
find out.
for delay. Each half of my stage now gets 1 region, and each region goes to 1 route, and each route goes to 1 device, and each device actually produces visible output. The warping tab lets me define how the region appears within the raster of the route. The route accepts pixels from the region, right? But do I want to just fill every pixel of my route with every pixel of my region? Probably. But what happens if the projector is at a funny angle? I want to warp the output of the region within the route to counteract the funny angle of the projector. So here in my layout tab, I'm going to go back to showing everything full to avoid talking about 2 things at once. With the grid showing for my in-room route, I have warped the output here to counter-correct for the angle of the projector. Originally, when I had everything 1-to-1, this image appeared slightly askew. Because as you can see, the projector is slightly askew. It's actually impressively not that askew, given how far off axis it is. but it is askew. Ideally, the projector would be like this individual in the red shirt, where you're standing right above your head would be the perfect place for the projector. Right? We want to have it shooting straight at the screen at exactly a right angle, where the center of the lens of the projector is exactly aligned with the center of the space that I'm projecting on, and everything would be wonderful. The trouble is that in most theaters, that place is like not a place where you can put a thing, let alone a large thing. For some theaters, that's the balcony rail, which is why the two people who have the most expensive seats sitting on the balcony rail have an enormous projector with a huge fan blasting hot air in their face. I'm sorry?
Best seats in the house.
Yeah. Not the box seats, of course. But we can't put a projector there all the time, so we move it off to the side, and we warp the corners of the projection so that the angle of the projector is being offset by the warping here. Now, QLab's warping facility is quite robust. If I want to do more warping, I can split this region and warp it unusually. What if I'm projecting into the corner of a set? What if I'm projecting into the corner of a crumpled piece of paper? Right? What you're seeing, the black circle with yellow, is the control point that I've got actively selected. And when I move it around, it warps the corresponding sub-regions. If I have complex architecture that I'm projecting into, this is the view where I can correct for that architecture. If I have curvy architecture, I can use Bezier warping instead of Bezier starts with B and bendy starts with B. That's how I remember. Instead of perspective warping, which is for straight edges. There's also a kind of warp called linear. Linear warp is not perspective corrected, and this is one of the ones where I'm like, start here, and if it doesn't look good, switch to that, and if it looks better, good. That's my description of how to use linear warping. Yeah?
This is really a QLab question necessarily, but I was curious, I find this really cool. What's that method for, like, if you are projecting into something like really, for like tuning your warp to get it right? Is it literally just projecting it, adjusting it, and then
Oh yeah, me,
running
this,
to the
hours
wall
and hours.
going,
Yeah.
going like,
No, so there's a couple of different things. When I was in Provence, mapping the projectors in the voûte, Alana, my wife, and I were both hired, and we spent a week each, 8 hours a day in the voûte, and we had 2 iPads. And the iPad, running QLab Remote, has a way to remotely adjust the screen. So we were standing there with our pencils. She was like, I'm going to take projector 2. And I said, great, I'll take projector 6. So we were nowhere near each other, tweaking control points, drawing essentially. I was sitting there, because I work for QLab, I was sitting there thinking, if this project were 6 months later than today, we'd be doing this in QLab 5 and we would have been done by now. And then I thought that at the end of the first day, and then the second day I started to think that again, and I was like, actually, no, we wouldn't be done by now. We'd be done by yesterday. This same process in QLab 4 was pretty good. In QLab 5, it's very good. Essentially, what I ended up doing is drawing an inverted image of the architecture here. That's basically what you end up doing. Because of math, no matter how complicated this gets, the amount of work it takes to play video back remains constant. It uses something called a lookup table, which basically says, okay, do your crazy drawing, and then once you're done with that, there's like a quick reference, like source pixel belongs here, where does destination pixel belong here? Over 6, up 12. It's like plays Battleship really quickly. So you don't need to worry about performance implications of doing advanced warping. Warp away. The only thing I want to warn you about is that when your mesh splits number goes very high, this interface gets pretty sluggy. It's just sluggy. It's not problematic. But I was being a little glib in a QLab class, and I clicked all the way up to the maximum mesh splits, and then we watched my cursor beach ball as I just tried to move 1 point a few inches. I was on an older Mac, and I was like, okay, all right, Sam, cool your jets. Not the best demo. But you don't need to worry about any of the performance implications of using a very warped stage. It will just play just as easily as if it were unwarped. So yeah, the answer is you're basically just sitting here doing it. And you want to do it in a way where you are standing or sitting, ideally, if it's going to take a long time, square to the surface with a nice view of the whole surface, the literal surface that you're projecting on, and able to use either QLab directly, screen share into QLab, or move your computer down there, or use QLab collaboration, which we'll talk about tomorrow, or use QLab remote on an iPad to painstakingly move your control points exactly where they belong. Other questions? Yeah.
Is this how you would, let's imagine I have a complex object like that. Just say it's a cube.
Yeah.
And I can see 3 sides of it, and I want one video on this side of the cube, and a different video on the other side of the cube, and a third video on top. Would you recommend me going through and using like the, I forget the word, the Q word,
Quaternion.
Quaternion, like would you recommend me going in and making separate cues and tilting them and smushing them around so that they land where I want, or is it faster, more efficient, better to make a, not map, or what,
This.
make that.
Yeah.
Do the warping and do that as opposed to like adjusting the geometry in the cube.
Yeah, I'd make this.
Do that.
And well, it depends on how many cues you're going to make, right?
If I'm doing a bunch of different cues to the surfaces, do this.
So if I have a 3D object here, I can take my stage, I can make 3 regions on it, then I can warp those 3 regions so that each region maps to a surface of the actual cube that my projector is shooting at.
I propose a slight remix on this workflow. Make a separate stage for each side of the cube.
Oh, hang on a second. Let's wait till I finish, and then you can tell me if you still think this. Each of these regions represents one actual physical surface of the cube, right? Each of those regions feeds a siphon output in thirds. Intermed siphon. I'm sorry, I'm describing this badly. I'm going to start again. I've got 4 stages here. Cube top, cube left, cube right. Cube top projects onto the top of my cube. Cube top is just a stage where the full raster of the stage is warped to hit the top of the cube. Cube left is a stage hitting the left side of the cube, and cube right is hitting the right side. When I play video to each of those stages, all I have to do is play video to the stage, video output, cube top. From the cube's perspective, I'm just gonna right? I don't have an actual cube. From the cube's perspective, I'm just playing to a stage. But the end result, that's right. I'm going to turn this off because that's copywritten music. It's beautiful. Aaron Copeland, Appalachian Spring, highly recommended. If I had an actual cube that I'm projecting upon, the warp would be correct. I can play to the top of the cube only by sending this stage. But if I want to send to that stage, I did. You did? Okay. Yeah. I also have, oh, I see what I did there. Never mind. I'm mid-flight on a different version of this demo right now, which is what's going on, which is why I stalled myself. So now, go ahead, Alec. What's your recommendation?
I would personally make a different stage for each side of the face of the cube, so I can play different.
Top, left, right, like this. Yeah.
Without having, that way I can leave the geometry as fill, rather than needing to put them in sections of my stage.
So here are 3 video cues playing to cube top, left, and right. And you would make those 3 stages to hit the 3 sides of the cube, right?
Unless my video designer handed me a fancy unwrapped export from Blender of some sort of single file that contained 3 faces.
Yeah, I hear you.
They just done all that work for you before you got the cube.
But here's the thing. Here's also another version of the same where I'm playing to a single stage and a single, am I?
Way up top.
That's odd. Yeah. Who indeed did that? Yeah, there we go. All right.
When you have a second, could you double check the stream output?
None of this is playing to NDI, only the...
Yeah, this is just to in-room.
Okay.
Here is one video wrapped around the corner of a cube. Right? So this is a single video that I'm playing to a stage. The stage has 3 regions, which take bytes out of the 3 corners of the stage. The 3 corners of the stage. And then those 3 regions are wrapped around an imaginary cube.
And thus we're missing 25% of the video.
Right. The last quarter is absent. Alec's approach, which I think is also a good approach, is run 3 separate cues, 1 for each face.
That's what I was asking about.
If you want to run 3 cues, 1 on each face, this is your way. If you want to run 1 cue wrapped around, this is your way. But of course, you need a piece of media that understands that the upper right corner is missing. So for that, I spent a little more time than I'm proud of figuring out how to render, where are you? Rain Cube Corner. Rain Cube Corner was rendered in Apple Motion 3/4 of a square that produced one ideally sort of theoretically continuous image of water sort of spraying out of the corner of the top and pouring down both sides. I could do it in Blender and that would take even more time. But I thought I'd just do it, the cheap way, quicker, and even this took a long time. But this is a piece of imagery which is analogous to what we were talking about with the display slicer. The source material understands that we're only using 3/4 of the square. The stage with 3 regions. Those 3 regions all play to one route, but use different chunks of the route. And that one route plays to that projector here. The purple rectangle with the gray background and the grid lines represents the projector, the device that the routes are playing onto. Make sense? Okay. Not super straightforward. But what we've now done is gone all the way up the signal path and made a stage, in this case, warped for the in-room version of the region, not warped for the stream version, where this same space is where all of our cues are going to, and that same space doesn't need any real adjusting when I take this class and go and do it in some other venue. Even if I'm streaming or not streaming, who cares? The one that sends to NDI doesn't go anywhere. If I'm plugged into this projector, great. If I'm plugged into another projector, great. So that's stages all the way up. Do people feel as though they basically understand it? It's okay if you don't all the way understand it. Like with many things, the first time you hear something is unlikely to be the time that you're going to really latch. What's going to happen is the next time you need to deal with this, it won't feel like a foreign language. It'll feel like a thing you remember but don't quite know. And you'll muddle your way through, and then the next time you do it, you'll be like, no, I remember. I went to class, I learned how to do this, then I sat down and did it myself. It wasn't that easy. Now this time I remember all the things I did, and I remember all the things Sam said, and all that put together means I can do it this time, no big deal. That's usually how this works. Okay. Video formats. So I said we would talk about this in the future. What types of video files do you want to use when you're making video for QLab? It matters more than for audio. For audio, it's easy. Use AIFF, WAV, core audio format, or MP3 or MP4. And it turns out that that's almost all audio files are in one of those formats. You actually have to go out of your way to find an audio file that's not in one of those formats. So you're pretty much good. For video, the most common file format for video these days is actually one of my least favorite. So that's why we have to have a little lecture here. The short version is, these are the types of files that I want to talk about today that are the most relevant to QLab. And my attitude towards them is basically that. ProRes 422 proxy is the first format of video I want to talk about. It is, it's a format that was invented by Apple. They make large file sizes. Chris wants me to stop.
Sorry, our NDI app, when we adjusted the region, it got stretched in a funny way. I think we need to somehow reset it. There it is. There it is. Thank you.
Yeah, you bet. I love streaming. Yes, I do. ProRes 422 proxy ProRes 422 is a family of video formats that was invented by Apple, designed largely around the. They're designed as what are called intermediate video codecs. Your camera shoots in one form, you edit in another, and then the customer receives the final edit in a third form. This is an intermediary codec. Then it turns out that the codec is really good, and so people started making cameras that can shoot in 422. All right. So Blackmagic and a few others make cameras that shoot directly to ProRes 422, and that's pretty groovy. But that's neither here nor there. ProRes 422 proxy makes pretty large files. If you have a video that you've bought from Pexels or wherever, and then you re-encode it as 422 proxy, it's going to get big and you're going to be surprised by that. Don't worry about it. No big deal. It has really nice picture quality. There are no ugly gradients, but it does have soft edges. That is its Achilles heel, is soft edges. The truth is that those soft edges are usually not a problem in a real theatrical context. I'll talk more about that in a sec. You don't need a lot of GPU or CPU power to render and play back ProRes 422 proxy, and it's hardware accelerated on Apple Silicon, but you do need plenty of memory because it's a large file. The codec itself is free, but the only way to gain access to it is through Final Cut Pro, Motion, or Compressor, which are Apple's video tools. There is sort of a roundabout, tricky way to do it, and some other media encoding software has built-in support for 422. So you can, for example, if you use Adobe Premiere or After Effects, they can encode directly to ProRes 422 as well. Adobe Media Encoder is one of Adobe's media encoding tools. Adobe Media Encoder has a bug. It has had this bug for a minimum of 20 years. It once in a while generates files that are a little glitchy. No one really understands this that I've met. It is non-negotiably true, and people who have observed it to me are Adobe lovers and Adobe haters and Adobe agnostics. So I know it to be true, and it drives me crazy. The only answer here is just don't use Adobe Media Encoder to encode video. Use the built-in encoding tools in After Effects or Premiere. Or if you do use Media Encoder and you get glitchy playback, re-export it through Compressor. Compressor is only 50 bucks and it's really useful, and I really recommend it. If you're routinely working with video, Compressor is the best tool that I've seen to open any kind of video and save it as any other kind of video, and including some very minor editing tools built into it. So, ProRes 422 LT is one picture quality step higher than Proxy. Even larger file sizes, superb picture quality, no gross gradients, no jaggy edges. The deficiencies of this codec are seldom visible in a theatrical context. Sometimes people look at 422 Proxy and they say, listen, I looked at that video on my $50,000 reference monitor and I found that the edges are soft and therefore I think it should not be used. And I say, and is your $50,000 reference monitor going to be installed in the set to display the video to the audience? Or no, you're going to use a projector, which is in the back of the theater, which is projecting through 60 feet of humidity onto a literally soft surface. So the soft edges in your picture are in fact meaningless compared to the atmospheric effects and the physical effects. Not to mention the fact that I'm front lighting myself, and so there's bounce onto the cyc that's washing out my picture slightly, and my lighting designer hasn't even showed up with the hazer. So your soft edges you see in your perfect pristine studio setting are unlikely to be relevant in an actual live context. It's the same thing you say to folks who are obsessive about sound quality, about their recordings, and then go to a theater and then are playing through like an amplifier that buzzes. Like, I mean, okay, but the whole thing only looks as good as the worst looking thing. That said, feeding garbage in, you get garbage out. So you want to start with a good picture, but you needn't obsess over it being a perfect picture. That's my point. It has the same CPU, GPU, and RAM storage as 422 Proxy. You don't need that much CPU or GPU. You do need a good amount of RAM because the file size is large. Photo JPEG is an interesting codec because it's very flexible. When you render a photo JPEG movie file, there's like a slider that's called quality. And it's a scale from 0 to 100, which I assume is % good looking. I don't know. When the slider is all the way to the top, the picture looked great. And it requires a lot of system resources to play back. When you set the slider lower, you use less system resources to play, but the picture doesn't look quite as good. I think that very high quality looks superb and very low quality looks terrible, but it is subjective, and it really matters what kind of imagery you're rendering. If you have a Mac that you are pushing to the limit, you can consider using Photo JPEG, render like little 30-second clips at 100 quality, 90, 80, 70, 60, 50, 40, and play back these clips and use the clip that has the best picture quality without overtaxing your computer. So you may be on one particular setup, it's like, oh yeah, 70 works great and looks fine. Maybe 60. Now, this part of this lecture is getting rapidly outdated because the cheapest Mac you can buy new, which is sitting on the desk in front of me, would never even need to be thought about this way. Until you're like, what are you actually doing? Oh yes, I'm playing back 12 8K videos at the same time. Like, okay, we'll talk. But mostly, this is kind of an outdated idea, and you should just render it in ProRes Proxy and get on with your day. H.264 and H.265 are interesting and valuable and technically sophisticated, and they made a really big advance in the field of video that was very important. Some say H.264 and 265 looks better than Photo JPEG. I disagree. I think it only looks better than crummy Photo JPEG. H.264 is hardware accelerated on Macs all the way back to the early 2000s. So there was a time where H.264 was a great choice if you had a really pokey Mac. H.264 and H.265 are temporal codecs, and this is the cleverness. Just like MIDI timecode is 1, 2, 3, 4, 2, 2, 3, 4. So too is H.264 and H.265. When you encode video that's 30 frames per second, the first frame of every second is a full picture of all the pixels in the frame. Then the next frame is just the pixels that changed. Then the next frame is just the pixels that changed. And this keeps going until you get to the end of the second. And then at the second, the first frame is the whole frame. Okay, cool. That's why YouTube runs so well even on crummy internet connections. Because it can just pipe down a lot of this data really quickly, especially when so many YouTube videos are a really nice static shot of a very well laid out room and a person in a small percentage of the shot talking and holding more or less still. It's perfect for that because all those pixels don't change. Just these pixels change. But try to scrub ahead, try to scrub back, no good. Play the video faster or slower than normal, no good. H.264 and H.265 are perfect codecs for internet delivery. All of their good powers are designed to make internet delivery, streaming delivery, ideal, but all of their deficiencies come into play when you use it in a live playback context. So while it's technically compatible, it's not recommended. Yeah?
Is that the reason for like the confetti effect? Do you know what I'm talking about?
I don't know if I do.
When you're watching a video on YouTube and like you watch like Macy's Thanksgiving Day Parade and they have the reporter and then they like quickly cut to like a wide shot and there's tons of confetti, the quality of the video just
Plummets. Yes.
Because they have to refresh so much.
Yes, that is the
Because
reason.
there's so many pixels changing. That's okay. That makes sense. Yeah.
More sophisticated versions of more sophisticated temporal codecs, I think 265 might do this, dynamically decides how many frames should be full encoded frames and how many frames should just be difference frames based on the picture content. I'm not certain of that. Check my work. H.265 is definitively better, the same way that MP4 is definitively better than MP3 for audio. It just sounds better at the end. No discussion. Or discussion, but you're wrong. Like you are wrong. MP4 and MP3 encoded at the same bit rate, MP4 sounds better, non-negotiably true. Or MP3 and MP4, the same piece of audio encoded so that the two file sizes match, MP4 sounds better. It just does. And the same thing is true with H.264 and H.265 video. One is just better at the end. But I don't know if that exact thing that I said about the dynamic keyframes happens to be one of the things that makes it better. I'm not certain of that. I do know that some video formats and some video encoders can dynamically set keyframe.
This is a little bit of a nerd sidebar, but the confetti question, and it helps our collective deeper understanding of what's going on with video. You know how I talked yesterday about the Nyquist theorem and about how many samples per second to get high frequencies? So all of that math is still true for video because video is two-dimensional signal, not one-dimensional signal. So if you're curious about this, it's fun to look into this. The same math that compresses audio signals, those same principles are at work for video signals. So if you have an image that has in an image, what is high frequency information? Confetti. Because it's a lot of changes from light to dark to light to dark in a short space of the image. That's high frequency image information.
It's frequently changing.
And it's frequently changing in the image. So you'll notice this when you're saving, like if you take a photograph and you're trying to figure out why the file size might change dramatically depending on what's inside the photograph, it's because how much high frequency information in the photograph will determine how much file storage it takes to recapture and recreate what's in the image. If you've got the compression math is doing the same stuff. So if you've got mostly big fields of color, there's not high frequency information, you can compress that out and it still looks pretty good. If you have lots of edges, lots of high detail, lots of grass, lots of leaves, confetti in the air, then that's high frequency information and you need a lot more data to recreate it and not be fuzzy and blurry. So exact same math now with images instead of sound.
I'll go one step simpler and say, let's encode a piece of text. And the text is 75 copies of the letter A. So you just encode that as A times 75. Okay, great. Little tiny piece of information. I send it to you. You can decode that real easy. But if I randomly mash on the keyboard for 75 characters, it's much more difficult to find patterns that you can encode down into a shorthand version. So I have to send a larger amount of information to you for you to decode. How I know for sure that there is someone in charge at HBO who doesn't know anything about video? Because when HBO went to streaming, did they change their opening logo slate of the white TV snow, which is a custom designed image to foil streaming quality, right? When you have a good, strong internet connection and you watch something on HBO, you know, if you're binge watching something, you watch the episode, then you see the title slate for the next episode, and then you watch the episode. So when I watch, you know, whatever, Game of Thrones, first of all, it has to be a very, very dark room because the dynamic range of Game of Thrones is like 6. Black to deep gray. That's an aesthetic choice which reasonable people may differ on whether it's a terrible choice or just a bad choice. But when you go through the whole episode with a good, strong internet connection, it's all crisp and beautiful and everything looks great. And then the moment you hit the next HBO, that slide thing with all the snow and the HBO logo, it looks like your stream drops. Everything looks blocky and chunky and something's wrong. And you're like, oh no, did my modem need to restart my router? No, it's just that that white snow image is uncompressible. And as a result, it looks terrible, even on a good internet connection. That's how you know for sure that someone who's in charge at HBO doesn't understand anything about video.
What should they have done instead?
They should have recreated that image, I think, to be a more digital version. At minimum, they should have taken the block size of their compression algorithm and made each block of the snow animation that size. So that the chunky, gritty effect that you see would be aligned with the grid of the noise in the image. I think that would have looked pretty hot. Or they just, I don't know, use a little imagination and come to a new version of HBO that is new and that doesn't call back to a picture quality. Like my daughter, who you've been hearing, she's never going in her entire life to turn on a TV and see white snow because that technology is gone. Analog transmission over the air and the possibility of switching on a television that's tuned to a dead air station, that just doesn't exist anymore. And that snow is a hearkening back to something that doesn't exist and the reference point is gone, right? What do you say when you end a phone call? What am I doing? Hanging up. How many people have hung up a phone recently? On what? We don't hang up the phone, we turn off the phone, or I don't know what. But hang up is this weird, like, vestigial thing. But the handset no longer hangs on a hook on the wall like it used to. The save button in Microsoft Word, it's a little disk icon. Young people look at it and say, excuse me, what is that? Why does it mean save? And it's a reasonable question. I have no idea why it means save. Oh, I guess it's a floppy disk. What's a floppy disk? And why is it floppy? Well, there's floppy disks and there's hard disks. Well, actually, there's neither anymore. There's solid state disk. Well, what's the difference between hard and solid state? Hard seems kind of solid. It all is like these metaphors on top of each other, some of which have the original reference point is gone. So the HBO snow for me is like, okay, I get it, but it both doesn't make any sense and looks like specifically terrible with online streaming encoding. So that's just my opinion, but it's interesting to think about how those two things interact exactly. ProRes 4444 is one of only 2 moving image file formats in QLab that has alpha channel support. If you have a moving image video format and you need transparency, this is one of the 2 that you need. ProRes 4444. It's a mouthful. Huge file sizes, truly huge file sizes. It needs the most system resources of any of the video formats we've talked about today. It looks terrific. Is it pouring? Yeah. Okay, great. That was not in the forecast recently. It is very, very hard to see the deficiencies of 4444. All but the most trained eye will be unable to tell the difference between ProRes 4444 and truly uncompressed video. HAP and HAP Alpha are the last 2 video formats that I want to talk about as being supported in QLab. They're interesting. They were invented by Vidvox, which is a software outfit that publishes the excellent and very complicated piece of video software VDMX. You can think of VDMX not so much as a program as it is a toolbox to build your own program to do VJ stuff with. They were sick of trash talking H.264 without having something to suggest as an alternative, so they invented HAP. It looks as good or better than ProRes at equal file sizes. So if I have a 100 megabyte ProRes 422 file and a 100 megabyte HAP file, the HAP looks at least as good, usually better. The performance on equal hardware is 2 to 10 times better than ProRes. So even though my picture quality is equal, the same computer that can play back 2 ProRes 422 files simultaneously without dropping frames will be able to play between 4 and 20 HAP files of equal resolution without dropping frames. It's very, very impressive. It needs third-party tools to encode, and these tools are not intensely maintained, so it can be a bit of a workflow hassle to use HAP. You cannot just grab a video file that is encoded in HAP in the Mac OS and hit spacebar and preview it. When you do that, you will just see a thumbnail that's the first frame of the video. It's a bummer, but it's not directly supported by the Mac OS. You've got to use other tools to do it. That's just true. And that's sort of a pain in the neck. But it's very, very groovy. So if you're willing to do the extra administrative work to deal with it, you can really pay off big. If you're trying to do a very video-intensive show on a lackluster computer, you may find that using HAP or HAP Alpha, which has transparency support, can get you over the threshold of the amount of playback that you need to be able to do. That is Moving Image Video Formats lecture. Are there any questions? Though you did a great job of interspersing your questions, so I applaud you. Still images, it's even easier. PNG, JPEG, GIF, TIFF, the end. But use PNG or JPEG. Just don't run yourself in circles doing weird things because GIFs are weird. Animated GIFs, if you drop them into an image playing program that is expecting a still image, can act funny. Some people like to use PDFs in QLab. PDF is a mysterious file format full of eldritch horror. You can have code in a PDF. You can have scripts in a PDF. A PDF can have an embedded web server in a PDF file. Just save yourself the trouble. Make a JPEG, make a PNG, and get on with it. TIFF, if picture quality is of the utmost importance, but TIFF file sizes are also very large. But that's still images. It's really a lot more straightforward. Okay. You running? Yeah.
You're doing great weather.
Great weather, right? Yeah. This is my mid-Atlantic rainstorm, no thunder. Yeah. Camera queue. This is a camera queue in QLab, which is using as its source the FaceTime camera on my laptop. The laptop is running QLab. The output of that copy of QLab is an NDI feed, which is going over our private Wi-Fi network that this computer has access to. The camera on the Mac is playing to a camera queue. The camera queue is playing full screen to an NDI feed. The NDI feed is being picked up by this computer, and that NDI feed, Sam's laptop, Saturn, Sam's laptop NDI. Saturn is the Mac OS name of this Mac. Sam's laptop NDI is what I named the NDI feed inside QLab on this Mac. And that appears as the video input for this camera queue. You can see the latency is mediocre. The picture quality is superb. Or as superb, oh, the latency is worse than mediocre. The faster I move, the less happy it is. But the picture quality is really, really good. This is an M4 MacBook, which is Apple updates the camera in their laptops basically once every geological era. This is the most recent camera, and I think they actually did meaningfully improve its picture quality. Not a ton, but a good amount. And so you can see, individual beard hairs. It's not just a mushy beard space. And of course, you can see the picture behind me, and the letters are fairly crisp. So the picture's doing a good job, the camera's doing a good job, and NDI is doing a very good job of encoding the picture quality and sending it over there. The reason the choppiness is because we are really slamming the network in this theater with this particular demo. So I'm going to move on from that. We can also use the NDI cameras, which are already being used for the stream, and therefore not tax the network extra, because this NDI stream is already being supplied, fed into the network. So I'm just taking a second copy of that out, so the network is not now being extra taxed. And to show you something about QLab, I can add another copy of the camera. QLab just takes the pixels in once and displays them twice. So these two cameras, however much latency they have, the two of them remain perfectly in sync and will always. I can even add another 2 copies, and all 4 remain in sync. Right? Piece of cake. In a camera queue, you have the I/O tab, which has a video input. And here we choose one of the video input patches, which we talked about earlier. It has audio input optionally. And it has, in the case of NDI, the NDI stream. No, let me explain this better. If a camera queue is using a patch that uses NDI video, that camera queue can only accept audio from that NDI stream. And if that NDI stream has no audio, then that camera queue cannot accept audio. If, however, the patch for a camera queue is using any other form of video, you're allowed to use any audio input patch on that same camera queue at the same time. So let's, for example, go into Workspace Settings to Video Inputs, and choose this Ultra Studio Recorder 3G. In this case, during lunch, Alex swapped out one of the Blackmagic output devices for a Blackmagic input device called Ultra Studio Recorder 3G. And Chris, this is Chris. Chris loaned me the use of his lovely Sony. When this camera is on and running, it is just different. And I have an A7 III. This is an A7 IV. They are just different enough that it feels as though I have never heard of it before, which is really quite something. Well done, Sony. With this Ultra Studio Recorder 3G, I can accept any video input up to HD signal quality in via HDMI or SDI. I can hit the monitor button and look at the live input from my device at any time. Once I'm sure I like it, I can then use that device for my cue. Since I am using anything other than NDI as the source, it is now possible to use an audio input. So if I had a microphone next to this camera, and the microphone were plugged into my Dante device, I could use that Dante device and use main input patch and have a built-in mic cue built into this camera cue. I choose not to at this time. We also, on the I/O tab, have a video output and an audio output side, same as others. The geometry tab looks just the same as it does for a video cue. And the video effects tab looks just the same as it does for a video effect cue. There is no time and loops tab because there is no fixed timeline for a camera cue. So when I run this camera, this is a video effect laden video cue. But I think it might be worth seeing it with no effects for a moment, just to show how much fidelity we can get out of a Blackmagic card. Pretty good. The camera itself is very good, and everything the camera has to offer gets caught by the Blackmagic card, right? This is the way to fly, in my opinion, if you want to bring in real video into QLab and you really care about how it looks. There are also some other fun things you can do. Well, no, we already did that. Hang on. I wanted to point out, someone asked me once about using QLab as like a multicam viewer, and it occurred to me that that is actually possible. Let's see, let's make this. So here's a 4-way multicam display, 4 cameras in this room, the 3 NDI cameras up there and this one down here. And I've got them all 4 playing in quadrants. Or I could spend $2,000 on a multicam view piece of hardware and then slap a monitor on it.
And can I point out again that this is running off the base entry-level Mac Mini? That is not something we would have ever done this class on 4 or 5 years ago. It's pretty astonishing how far the current generation of Apple Silicon has come for everything, but for video in particular. I mean, this is the cheapest entry-level Mac Mini is doing this.
And yeah, and to be clear, we've added a piece of input hardware here that's about $130, which takes the HDMI in from this camera. While this camera is a pretty pricey camera, any camera will do. We also have 3 NDI video cameras that are feeding onto the network. Those are, I think, 1 fairly high-end and 2 quite mid-range cameras. Yeah, they're all AIDA, right? All from a sort of middle of the road. You can get some very expensive cameras which look phenomenal. You can get some cheap cameras which look cheap. The cheapest worthwhile camera that I found is a little security camera for about $200 with a lens. It doesn't look great, but it looks okay. Marshall makes some good, inexpensive cameras. AIDA makes some good, fairly inexpensive cameras. But I wanted to point out that you can actually, QLab can actually be used as a fairly reasonable video switcher. So I've got 4 camera cues here. Each of them is set to play on layer bottom. and each of them has a hotkey trigger. And they're all set to fade and stop peers. So when I hit 1 on my number pad, I get one camera. 2 is the other camera. 3 is the third. And 4 is something I failed to program properly. There we go. So I'm now just using hotkeys to switch between these cameras pretty effortlessly. That one is not working great, and that's because the way Blackmagic turns itself on and off when you stop playback. So I'm going to try a trick where I leave the monitor window for that camera open and see if that keeps it happy. Yeah. Blackmagic is clever enough to notice when it's not being used, and it shuts itself off. And so the monitor window prevents that from, oh, no, not quite. All right, well, you get the picture, though, I hope. And if I did this with opacity fading instead of just fade and stop peers, I wanted to set this demo up as quickly as possible. But if I could instead programmed it so that it faded each camera cue down to 0 opacity but kept it running, then the Blackmagic device would not shut itself off, and you wouldn't get this dropout. I am monitoring the video input, or I'm trying to monitor the video input.
Oh, no, that's the output.
Oh, I failed to do this. I failed to do what I thought I was doing. Yeah, that is exactly what I thought I was doing, and it worked. Excellent. Now, while I'm doing this, I say to you, so now why exactly are you spending $20,000 on a TriCaster? And you say, well, it does nice lower thirds titles, and okay, fine, I can do those too. And that's my video switcher demo. I set it up in 20 minutes. If I set it up in 30 minutes, it probably would have run a little bit smoother, but I wanted to make the point. That's camera cues. Do you have any questions about camera cues? No? Okay, great. Yeah, escape. It's stuck. It won't.
I mean, it's great.
It's great, but but it's a bit much, Sam. Okay, text cues are the third type of cue that generates video output from QLab. We have the Basics and Triggers tab. We have the I/O tab, which you know all about. We have the Geometry tab, which you know all about. The Video Effects tab, which you know all about. But instead of a Time and Loops tab, we have a Text tab where you can type in text. That text can be styled with any font you like. Pardon me, any font you like, any color you like, and any background color you like. Once a text cue is playing, it just is another video cue. So everything works on a video cue that works on, everything works on a text cue that works on any other kind of video cue, including blend modes, right? That's kind of it for text cues. While a text cue is running, its output is essentially a PNG image. This is a demo that I like to do to demonstrate the sorts of things that are possible with tools built into QLab and nothing outside QLab. And I'm gonna open this monitor because I need to look at what I'm doing, and I don't want to keep twisting my neck around. So this little animation in homage to the original multi-plane camera, which was the Walt Disney Company's true magic invention that made cell animation as we know it possible. It was a camera that was used to film animation in which it was filming down onto a series of glass plates. The glass plates were hooked together on a rack that could be moved closer to the camera and farther, and which could be spread apart or brought together to allow the camera to simulate the kind of depth of field effects that happen in reality with a real camera filming a real set. So here we have layers in QLab. On the background, we have layer 1, we have the background image. That is a still image of a mountainscape with a slight blur effect on it in QLab. On a higher layer, we have Snow White herself. On a layer higher than that, we have that oak tree. And on a higher still layer, we have some shrubbery in the foreground. You will bring us a shrubbery. If we want Snow White to walk across the stage, and this is not a perfect simulation of walking because her skirt doesn't billow, all we need to do is use fade cues to slide the other elements the opposite direction, and we slide the foreground elements faster than the background elements. To push in on Snow White, all we need to do is use fade cues to change the scale of the foreground elements faster than we change the scale of the background elements. If we want to rack focus to Dopey, he's back there with a blur on him. So all I really need to do is reduce the blur on Dopey at the same time that I increase the blur on Snow White, which is just, again, a fade cue adjusting parameters of the video effects on these images. I also did a little bit of focus breathing simulation, so I changed the size very, very slightly of the cue, which emulates something that happens in all but the most expensive zoom lenses. To iris out, all I need to do is take a big PNG with a hole punched in the middle, zoom it way large, and then zoom it in and get smaller. The twinkle is just an image that spins, then fades in, then fades out while it's spinning. It's not so much that I think that this is necessarily the be-all and the end-all of making animation, right? It's really not. But I wanted to point out that this animation style, which is a style, allows me to modify those components live in real time as the director gives me notes in rehearsal. Hey, can she walk across the stage slower? Hey, can that oak tree be bluer? Hey, can we replace Dopey with Doc, right? Like, all those things can be done really quickly. What used to require me saying, I'll take that note and I'll go back to my studio, re-edit my original, re-render, wait for the render computer to output, and then bring that file in and see what happens. Not necessary now. All of these fade cues, which we've been using, have been fading a single parameter or a pair of parameters in QLab, much in the same way that we faded audio effects, audio parameters. But we also have the ability in a fade cue to fade geometry parameters of video cues according to a path rather than a curve. The path fading is your old friend now from Object Audio. So here's a rocket. I can move that rocket in a circle by using a fade cue set to a path that fades translation parameters. It fades the X and Y translation together in a pair, moving the object, which is in this case a video cue, around the stage in a circle, much the same way Object Audio worked. I made a couple of demos here for the kinds of different movements that are possible with these 2D fades. Like here's a satellite orbiting the Earth. I wouldn't call it the world's grooviest animation. Here I've got a fade and a start cue in a group. and I'm using the, if I should have set that to hard stop and restart. Here's a snowflake fluttering down, and here we start to see a possibility. I've got two different cues going at once. This one fades the rotation X and Y in a figure of 8. Meanwhile, this cue fades the translation down this line. So we've got two motions going on simultaneously, which helps to generate a fairly natural and not very much computery, programmery type of behavior. This feels really organic in a way that would be hard to do, in my opinion, with single axis fading. Speaking of old-fashioned things, here's a telephone ringing, bouncing around the desk as it rings. It's a series of fades in groups. There's the ring group, which fades in a blur, moves the phone around in a wild pattern, rotates the phone around in a wild pattern, though not very much, and then stopping it, stopping the ring, stops that group, and then restores the translation and blur and rotation back to their home parameters. This one needs work. The plane flies, that needs work. I'm not proud of that, but I thought I'd show it to you anyway. We also have the stereotypical boomerang man, as we all have heard of before, who shows up, throws his boomerang, it comes back to him, and he's gone. That one just shows off really how many different emoji there are. The whole background, these are all text cues for fun. The whole background is just the white square emoji, but it's zoomed very large. The boomerang appears off screen, as does Boomerang Man. Then a fade just brings the boomerang on stage with Boomerang Man. And Boomerang Man has his anchor point set to his left foot. His left foot. So that when he steps down, it pivots around that foot. When he throws the boomerang, it goes in an oval. While spinning, using a single axis rotation, then the exclamation mark appears and then everybody goes away. I've tried to think of a demo that would use as many different switchable settings of the fade cue as possible. And so that one has, I think, every form of fade that's possible in a video cue. And then we have the hole-in-one, which is just the golf ball circling around, working exactly like a real golf ball obviously does. The zeroing in is a series of concentric circles that just gets smaller and smaller and smaller, with the smooth path checkbox checked so that it stays nice and smooth. So there we go. Those are some examples of things you can do with video, ways that you can animate video within QLab that do not require you to go to an outside tool, an authoring tool, and produce media that exactly fits the needs. A lot of the times when I see projection designers struggling to use QLab effectively, who feel as though QLab is holding them back, those very same designers are also sort of passing on using most of QLab's powers. They're passing on using QLab's layering or QLab's translation and animation tools, and instead just basically playing one movie at a time, full screen, with all of the work being done in their nonlinear editor. And if that's what you're used to, I can understand why that's your tendency. But I'm here to encourage you to consider doing more in QLab and less in your editor, and which allows you the flexibility to sort of play around in the playback tool. Okay. Any video questions at all? Any video folks here? Folks who use QLab for video or plan to? Yeah. What kind of context are you working in? You working in a theater? You working on dance? You working in broadcast? Anyone?
Well, I do work in the theater. I work at Hopkins in DC, and we mostly use it for like film screenings and like dance and stuff. However, what I came here for is that we have a media space not open yet, but I want to create a show, like a live tape show, in our live broadcast suite, probably like a news type of show, and I want to build it with QLab.
Magnificent. That sounds great. Do you feel like you're seeing the kinds of tools you need to use to do that?
Yeah, I didn't know so much could be done in this, so this is great.
Because you mentioned specifically working in a broadcast studio, I do want to, I did pass on an opportunity to mention that there is a video effect that you will probably care about a great deal, which is, where are you? Where are you? Ugh. The ordering of these is quite logical, but it's still difficult for me to spot it, what I'm looking for when I'm in a hurry. Linear key. Linear key is like chroma key, but a little easier to get a nice key in an adverse situation. This linear key effect, which can work on either a green screen or a blue screen, will let you chroma key a video cue in QLab live in real time.
I despise that green screen. They also made it for green for whatever reason. It's very stupid, but I'm happy that this is.
Yeah. So if you have a camera on you, that camera comes into QLab, and you're on a green background, this video effect, linear key, will let you key out your background in that camera cue. I'm sorry? Yeah, all in the camera cue. Now, so here we have a sort of a head-bendy thing. In a broadcast context, when you do a chroma key, it keys out the green background and produces what? Black pixels. Or it produces the fill layer that you're using to mix in your mixer. But in broadcast, there's no such thing as transparency, right? But in QLab, what does the key do? It keys out the green in the camera cue and produces transparency. So you can then layer the camera cue on top of another cue in QLab. And then the end result is a key and a fill. Oh yeah, for sure. Yeah. Never mind. It's a bad idea. I was wondering if I project the right green and stand in front of it. All right, let's see if this works. Text queue, nothing but text queue. Or it could just look super weird, right? Yeah. So here's a text queue. Okay, we're going to play it on the QClass stage.
Oh, it's not.
Well, I'm going to shoot you.
We'll need a camera.
Yeah.
I could do a. Oh, do I have an NDI streamer on my phone? Try to give you.
It's going to, the stiller it holds, the better the key. Yeah, I was thinking. Yeah. So.
I don't got that much room.
Oh, am I gonna? Yeah. Oh, because I'm in.
Yeah, I was hoping that you'd be not in the green. Yeah, there we go. Yeah.
You come over here.
Okay.
There we go.
There we go. All right.
Oh boy.
For the camera, we're using the Blackmagic. It says that the Ultra Studio recorder is disconnected. There it is. It's a different one. Thank you.
We're gonna do a weather report from the. It's raining.
Okay, right.
Yes.
Hey, did it work?
No, hang on. I'm just testing the camera. So the trouble is, I don't want this camera to be playing on that same display, right? Because that display is meant to be our green background.
Right.
So I'm going to send this camera to some imaginary other display somewhere. And I'm going to look at that imaginary other display. Here's the linear key without any real work done on it.
What's that?
Put something behind it.
Yeah,
put something-
so what did I put you on? What layer? I put you on intermediary siphon. You go to intermediary siphon 2. The camera needs to be on a higher layer. Yep, good. And then the thing that I want to fill behind him is on a lower layer. So we can put, oh wait, I know.
I was hoping you would be the bear. It's sort of like actually a great key because it's perfectly evenly grained.
It actually is a really good key. Yeah, you're right. Now, this diagonal line is because because the table is here, Alec is also seeing some of the black that's under the lower edge. If you zoom in on Chris a little.
I think I'm
Oh, you are
all
zoomed all the way in, yeah.
Physically zoom.
And then hold it quite low.
Oh, gosh.
And point.
Here, I'll do a selfie.
Yeah, you
Yeah.
gotta, you
I
gotta.
gotta unzoom. Hold on. Technical difficulties.
What's that?
Did I disconnect? Oh, it's just doing a. I pressed the playback.
You press the playback button on the
Yeah,
camera.
it's like showing. Okay. Now we're seeing all. I don't know. We're seeing too much stuff. Oh lordy.
There we go.
Now we're not focused. What's happening?
Manual focus.
Manual focus. Okay, autofocus. Okay, please autofocus on me. Oh no, I got a back button. Focus it. There we go.
There we go.
Oh boy. This is.
How's your forearms?
It's great. It's fun. No, I'm good. Oh right.
There we go. So that works, right? The answer is the linear key pulls the key pretty nicely on the green background.
This is all you gotta do.
And this is, but truthfully, if we were, so what? If we were rear projecting onto the cyc, or if the projector were at any angle that allowed Chris to stand somewhere and be in front of the cyc without the green light of the projector hitting him, we'd have no trouble, right? So there we go. I didn't loop the bear. I don't know why. Of course, the bear itself has green, right? So if I linear key out the green of the bear, and now we can put the Chris and the bear, somewhere.
Oh, space bear.
Space bear. There we go. Chris and the bear both in space. Yeah.
All on an entry-level base Mac Mini. I'm telling you.
Yeah. This is
exciting
cinema
times.
gold. Okay. And Chris got his exercise for the week. Well, at least until leg day. What else are folks using QLab for? Broadcast settings, to try to do a live to tape show. What else are folks using QLab for? Theater. Yeah. Quote unquote, the legit theater, as they call it, for whatever reason. I think, no, legit was meant, never mind. Yeah. Corporate. What kind of corporate shows are you doing with QLab? I'm sorry? Uh-huh. Yep. Great. Are folks finding, specifically video, I guess, are folks finding that the thing that they were hoping to figure out how to do is among the things we discussed? tomorrow, which is lights. Yeah, great, super. All right. What is a good half-hour topic to go next? I think. Yeah, that wasn't my imagination. How exciting. Is the stream kosher?
So far?
How exciting. All right. We've talked about it a couple of times. Chris has been particularly excited about this topic. No, it's great. I mean, I meant what I said. You've been excited about this topic. So I want to talk about hardware requirements for QLab because this is a question we get a lot. And it's a question where the answer is kind of in flux these days and will be even further in flux as soon as Tuesday, depending on what Apple decides to talk about on Tuesday. But I think it's probably the iPhone, in which case we don't care. I mean, we care, but not for QLab. That's it. That's the requirements for QLab. We're done. macOS 11 or newer. This is a great opportunity for me to say QLab is known to work on macOS 11 through the current version of macOS. And if you pay attention to Apple News, you know that Apple's changing their numbering scheme for macOS for all their operating systems to be a year-based number. So the next version of macOS to come out, which is coming out very soon and it has been in beta all summer, will be macOS 26. We're jumping from whatever number it's on right now, 16, to 26. Now, a clever person will notice macOS 26 coming out this month, that's not 2026, surely. 2026 is next year. But Apple has carefully done us a service. The number of the OS version is the last 2 digits of the year that it ought to be before you update your Mac. If your Mac is used for shows, I am begging you not to update to macOS 26 soon. Begging you. macOS 26 is making a lot of changes to the basic user interface of Mac. Some folks might like it, some folks might dislike it. That's not what's important here. What's important here is it's going to work very differently. And because this summer has been such a chaotic beta cycle, and every version of the beta of macOS 26 has been in some way truly deficient, we haven't felt ready to tackle the question of beta testing QLab on macOS 26. And so we are not yet 100% confident about how it will look and how it will run and whether there will be bugs. So I'm just begging you to wait, unless you have no shows coming up and you're willing to tolerate some bizarre QLab behavior. But any version of macOS up until 26, from 11 through 16, good to go. Okay, but really, right? That's not enough information. Any Apple Silicon processor is good enough to run QLab. M1, M2, M3, M4, or any of their suffixes, right? So the basic naming scheme is M, then a number, and then either nothing or the words Pro, Max, or Ultra. An M something or an M something Pro, M something Max, or M something Ultra, all great for running QLab. 8 gigabytes of RAM is a wonderful minimum. Because of the LLM hype and because of the unbelievably bad press that Apple has been getting about their particular approach, i.e. failed approach, to the LLM hype, which in my opinion is actually a perfectly reasonable approach, which is stay out of it until it settles down. But they've been taking heat for it. So new Macs all come with 16 gigabytes of RAM now because you need a lot of RAM to do LLM stuff. So, fortunately for those of us who are LLM haters, as me, the LLM hype has turned the floor for the amount of RAM into more than I would recommend as the minimum for QLab. Beautiful. You need an SSD in your Mac big enough to hold your show, and that's about it. If you are doing video, you need to worry about how many external displays your Mac supports. An M1 or M2 supports 2 displays with an asterisk. If it's a laptop or the iMac, the built-in display is one of those 2 displays. An M1 Pro or M3 based Mac supports 2 displays, and the built-in display on a laptop or iMac doesn't count towards that limit. The M2 or the M4 or the M2, M3, or M4 Pro all support 3 displays plus the built-in. The M1, 2, and 3 Macs all support 4 displays. The M1 Ultra and M4 Max support 5 displays. The M2 Ultra supports 8 4K displays, or 6 6K, or 3 8K. And the that should be a 3. Let's fix that right now. The M3 Ultra supports 8 6K screens or 4 8K screens, which is truly insane. And all of that is separate from displays that use Blackmagic devices or NDI output. If you have one of these monstrously powerful Macs and you choose not to use any of the built-in display support and you just use these, the numerical limits are irrelevant, but the more powerful Mac has plenty of power to burn to drive these. The exact number of these that is supported on an individual Mac is hard to quantify. Most Macs, though, don't have enough plugs to plug more of these in than it can handle. And those that, because of Thunderbolt is weird, it's difficult to get more plugs without weird things happening. But the long and short of it is several. Let's go with several. Does that feel good? Sam, please just tell me which Mac I should buy. If you're doing a low intensity show, quite literally any Mac with Apple Silicon will be great. If you're just doing walk in, walk out, lights up, lights down, very straightforward vanilla, find the cheapest Apple Silicon Mac you can from a reputable source, buy it, never worry. Almost certainly. If you have a high intensity show, except for video, any Apple Silicon Mac with 16 gigabytes of RAM, don't use an M1 or M2 MacBook Air, don't use an M1 or M2 iMac, because they don't have fans, which is cool, but it doesn't keep them that cool. So when they work hard, the temperature rises. When the temperature rises, the processors clock themselves down so that they don't overheat. Other than that, though, any other Apple Silicon Mac will outperform even the Intel Mac Pro. If you're not sure what to do and you can spend $1,000 on a Mac, buy the entry-level M4 Mac Mini and a couple of these and never look back if you're doing video. If you're not doing video, don't bother with these. Just buy this and take yourself out to dinner for the rest. Audio interfaces. I get asked about audio interfaces quite a lot. Motu AVB era devices, those are basically any Motu audio interface built in the last few years, really great. RME is a German manufacturer of audio interfaces. All of their interfaces are named the something face. There's the DigiFace, the Fire Face, the, I don't know, hit me in the face. There's all the RME faces are quite good, but they must be kept cool. Do not put them in a rack together with your amplifiers. Keep them cool and they will last you forever. The Focusrite Sapphire Pro and Claret series, the Focusrite Scarlett Gen 2, which is now like 12 years old. The Gen 1 is like 14 years old. You don't even have to think about it anymore. The Gen 2 and up, great. I really, really like them. The Universal Audio Volt and Apollo, never laid my hands on them myself, but I've read their spec sheet and I've read very good reviews. And Universal Audio in general is just very reputable. iConnectivity makes peculiar but very well-made devices. Highly recommended. And Dante, of course, is no actual audio interface needed, so that's my favorite. Questions here? Anything to add to this list? I didn't even bother putting Metric Halo on this list. Metric Halo their cheap interface is $3,400. It will, on the other hand, outlive all of us, this building and all life on Earth. But $3,400 is a lot of money. Alec?
Buy a Dante recommended Ethernet dongle if you are in the market for an Ethernet dongle.
So, you know, I challenge Audinate on that one.
Great.
I have said, so the suggestion from Alec is, if you're going to use Dante, most Macs don't have Ethernet ports built into them physically. The only ones that do are the Mac Studio, the Mac Pro, and the iMac if you get the expensive power brick, because the Ethernet port, believe it or not, lives in the power brick and is connected to the Mac through the cable that connects the power brick to the Mac, which is a custom cable. It's actually kind of a brilliant idea, because the power brick lives on the floor under your desk, and that's where the Ethernet comes out of the wall for a lot of folks. I think it's kind of ingenious. The Mini does the same thing?
No, the Mini has an Ethernet.
Oh, the Mini has an Ethernet port. Yes, correct. Good. So the Mini, the Studio, the iMac with the more expensive power brick, and the Pro. The laptops do not have an Ethernet port built in. So Alex said, if you're going to use Dante and you're not using a built-in Ethernet port, you want to get a Dante-approved Ethernet adapter, like this one, which is made by Anchor. Is this on their list? Yeah. I have found the following to be so. If you get a good Ethernet adapter, if you get a quality Ethernet adapter, the only problem you'll have with Dante is getting the warning that it's not on their approved list. If you get a crummy Ethernet adapter, it won't work properly and you'll get the warning. But my feeling is that their approved list is too stringent. Because I've used, I have another Anchor Ethernet adapter other than this one, which I know uses the same chip as this one, but it's not on their approved list. So I get the complaining message, but no Dante problems.
I think the approved list is like based on which Ethernet driver it uses built into your Mac. So you probably have one with a different chip inside of it, but it's still probably fine. You're right.
That's interesting. Well, I'll learn more about it, hopefully. I'm a little skeptical. And I've become a little skeptical of Audinate. They're starting to make the move that Dropbox made when they went from being a piece of software designed for people to use and get their work done to a piece of software designed to make Dropbox as much money as possible, which is not something I fundamentally begrudge companies for doing, but it's a little vexing to watch Dante go from making your show as easy as possible is our main goal to making your show as easy as possible is good, and selling licenses to large corporate deployments is also good. It's not quite as confidence-inspiring for me personally. That said, everyone's got to make a living, and finances are complicated. So I'm not like angry about it. I'm just a little hesitant and a little skeptical of the like approved list and what the motivations behind that are. Are they all technical, or are they a little bit socio-political? Speaking of being skeptical, bad audio interfaces. These are audio interfaces which aren't so much bad as audio interfaces which have definitely been the source of many support questions to us. Things made by Presonus, things made by M Audio, things made by Behringer, Tascam, or Avid. I want to specifically point out that when I say I have a problem with Avid's devices, it is because Avid's devices are made first and foremost to work well with Avid's software, which they do. They are well-made devices that do good work with Avid software. Avid's support of other software using their devices is middling. So it's not so much a problem as it is your mileage may vary and it may be difficult to get support. Anything without balanced outputs is not recommended, in my opinion. This is the distance you should trust an unbalanced audio signal to travel. Unless you are a very tall person, in which case this is the distance. Okay, this is a thing. Once upon a time, there was USB. And it was pretty cool because it was better than what it replaced. And it came in, the plugs came in two flavors. There was the USB-A plug, which was like this, and the USB-B plug, which was like this. and you could tell you were plugging the right end into the right end because they would not fit the other way. This was on your Mac. This was on your printer. Okay, great. But the C in the USB in the USB-C connector does not mean USB, the language computers speak to printers with. It just means that this connector, the USB-C connector, was devised and adopted by the USB standards body as the next connector that USB was going to use, but the same connector is also used for other things that have nothing to do with USB, most notably Thunderbolt. The USB-C connector is the connector of choice for Thunderbolt 2 and newer. Yeah, Thunderbolt 3 and newer. Yeah, Thunderbolt 3 and newer. I'm not going to talk about what Thunderbolt 1 and 2 used. It's complicated. Thunderbolt was a clever idea that some folks at Intel had, where they took the PCIe bus, which I'll explain what that is in a second, the DisplayPort bus, and power delivery mechanism, and bundled it together in one cable. And then for that one cable, they thought, okay, the USB-C connector is a nice connector to use for that cable, and they're right. PCIe is the communications bus that is used in a computer when you have a big desktop tower computer and you put a card in it, and that card's got a connector that's like a zillion little gold fingers. They go into a big wide slot. That slot is a PCIe slot, and it connects directly to the CPU of the computer with a very, very fast connection. The CPU of the computer natively understands PCIe as the way I talk to other stuff. If you have an Ethernet connection built into your old desktop PC, what's probably going on is that the Ethernet connection is secretly a little PCI card that's just not in card form, and it connects directly to the CPU with PCIe as well. I don't know if that's most likely, but it is likely. The good thing about PCIe is it's very, very fast and not that expensive. The bad thing about PCIe is it only works over about that distance, until these clever folks figured out a way to make it work over about that distance. And then they thought, okay, great, now PCIe devices can move outside of the computer. The computer can be smaller because we don't need all the space for all those cards. And the thing out there could be not in card form. So you could have, say, a video capture card that is a little box with a Thunderbolt cable, plugs into the computer, and it connects as though it's a PCIe card in the slot of the card, of the chassis of the computer, and it'll be real fast and real groovy. Okay? Phenomenal. Turns out the electrical properties of the USB-C connector and the USB-C cable are stupendous and ideal for something like that. So we use the USB-C connector for Thunderbolt. Thunderbolt is PCIe. It's also DisplayPort, which is this connector, which looks like HDMI but asymmetrical and slightly larger. It also looks more delicate than HDMI, but that is a lie. It is dramatically less delicate than HDMI. If you go and yank on a Thunderbolt, on a DisplayPort cable, it will not pop out of the socket because it's got these goofy little teeth that keep it in. Whereas if you go and take the same amount of force and yank on an HDMI cable, even odds it either unplugs or pulls the device off the desk or pulls the cable out of the socket, and you just are left with a zillion little gold fingers sticking out, and you've ripped the cable out of the plug. You need to pull the plug out and then either resolder it if you're some kind of self-punishing person, or throw it away and get a new one. DisplayPort is also the lingua franca of video signals inside a computer. The GPU in the computer, the graphics processing unit, when it makes video, and it's like, okay, this video is ready to go to a screen, it sends that signal to the screen in DisplayPort language. If that DisplayPort language wants to exit the computer and go on a cable, it could come to an HDMI connector, get translated to HDMI language, go over the HDMI cable into the screen, and voila. Or there could be a DisplayPort socket on the side of your computer, and then that conversation happens in DisplayPort language. Thunderbolt supports DisplayPort inside that same wire. So you plug USB-C connector into your Mac, USB-C connector into your screen. The screen hollers down the cable, hey, I'm a screen. And the Mac is like, that's dope. I can make this port be a DisplayPort, even though it's actually a USB-C socket.
I'm not a barge.
Not a barge, not a barge. Okay, good for you. It's gonna be okay, and you're gonna get pixels, and it's gonna be lovely. PD, power delivery, is a method where, you know how you plug your phone into any USB socket on the planet and it charges? That's because the base design of USB includes some stupid, deliberately stupid charging circuitry. Okay, and that's phenomenal, right? Because that's how you charge your phone anywhere in any USB socket. Power delivery is like, let's take that, make it 5% less stupid so that we can charge devices that need different amounts of power. So my laptop wants 140 watts of power if it can take it. And so it has a little bit of cleverness when you plug in a power cable, a USB-C cable, it hollers down, I'm not a barge and I want 140 watts. And if the power supply on the other side knows what to do with that signal, it supplies up to 140 watts of power. But the really smart thing is that if the power supply doesn't know what that message means, it just continues to supply the 5 milliwatts, or I can't remember how much the base wattage of USB is. The very, very small trickle charge. 500 milliamps, right. It supplies 500 milliamps, no problem, and then trickle charges the Mac very slowly. Yeah? So that's power delivery, really clever. So we bundled 3 kinds of things that people really super duper want and use all the time into one skinny little cable, and we gave it a really convenient connector that is physically robust, impossible to plug in upside down, and puts the bit that wears out in the cable, not on the connector built into the Mac. So when your USB-C connector starts to get flaky, the part that has worn out is the part in the cable. You can ditch the cable, get a new cable, plug it in, and it will feel brand new again. Groovy, brilliant, everyone's happy. And then the USB folks came along and said, well, we're going to use the USB-C connector also. And we're going to use it for USB 2, USB 3, USB 3.1, USB 3.2, and USB 4. A normal human person might imagine that those are 5 versions of one language, USB. And there you would be tragically wrong. When you plug in a USB 2 device to a computer, a modern computer, that computer's like, oh, I've got to speak USB 2 now. I look up my USB 2 dictionary. It's a whole different story. USB 3, 3.1, and 3.2 seem like they're minor revisions. They're in fact completely different. USB 4 is basically just Thunderbolt, but you're allowed to not be as fast as possible. It's madness. Some of the pins on the USB-C connection are optional. I don't know why. The real reason is if I'm using a USB 2 connection over like this Go box has USB-C sockets, but it's very, very little data that passes across this thing. So it speaks USB 2. If I plug in a USB cable, a USB-C cable, that has only 6 of the 24 pins connected, it will work. But if I try to plug in this Thunderbolt device with only 6 pins, it will not work. I believe that 12 of the 24 pins are necessary to make this thing work, but I'm not 100% certain. Cables which are marketed and branded as being full-featured USB-C cables have every pin connected. If you are not sure if your cable is full-featured, you can use a cable tester. Are these cable testers very easy to come by, you ask? No. No, they are not. Here's one. It looks like a homemade project, because it is a homemade project, not by me, by caberqu.com, caberqu.com. This person 3D prints this little thing, has these little circuit boards made. I got to put it together with a screwdriver myself. It was really fun. When you plug in a Thunderbolt, when you plug in any cable that has USB-C connectors on it to this tester, it will light up a bunch of lights, and the lights that are lit up will demonstrate whether it is a full-featured cable or not. There is a fluke in my particular copy of this tester that means that certain lights don't light up when they ought to. That's because I bought a very early copy of one because I was excited to try it out. But in short, the full-featured cable should light up all the lights on a tester like this. If you don't want to spend time wondering whether you've got the right cable for the right USB-C connector device, just throw out all the ones that don't have all the pins connected because there's no reason not to use them, except maybe the one that you use to charge your phone because it's super thin and bendy. And charging your phone doesn't need all the pins. So, USB-C Ethernet adapters, as Alec was talking about, some of them use the PCIe bus to connect at very high speed to the CPU of your computer, and those are impressively fast. Some of them use USB, which is an intermediary step, and some of those might not work as well as the others. So when you buy an Ethernet adapter, what does it say in the marketing literature? A USB-C to Ethernet adapter. Well, yes, I know it's a USB-C to Ethernet adapter physically, but is it USB-C that uses USB, or is it USB-C that uses Thunderbolt? Nobody knows. Nobody knows. What do you have to do? You have to find out what Ethernet chip is inside here, and then find out whether that Ethernet chip wants to use Thunderbolt or USB to connect to the Mac. It is crazy making. Or you could just let Audinate do the homework for you and only buy ones that are recommended by Audinate. Video can be connected via a USB-C connector because DisplayPort is a technology that is part of Thunderbolt. But also, you can connect monitors to computers using a USB connection, not USB-C, USB, using a technology called DisplayLink, which requires you to install a software driver on your Mac, which converts video signals to USB and connects to low-quality displays that way. DisplayLink is flaky as heck. Don't use it. If you have to get a video adapter, and that video adapter says, to make this work, install software, throw it away, get your money back, do not. Do not be like this guy who learned about DisplayLink in front of an audience of many hundreds, in a beloved annual traditional show that had been happening for decades. And this year they hired me to do some video, and never mind. Ugh is how I felt. Ugh is how I feel now. USB 4 is Thunderbolt 4. The only difference between them is a Thunderbolt 4 device must operate at full speed. A USB 4 device is permitted to limp along at partial speed. USB 4 version 2 sort of equals Thunderbolt 5. And I ask you, of what value is almost equal? All I can say is, look for the little lightning bolt. That means Thunderbolt. It is more expensive. What you get for that more expensive is it always works. If you see the little Solera cactus, that is USB. That is fine for your mouse, keyboard, printer, whatever, low intensity stuff, and probably fine for your audio interface most of the time. But some of the time, it's a flimsy Ethernet driver that doesn't work properly and doesn't pass Dante. Some of the time, it's a lousy video translator that requires you to install drivers that don't work. It is challenging to understand. So my parting words for the day are, USB-C is very cool, very useful, occasionally challenging. Proceed with caution. Are there any questions? Yeah.
Any pitfalls to be aware of? Like I have a M4 Max MacBook. So I think according to your display, I could do up to 5 displays.
Yeah, you're sitting pretty.
Great, but like how do I get 5 displays out of 3 Thunderbolt 5 ports and not worry about bandwidth?
You get a proper actual Thunderbolt USB-C to DisplayPort cable. Thunderbolt 5 can daisy chain, Thunderbolt 4 can daisy chain, but the way that the DisplayPort bus daisy chains itself can be a little odd. Sonnet makes a set of adapters that connect with USB-C to your Mac and provide 2 HDMI or 2 DisplayPort sockets. Love those. Always work.
Is it worth, in that context, like video context, to make sure I'm buying like a Thunderbolt 5 product and not a USB product?
Thunderbolt 4 or 5. Yeah. Yes, it is always for video. Always.
Do I have to work, like, should I prioritize, like, let's make sure I have a couple coming out of this port on this side and a couple coming out of this port on this side, because like a port might have a limit? Or is it like, if I can get that device that you described that's going to spit out a bunch of displays into one port, that's fine, that'll work?
On the M4 laptops, it doesn't matter. On the M1 and M2 laptops, there were a few models where like this side was one bus and this side was the other bus. Now, this is an M4 Max as well. Each of these 3 USB-C ports is its own independent Thunderbolt bus.
And any of them can do all?
Any of them can do all.
That's amazing.
So I put 2 displays here, 1 display there, 1 display there,
And just no issue.
and never think about it.
That's amazing.
Yeah.
Sonnet makes the best Thunderbolt to HDMI and DisplayPort adapters, and on the same page, right next to them, is the Display Link adapter, which you should not trust.
Yeah. Sonnet Tech, products, where is it? Thunderbolt products, display adapters. Thunderbolt dual 4K display port, great. Thunderbolt dual 4K HDMI, terrific. USB-C display link dual 4K, garbage no one should ever buy under any circumstances. USB 3 display link dual, nope, goodbye. USB 3 display link, nope, sorry, goodbye. Use the ones that are light gray on the top and black on the face, not the ones that are black all over.
How much are those?
It's like 200 bucks.
Okay.
I think. 100 bucks. I'm sure the DisplayPort one is slightly more expensive. No, slightly cheaper. 80. Poof. And it's a lock-in connector that doesn't break, so hey. Tomorrow, my friends, is another day. And on that day, we will talk of lighting, and we will talk of collaboration, and we will talk about a bunch of workflow features built into QLab that are there just not for the audience, but for you, to help make it easy for you to work your way through making queues, dealing with queues, and running queues. And Eleanor is very excited about the end of the day. So tomorrow, lighting, workflow, collaboration, fun stuff. Hi. And the Children's Museum for those who are interested. Thank you so much. Thank you, stream folks. And I'll see you tomorrow.